20 years ago, a seed was planted and cared for. We painstakingly nurtured it and weathered it against adversity until one day it blossomed and the fruits of our labor began to show. Today, millions have learned, shared, and been inspired by what our community has produced. We proudly served 21 million users from 204 countries in 2019. For our 85,000 technical articles, code samples, and videos, our 450,000 forum questions, and our highly anticipated conferences and events featuring keynote panels, live streams, and industry experts and influencers, we recognize and reward members for their dedication to the community. Through content contributions and mentorships, we ranked number 2,620 in the world with a reach of millions across our social media channels. Thanks to you, our global community of software and data developers grows stronger each day. For more information, visit us at C#Corner.
Hey, welcome everybody. Welcome to the very first Code Quality and Performance Conference, virtual conference. I'm really happy you're here. And, we have an awesome lineup of speakers. I'm so excited about today. I don't know if you guys have been seeing my tweets this week, but I've been really anxious about today. I'm so anxious I woke up too early, and 7 a.m. is a little bit too early for me. My brain isn't working. So I have my coffee cup, lots of coffee, so I can get through today and present all these great speakers. Before I start, I've been tweeting this that, I've been wanting to do a conference like this, for about probably 10 years. I've really wanted to do something like this. And I just couldn't get enough people that had the passion that I had to put on a conference in person. So I'm really happy that I've been able to I've been given this opportunity to do this virtually for everybody around the world. We have speakers from all around the world. We have speakers of all ages, including our first speaker is only 13 years old. I'm really looking forward to this. And then I'm going to end the conference with my keynote and 7 things that every successful project needs to have. After what happened yesterday with HBO Max, I think some of the developers there need to watch this conference today. So I'm really glad you're here. Let's go through some slides really quick. And because I want to make sure that we start everything on time and end everything on time. So here's all the speakers we're having today. I'm really, like I said, I'm super excited about all of these speakers. And some people I know, some people I don't know. So I'm going to make some new friends today, hopefully. And I hope you'll make some new friends too. And most important of all, I want the speakers to have fun, and I want you to have fun. And I know, it might be in the middle of the night where you are and you're watching it. If you are, I'm really happy that you're doing that. We have some great, giveaways to, encourage you to stay watching live. But everything will be available online afterwards if you miss a session or two. So here's all the sessions we're doing today. I'm not going to go over every single one because we only have like a minute left. And so here's all the sessions. I hope you'll attend your favorites or all of them. I'll be attending all, of course, because, I'm hosting today. But I hope you'll check them all out. I know they're going to be great. So to entice you to kind of, hang out and make comments, in the comment window and on social media, we have some awesome prizes to give away during this conference. We're giving away 3 licenses from Grape City of any .NET product they make, and that ranges from $495 to $895 US. So I hope you'll stick around for those. Grape City makes awesome components. I use Grape City components. I've known Grape City for a long time. I'm actually one of the few Grape City influencers. So I hope you do that. Also, I'll be giving away 2 copies of my coding standards book, which is basically kind of what this conference is all about, is standards and code quality. And that's why I have this book. And so I'll be giving away 2 autographed copies of this. I'll ship it anywhere in the world except for the Middle East. And because I haven't been speaking, I have lots of stuff here that I want to give away. I mean, I want to include in the package too, like bumper stickers and, pins and, I need to clean out my house is what I'm trying to say. We're also giving away 1,000 Stratus bucks. And there's the breakdown of how we're going to do it. So the top commenter will get 300 Stratus bucks. And other top commenters will get $140 Stratus bucks. So that's exciting. And then also for the most creative social media posts, we're going to give away some $50 Amazon gift cards. I wish I could get one of those. And but to win any of this, you need, when you make a comment in the chat window, or if you make a comment on social media, please use the hashtag CodeQualityConf21, because that's what we have, an automated program that will go reach out and pick somebody by random. So you have to use the hashtag, but please make comments. That's what we're here to see how the conference is doing and how you like the speakers. And so please make comments and tweet about this or post it on Facebook and things like that. So that's how you win. So start commenting now. Also, we're also raising money for the kids in the slums in India. India is going through a terrible pandemic right now. And I know you guys are opening up. I don't understand why, since you don't have any vaccines, but we're going to try to raise some money. So please go to this link and donate. I really want to, provide money. If you know me, I do a lot of work, including 100% of the proceeds of my code performance book goes to the Voice of SLUM NGO in India every month. So please go there, donate. I know most of the developers watching, maybe not in India, should be able to help out and donate to help the kids. I've been to the slums in India, and they really need your support. So please help them. I want to thank. I really want to thank Mahesh, who runs C# Corner, who founded and runs C# Corner, for letting me do this conference and approaching me with this idea. And so I'm really grateful that he did that for me. And because, like I said, I've wanted to do this for a long time. And I also want to thank the man behind the scenes, Stephen Simon, who, without him, this conference wouldn't be happening. He does all the work. He stays up through the night, like he will be doing today, to the wee morning hours. I don't know how he does it. Well, he's young. I could never do that now, but maybe when I was his age. But so everybody, please give a hand to Mahesh and Simon for doing so much work to put on conferences like this at C# Corner. Without them, this wouldn't be happening. So please thank them and make some good comments to those two, especially Simon. He does a lot of work for these conferences. And I also want to talk about the Hello World Cookbook. I'm doing a new food cookbook, and all the proceeds will go to the Voice of SLUM NGO in India. And so please go to helloworldcookbook.com and submit your food recipes. I also need some testers and some graphic artists. So I hope you'll help out in this endeavor, because this will keep money flowing into the Voice of SLUM in India. And that's really one of my goals with it. That's the goal for this book. Plus sharing that, software engineers like me can really cook, right? So if you can cook, submit a recipe. I also want to promote really quick my weekly show. There won't be one tomorrow because I'll be recovering from today. So please, I hope you'll check out my weekly show, Rockin' the Cold World, .NET Dave. And we'll talk more about that later. Oh, that's it, I guess. So is our first speaker ready, Pulkit? Yep. Okay. So let's welcome the first speaker, Pulkit, and uh, and I'm really excited about this. Hey, Pulkit. Oh, I can't hear him. Do we have technical
Is it now
difficulties?
audible to you all?
Hey,
Yeah,
hey,
I
Simon. I
guess
thought
now
we are
it's
doing a.
audible to you.
That's okay, Simon. I thought we are doing a video before he comes on. No. Okay. Well, no. Okay. So we're a couple minutes early. So I mean, I'm late. So I'm going to turn it over to you, Pulkit. I'm really glad you're here. I'm excited that our first speaker is only 13 years old, and when I was 13, uh, I was still playing in the forest and with trucks and cars, and I wasn't programming. So I'm really glad you're here. So take it away.
Yeah, sure. So just give me a sec. Yep, I guess my screen is visible to you all.
Yeah, we can see it.
Yeah, great. So I'll be just switching off my camera so that it did not get lag in between. So yeah. So first of all, welcome to this session that is taking your code to next level with open source, basically Git and GitHub. So after this session, if you gain some experience or something else, you can just share your experience on Twitter or any social media by tagging me on at the Pulkit Singh Dev. And yeah, so my name is Pulkit Singh, and I'm a 13 years old self-taught programmer. So I'm currently passionately contributing towards communities, open source as well as hackathons. And currently I'm working as an author at freecodecamp.org, and even I'm one of the 162nd event ambassador at deeplearning.ai. So apart from this, I have been giving, you can say, sessions on basically open source only at various, you can say, conferences and etc. So it's like even I have been contributing in 50 plus communities as well as hackathons, and like you can see, I have 4 to 5 of my own communities as well, which include programmer seniors and group and etc. So now let us get started with our session. So basically, when we talk about open source, it's something like you can say any project or software's original code is made freely available and maybe you can say redistributed and modified according to the requirement of the user, or maybe you can say some other folks can contribute in it so that the project's owner can gain some more features on their project, right? So it's like basically programmers have more control over that kind of software and can examine the code to make sure it's not doing anything you don't want it to do, and even likely fix they all can fix the bugs as well. But what about others? It's like open source is for everyone, and even though if you are someone who is from who doesn't have any you can say any background in tech field, even they can get started with open source and can gain very much experience as well. So like for others, you can make your own projects, blogs, etc., and make it open source, and even let others to contribute in it and even make some changes in it. And yeah, there are many more advantage, and even in the last, if possible, if I get some time, I will try to include some of the programs that even open source, not like other open source programs that you can take benefits from. So it's like you have some other advantages, like you can get you get a very large community of like-minded, inspiring people, and yeah, you even get some essential support and help there. So basically, I will be now telling you what is Git and GitHub, and by likely differentiating both of them. And it's like Git and GitHub are one of the platforms that majority of the developers or programmers use for getting started with open source. So yeah, let's get started with it. So first of all, what is Git? So in simple words, Git is a version control system, and it can be used with various tools or locally on your computer to help you track of changes in your code projects as well. And you can maybe like think of like a Google Docs for code, but better, right? And in the same way, GitHub is a platform for code collaboration, and GitHub uses the Git for the version control and provides you all these sorts of, you can say, awesome collaboration tool. And even likely we have got some new features in it that I would be including to take your code to next level. And apart from this, basically you can say GitHub is a cloud platform for working on your open source project. So now let us discuss why we need version control here. So like I will tell you it through through an example. Like while you are freelancing, you get a client and like you are developing a website, and at that moment, like you create all the things that the user wants, and then he or she tells that he needs some other updates in it, and you just do it. And after that he says that the past one was better and he wants the past one only. So at that moment you won't be able to get this the last version of it, right? So for this we have version control system that can help you in having all the versions of your, you can say, code and anything, and it will help you by just not having it in one file, but it will even not create other files for version control. It will have the same and it will continue versioning your code or any project, right? So like collaborators can work in parallel and even merge their changes automatically instead of manually comparing and the differences between a file, right? So yeah, first of all, let's make an account there on GitHub. So if you are a student like me, I would you all can go on to this link, that is education.github.com. And if you are someone who is a developer or something like that, you can go on with github.com. And I would probably prefer to go with github.com first, because you will need to create an account there first and then you can go with any other things. So now let us explore GitHub here. So just let me stop my screen share once and reshare it to the another screen. Mm, just a second. Yeah. I guess it's now visible to you all. Can anyone give me the confirmation once?
Yes, Pulkit, it's visible.
Yeah, it's now visible too. Yeah. So like this is the main website you get into once you have logged in or signed in to the GitHub. And basically, now let us explore it and become more friendly with the UI of it. So first we have a pull request tab where we create pull request for contributing in other projects. So basically, pull request means something like like you want to contribute in someone else's project, and you just change some of the codes of it and just ask for taking your code in the main project as well. And after that you can see issues tab as well. It's something like same, just like people create an issue that there is some bug in in the project or something like you can say something related to it, right? So this is for the same. And then we have marketplace here that probably helps you in integrating some of the apps and actions. So basically GitHub actions is something I very love, and it's like best way of getting started with automation. Even it's like you can go on with automation in GitHub as well. So after that we have explore tab where we can explore some of others projects as well, and then a search tab for searching some of the projects. And then now we have a notification tab for seeing all the notifications. I have cleared the all. And then a plus sign for creating a new repository, meaning a project, and importing a repository the same way. And then we have new guest organizations, so we can even create some organization and even likely new projects. So projects are something different from repository that I will be including here after some time. So now let us see, like here we go with our profile. Like once we click on this navbar, we get to our profile. Then we have our own repositories, then code spaces, which I really love. And basically I guess many of you all would be like more knowing about if you are a developer, you would be used to with VS Code, right? So currently I'm not having that much access on it since I just cleared the all access, since it's a you can say beta feature for right now, but would be developing more. And yeah, just let's wait for some more updates in it, right? So at that moment you can see like GitHub has collaborated with VS Code to bring up you something, GitHub code spaces where you can work the same like VS Code online on the online platform, and even use the Git there as well. So this is something I really love, but currently I don't have that much access to it. So yeah, let's wait for more development in it. Then we have some of the organizations, like I'm in the part of many, so let us skip this right now. So then we come to projects. So basically, when we talk about repositories, it's something like you can say your main code base and something like a software. But when we come to a project, it's something like you have a project and you are using that software for creating this project. Like I was currently working on some of the one, and yeah, it's something like even to-do list, or even we have some of the other software for the same, but GitHub has already included it here. So yeah, that was it for knowing about this. And then we have your sponsors, that's something about, even you can get some sponsor from others for your project as well. And then yeah, like you can even work on some of the other things. I won't be getting into the other stuff since it may leak my data. So let me just get back to our main slide again. So let's stop the screen share once, reshare it, and yeah, it's now sharing. Yeah. So now let us get started with the developer workflow. So before we get started, I want to include one thing, that is, if you want to get started with command line interface or even a development work, I would probably recommend it for getting started with Git and GitHub, since they if you being consistent on that platform, I can probably tell that you will be able to get the understanding of how the collaboration works in a team. You will be even understanding the main command line interfaces and how the backend works, and even the worst core concepts you can even ever think, right? So now let us understand the developer workflow here. So first you will need to fork someone else code for contributing in others project. Like a forks is something like your own copy of someone else repository, and then you will need to create a branch. The branch is a parallel version of your copy where you will test your own changes, right? So like branches, as I already included, making a branch allows you to edit code without accidentally breaking the working version of that software. So now you will need to stage your changes as you go. When you are happy with them, you will commit them. And basically, stage means add to cohesive or a group or bundles of revisions, and commit is something like a group of revisions you want to officially add to your branch. So if you want to add your code to someone else's project, you will open a pull request, and if they approve it, they will merge your branch into their master branch. So here merge means to officially add the changes from your local branch to the master branch or the main branch of the repository, right? So great. And yeah, that's how you work with Git and GitHub. So let us try this practically on GitHub. So network activity workflow, like first of all you will need to fork the repository you want to contribute in it. I have just given an example here. And note, this is only necessary if you are not a collaborator on the project, or it's your own project. It's only if you want to contribute in someone else's project where you don't have the access. So now you will create a branch like something like this and etc. And you should always try to name branches with your name and what you are doing, so that even the you can say the owners and the code maintainers can understand what you are doing there, and then open the any of the file you want to contribute in it, and select the edit icon that would be available to you at the right corner side, and it looks something like a pencil. So add the name of add the code and the changes you want to make in, and then scroll to the bottom to commit the changes section, and just click on it. And if you want to add a descriptive message, and select commit changes. Now you will return to the main page of your repo, and just select pull request. And because this is a simple pull request, you can simply create a pull request. If you were contributing to an open source project, you would want to be very descriptive about the changes you want, since when you contribute in open source projects, it's necessary to write all the description of what you have made the changes, etc., so that the maintainers can just understand what you have did, and then they can check the changes, right? And even it gives some good effect to the maintainers about you as well. So then after that, ask someone else to comment on your PR, and you should also comment on someone else's PR too, since it's not only about contributing in others projects, but even letting others to contribute in yours, right? So you can find other pull requests by selecting the pull request tab on the repos homepage. And yep, this is what a pull request looks like for someone who has write access to a repo. The organizer of this workshop will likely merge the pull request, and your changes would be added in it. And like in between, it's like something common in while contributing if in any of the projects is like when a file has multiple edits, right? It can be unclear which change should be committed, and this is where a conflict happens in the GitHub itself. So here I will be providing you with a conflict resolution. So for that, just go to your commit you have done, and just remove the code showing with this markdown, and then you can just remove that up, and then you are good to just commit it up, and it will most probably resolve the your conflict. And yeah, amazing. So now you know how to work with GitHub in the browser, right? The next section will teach you how to use GitHub on the command line on your computer, which is something really awesome, and really it even includes some of the really core concepts. So yeah, so first, once you start working on projects that are more complex, you might find that you prefer using your own local coding environment with GitHub, right? So let's learn how to set that up. And first, you will need to install Git. So here when you need to contribute in open source project through Git, you will just need to install it. If you have already installed, you just need to check it once by typing git dash dash version in your terminal or any of the terminal application. So after that, it should show some output like this. If it's not something like that, then this means you don't have Git installed in your device. So for that, just go to this URL, that is mlhlocalhost/install git. And if you do not have Git installed, navigate through the URL above, and just select your operating system. Basically, it's now available for macOS, Windows, Linux, as well as Unix. So open the installer and follow the instructions. It should be fine to select all of the default options. Open the installer and follow the instructions. It should be fine to select all the default options, but except for the one below that you can see here. We recommend choosing your preferred text editor in this step, but yeah, even it's up to you. So after that, restart your terminal or PowerShell or git bash and run the command below again. So after that, it would probably show the version of your git, and this means you have installed git in your you can say device. So yeah, awesome and great one. So let me just check the comment section once if we have some of the doubts in between. So yeah, even you all can just note down your comments questions, and then in the last we can have for 5 to 10 minutes Q&A session as well. So after this, you will need to configure Git by just entering git config dash dash global user name, and then you will need to enter your username of GitHub, and then same for configuring your email address with git config dash dash global user dot email and then your email ID. So you can use the two commands below to likely double check that you have set this up. So just enter git config user.name or git config user.email, and it would enter up the same stuff you have given the input in the last slides, right? So now let's cover some useful commands of it. And the workflow from the command line has few added steps compared to using GitHub. So you can clone any repository you have access to using git clone, and then you can create a branch with git branch name, after that the name of the branch. Now after you make changes, you will use git add to stage your changes. So basically clone means to copy a repository to your computer, but not the same repository as we talked about it in the last slides. There are some difference when we talk about git and github, but yeah, majority part are even same. So now stage means saving your changes so they are ready to be added to your branch, and you will use git commit dash m and then the commit message to add changes to a branch. And when you are ready to push your local changes to your repository, you will use git push, right? So dash m is a flag for message. That means, like you can see, um, that means whatever comes after dash m is a message explaining your commit, right? So these all practices can give you a whole bunch of experience of how the you can say all collaboration and teamwork goes on in the practical world, right? So basically you will learn something in the practical manner to enhance your knowledge, and it's something like a comment. And after that, push is something like add the changes on your computer to your GitHub repository. And these are some of the key terms that helps you to understand. And yeah, you can make a pull request and have your PR merged on GitHub like before, and you can pull changes from GitHub to your local repository as the same. So you might feel a little confused by committing, staging, and pushing your changes, right? So let us explore a visual representation. It's probably not my desk, okay? So I just got it through online. So yeah, and so first of all, let us talk about working directory. This is our working directory, and where the writing happens. This is something similar to coding and saving your work here. And then we have you can say our staging area, like when you're happy with a group of changes, and when you're happy with your changes, you just stage them there or stack them there. And like once you're done with all these stuffs, here is our repository. And when you're happy with your commits or the work you have done, you commit them to the main repository. So once again, this is not my desk, okay? And here's another visual representation of what you just saw. So we have a working directory, your workspace or local on your machine, where you get add to staging for the staging, saving your draft in the staging area. And once you are happy, you can get committed to the final repository, and or even you can say permanent repository. So great, let's try it in practical manner, right? So let me just check once. Yeah. Okay, so we were talking about first we'll need to create a repository on GitHub and then work with it locally, right? So just go to your profile homepage and just click new, and it will create your repository. So at that moment, you should just enter your repository name that you want to add some description for it. It's optional, but and then you can check the set up the availability of you viewing public or private according to your requirements, and then you can initialize the repository with a readme file that what I recommend. And then if you are in development area, I would recommend to have git ignore file and even a license, since git ignore file says something that if you have some stuffs that you can't share and that are private data, so dot get ignore helps you to do the same. And a license helps you to don't get your for getting your copyrights for the project, right? So if this were a code project, you would usually add a .getNow file, as I probably mentioned before, and then you can create a repository by clicking on that button, that is create repository, and then you will be redirected to the homepage of for your new repository. So just click on clone or download and just copy the URL that is provided here as the same it would be, and then click the clipboard and copy it and back to the terminal or git bash and just enter git clone and the URL that you have, and after that it would show something like cloning into repository name and etc, right? Even I can't I can't remember these things. This is something different. Yeah, but it's even normal, I guess, but yeah, let us leave it. And then it's important to note that you did not simply download the code, right? So you cloned a Git repo. This means a Git repo comes with a special folder called .git, right? So you don't need to know a lot about this folder, but just keep in mind that it connects your local project to the project on your GitHub. And this means if you delete this .git file, it would be something like your connection will be lost from your git this git repository to the github repository, meaning your local files to the github repository, right? So let's make some changes in your clone project, right? We won't be waiting for something like just seeing what's going on, right? So note, if you did not name your repo hello world, it should show something other than this, and just enter cd and then your repository name. Okay. Okay. Yep. So and like we are going to make some changes and just for now leave it, and you can do these things through some of these commands, and even there are some like entering your code editor's name and it would do the same. And yeah, then you can do some stuffs like this, and then just do git status for seeing the status of it, and then just commit your with the first commit message, and then yeah, just git push for contributing in your project, and in between it would show a password, and it will need to configure again github username and password. So yeah, just do this, and while you are entering password, it it won't be you can say it won't be viewable to anyone, even you, but even though after that you will need to just click on enter and it would work. So yeah, that's how it works, and just select compare and pull request at your GitHub and just make the pull request there, and name your pull request appropriately. Then select create pull request, and yeah, that's something we are likely done up with. So let us have a quick recap of it. Like, Git is a version control system allowing you multiple people to collaborate, and GitHub adds features to Git and provides a web interface, right? And command line Git lets you propose changes without the web interface. So yeah, and like for now, I guess we can just finish it up here, since we even need to go with our schedule. So should we go with you can say Q&A, or just that much is enough? If we have some question, we can continue, or that's the end.
Well, thanks, Pulkit. That's that you know more about GitHub than I do. So can you run my repositories for me now?
For
I
sure.
I really appreciate you being our first a speaker on the conference, and it's great meeting you. And I hope that the next time I'm in India, we can hang out and chat, because I'd love to talk to a 13-year-old about programming.
Yeah.
I know somebody's
Yeah.
son. I know somebody who has a son who's 8 years old that can't get enough learning on programming. He's 8 years old. When did you start?
Yeah, even startings helps you a lot, and basically when you talk about doing any of the things in this world, just go with the practical work, not with the theoretical work, and it will help you a lot in just learning anything in your whole life. That's
Yeah.
that's what I learned till now.
Yeah, that's awesome. I really appreciate you being on on the conference, and I can't wait to see you next session on C# Corner Live sometime.
Yeah.
Thanks a lot.
Yeah, bye.
Bye. So that was awesome to kick off our conference. Like I said, he knows more about GitHub than I do, and he's 13. It makes me feel bad. Anyway, let's talk about the contest we're doing really quick. And here's the contest we're doing. We're giving away a lot of free cool stuff. And the way you win is by making a comment and including the hashtag CodeQualityConf21. Now, I've been watching the comments, and just don't comment the hashtag, okay? Making a comment means you say something like, wow, this conference is awesome, or, Poolkit's session was awesome. Dude, come on. Just don't make a comment of the hashtag. Make a comment and then use the hashtag along with it. And on social media too. So we're a little bit over time. So I want to bring on our next speaker, who's Louis. He's going to be talking about code quality and performance with Xamarin. This sounds really exciting. Are we ready for Louis, Simon? Yep. Okay. So let's bring on Louis and start the next session. Welcome, Louis.
Hello. Hi, David.
How are you? How you doing?
I'm fine. What about you?
I'm tired. It's a little too early for me, but it's okay. I'm excited about this conference. And what country are you from? Live in now?
Dominican Republic.
Dominican Republic. That's right.
Yeah.
And so we have speakers from all over the world. I'm really excited about that we're getting input from just not like me and my friends. We have other people too. So I don't want to take too much of your time. So go for it. Let's learn about Xamarin performance and quality.
Thank you so much. I didn't expect the intro video. That's nice. Thank you for that.
It is nice.
Okay.
Uh-oh. Louis froze up already.
My name is Luis Matos. What happened? Hello? What happened? Okay. My name is Luis Matos. I'm system engineer, Xamarin certified. I have an agency. I do a lot of talking about Xamarin, Azure, and all of those things. If you want to see content about Xamarin, you can follow me on my social media, Twitter and LinkedIn. I have a lot of content there, and also I'm sharing content. I'm sharing a lot of content there. Today, we are going to talk about code quality and performance for Xamarin and Xamarin Forms. But first, I need to tell you that I don't have enough of time to show you all the things that I have here. So what that means, that I'm going to show you all the tips that you need to follow in order to have code quality and performance in your application, but we don't have enough time to detail all of those tips. But I'm going to write a blog post, but I don't know if it's going to be this weekend or it's going to be the next weekend because I'm really busy this weekend. But you are going to have it. So if you want to read that post or you need something follow me on social media, and you will have the content there. That's an extra content because I'm going to share all the resource that I'm going to use here. You will see it. Okay, what I have as a talk, I have a recopilation of all the best practice tools, techniques, and so on that you need for having a performant Xamarin application. If you are new in this world, just let's start talking about Xamarin. Xamarin is an open source platform for building modern and performing application for iOS, Android, and Windows with .NET. Xamarin is an abstraction layer that manage communication of shared code with the underlying platform code. Can I say? But when we talk about Xamarin, we have two approaches that we can follow. One of them is Xamarin traditional or Xamarin classic, as some people call it. With this approach, we can write code, logic code, once and share it across your Xamarin Android, Xamarin iOS, and Windows application or project. And those separate projects, you are writing code. In those separate projects, you are writing code that is specific for that platform, and you have access to their native API. That means that anything you can do with, I don't know, Object-C, Swift, Java, you can do it with C# and Xamarin. Anything. On the other hand, we have Xamarin Forms. Xamarin Forms is a UI framework that allows developers to build Xamarin iOS, Xamarin Android, and UWP application from a single shared code base. We have different approaches. We need to know that before we start. So let's start. We have the performance, the base, what you need to know at the beginning, what you need to know before you go deep. In this session, it doesn't matter what level you have. I promise you that you will learn something today, right? Okay, if you have a brand new app, be smart at the beginning. You need to be smart at the beginning. The first thing is making a good architecture choice. So you need to pick a good MVVM framework like Prism, React UI, MVV Lite, Fresh MVVM, and so on. But you can use what you like. Doesn't matter. But pick a good MVVM framework. Another thing is, if you are going to use database, make sure that you have a good repository pattern. If you are new in the Xamarin Forms world, or if you have a small project, you can use Shell. Shell can be a good option because you will have probably all the tools that you need to work with in an easy way. Also, you can pick dependencies wisely. Don't go too heavy with dependencies. Try to make your app light and snappy. And you need to add a unit test project or at least a mock configuration. This is because you need to have a way to test your project, a way that tell you like, hey, it's happening something, right? And okay, I have this hack stack, Xamarin Performance. In this session, I have In this talk, I have separate sessions in the presentation. In each session, I'm going to share the resource that I use for accomplish these steps that I'm sharing with you. So if you want to share your tips in that session, you can do that with the Xamarin Performance hashtag, right? And I'm going to read it at the end of that session. I have the application right here on Twitter. Okay. If you already have an app, be smart for the long term. Do you have the best architecture choice? You need to do. You need to. Um, you need to answer that question. But I write an ebook that it has 7 tactics to structure your project with Xamarin Forms. If your project is with Xamarin Forms, you have 7 tactics that you can use today and is free, right? Um, Another thing, if you already have an app, I have some tips that I'm going to share with you. These tips are from the official documentation that Microsoft Xamarin have. So we have, in order to improve the performance of our Xamarin Form application, we need to enable the Xamarin compiler. What is this? Oh, sorry. We need to enable the Xamarin compiler, use compile binding, and use fast render. These options are enabled by default, but for other solutions, you need to enable them manually. Reduce unnecessary binding. Don't use binding for content that can be easily set statically. For example, the name of the page, the title of the page. Choose the correct layout. For example, if you have a stack layout and the stack layout is capable of having multiple children, but you only have a single child, it's wasteful. You know what I mean? Optimize layout performance, use synchronous programming, and choose a dependency injection container carefully. Are specific tips that I recommend you to follow in the guide they provide, because you will learn a lot if you don't do it. Um, Use a collection view instead of list view. Collection view is more flexible and performant than the list view, so it's better. If you are using a list view because something happened, be sure that you optimize the performance with initialization, scrolling, interactions. Reduce the visual tree size. Reducing the number of elements of a page will make your page that render faster. And reduce the application resources dictionary size. XAML that is specific to a page shouldn't be included in the application resource dictionary, in the general, in the app XAML, right? Because the resource will be parsed at the application startup instead when you need to use it on that page, right? So don't overload the resources dictionary. Creating app with Xamarin Form examples and tips. I wrote an article talking about this topic. In this article, I talk about the 3 pillars to develop better application that are your app, the purpose of your app, and the developers. Also, I give you some general tips for increasing your application performance. In the performance section, I give you some resources that you can check. Also, an important tip, avoid using relative and absolute layout as much as you can. please. You will have all the resources in that post. In the same post, I give you some tips for Visual Studio and some tips that help you to choose the best MVVM framework for your needs. In the same way, you have 3 tips for your XAML and C# project. And I have a lot of tips lot of tips there. So go check it. Here's the first resources for the performance, the base. I'm sharing with you the Xamarin Mobile Resource Library that I have in my blog. You can see it here. The improved Xamarin Form and performance. Here's the link that you can see all of those tips that Microsoft give you, and the example tip for creating application in Xamarin Forms. And also, I don't have any people talking, but remember, if you want to add something in that session, you can do it with the hashtag Xamarin Performance. And also, if you can, use the C# live show hashtag too. So let's talk about performance and optimization. I know that, okay, we have a startup performance checklist. I know that this list is small, but think about it, and I promise you that you will see the results immediately. Don't start all the service that you have in your application right at the beginning. Use lazy load as possible. Don't download all your data on the startup. And think about user experience. When you talk about, we are going to see all of those steps later. But when you talk about data, use your data when you need it. You don't need to download them together, right? Okay. Here we have a release configuration for Android. So enable your layout compression, enable startup tracing on Android. Here you have an example of linking. Set your linking settings. If your app is for release, you can do it with link SDK assembly, with link all, and it's going to depend of your needs. You also will have a post talking about it. But for release configuration, you have link all SDK and user assemblies. And also, if you have some projects, some building project, you can enable linker save. I'm going to write a post talking about this because I think there is a few documentation for this. We will see. Follow me in social media and see what we can do. Use Android app bundle. It has a better security and is better than the APK. Sorry. For iOS, we have the LLVM optimization compiler. Enable that in iOS. So all the resources for the release configuration, you can see it here. Take a screenshot. I have some posts here that are really great that I recommend you to see. Optimize Xamarin Android builds, Xamarin Android app bundle, the Xamarin show with Android app bundle, really nice session. That been now also have a blog post to boot your Xamarin Form startup time, really nice post. Faster startup time with startup tracing on Android is also a good option to see. Okay. We also have resources for the linker. If you want to know about linker, I have here Montemagno talk about investing time in Xamarin linker for smaller app size. So if you want to reduce the app size of your application, that's a good post that you need to read. Optimizing Xamarin apps and libraries with the linker. And linking on Xamarin Android and linking on Xamarin iOS. And also you have a trick that John Douglas shared with all of us. Performance. If we talk about performance, we need to talk about memory management. Let's talk about event handlers. I know that these things are something you hear again and again, but trust me, it's very important to remember these rules. Just remember, as a general step, you need to unsubscribe from events and remember to unsubscribe events then before the subscriber object is disposed of. That's that's it. Keep that in mind at the beginning. Later you can read some posts and maybe I will give you all the results that you need to apply best practice. But at the beginning, just think about that. And that's it. We are not going to detail all those things. Prevent immortal object with reference. In .NET, any normal reference to another object is a strong reference, right? And that's it. When you declare a variable of a type that is not primitive or value type, you are declaring strong reference. For example, here we have object A. Let me use this. We have object A and object B that have a strong reference to each other, right? And because of this creates what we call an immortal object. Immortal object, how I can, okay. Immortal object are circular strong reference. On Xamarin Android, the garbage collector, sorry, handle that for you. But in Xamarin iOS, we need to be careful with that, right? But it doesn't matter. Why? Because we can use weak reference to prevent immortal object. A weak reference um, is created using an instance of the object to be trapped. So object A, let me use this. Okay, object A maintains a strong reference to object B, but object B maintains a weak reference to object A. And that's it. With that, you are all safe. If you don't do something like this, your app is going to fall down. Okay, load data efficiently. When you're loading a page, you need to think about user experience. When you need to be informative when you're loading your view and its data. So you need to tell the user that you are doing something, but don't show a blank screen and doing your stuff in the background. No, tell the user like, hey, I'm doing something. A good practice is load the local content first. I'm talking about your views, your component that you have locally, and in the background then you can start loading your data. So you can show, for example, an image, you can show activity indicator, a label, whatever you want. Drop something to the user, load that data first, and then in the background, call your data and populate what you need to populate in your view. You need to provide to user an experience of like there is something happening and not just like there is nothing appearing on the screen. Um, like I say, you can use placeholders, label, image, etc. Something that I like in this case uh, is defining states like my application is busy, I complete this task, I cancel this task, and all of those. You can use some animation with that. You can play with that and make a good, really user experience. Another thing is don't be things that can be said statically. I talked about before. If you have two labels, for example, and one of those describe something that, for example, a title, and in the line below you have the title of whatever you are talking. Why you need to bring a static text? You can do it right in your summary. With that, your page will render faster, so you will have a better, faster rendering experience. Um, Resources. I'm not seeing nobody using the hashtag Xamarin Performance. So if you are there, if you want to share some tips, please use the hashtag or follow me in social media. Um, Resources that we have for performance memory management, you have here. I really recommend you the post that Microsoft shared, Xamarin for Memory Performance Best Practice, really nice. Also, the Xamarin show and the session that I have memory management is really nice. Ah, the Xamarin Community Toolkit has a wiki event manager. With that, you can play, and they have a really nice documentation. Let's talk about quality code. Okay. Um, I wrote a post talking about async, await, and task best practice. Async await is one of those topics that you feel you like, you know a lot, but then you don't. The reality is that there are a lot of different ways to use async await, and that's part of the problem. So in the article, I give you some tips like how to invoke tasks, how to await multiple tasks, and what you need to know about threads. And for tasks, you have tips like how to return tasks. Maybe it sounds basic, but read the post. Read it. Avoid using void method in order to know the state of the process that you have with your method, and how to return tasks inside a try catch or using block. There are confusion in these kind of things. So read the post, please. I really recommend you to read the post. Believe me. Also, I have tips for Xamarin Forms and some plugin and extension for Visual Studio that you can use. A really nice post. I'm talking to you. In There is some kind of steps that the effort that you need to do is really small. Please read the post. I also write uh, an article talking about global error handling in Xamarin Forms. Many times we may encounter unhandled exceptions that are very difficult to detect and log. And you must do so in order to handle error in your application. You need a way to know what happened with your application, why your application doesn't work in the way you want to work. So there are global handlers in each application that allow you to receive notification of exceptions that you haven't handled elsewhere. That's a really nice post. I recommend you to read it. Not because I read it, no. Believe me, I do a lot of consultancies and this helps a lot. I will also write an article called Run Safe Tasks and Command Wrapper in Xamarin Form. When we work with tasks and commands, most of the time we do common implementation of some scenarios where we use repetitive code. For example, it's busy, a try catch for a method that you need to know what happened there, if something happened, a login, etc. The idea is to make a wrapper that allows us to store all of this logic for us and reuse that with tasks in common. I have there some really nice tips that you can check over there. Here's the resources. I have here the blog post that I wrote, a single way attack best practice, global error handles with Xamarin Forms, run safe, task, in command wrapper in Xamarin. I also I didn't talk about the plugin because it's an extra, but I built a plugin that is called plugin validation rules. That if your application have entries from users, believe me, this plugin is gonna be useful in the long term. Really useful, even though if it's not a long-term application. See it. Xamarin Performance hashtag on Twitter. People, please, let's go. Quality. Let's talk about quality with resources. Okay. When we talk about icons, images, and assets, the best thing you can do is using each platform. Yeah, that's it. Because the platform is going to adapt or use the files they need in the application they need. Remember, we have tablets, we have iPad, we have different kinds of devices and different kinds of resolutions. So the best things is go to each platform. But if you have generic files like a small image that you will share with all of your um, application, you can use it as embed resources. But avoid sharing larger files in a shared project, please. That not help your application. Also, if you want a faster image loading, avoid what I told you, putting a lot of files in .NET standard project. If you want to load resources from the web, don't do it for fundamental resources that your application has. For example, loading icons and all of these things. You can have it in your application. Avoid that. And consider using Glide X for Android and Nuke for iOS. Um, One line of code that will help you to load faster images. I'm not kidding with those libraries. And if you need to use images frequently, you can catch them with FFMatch loading. That's a library too. Here the resources for what I show you. Um, mm, mm, mm. Let's see, Xamarin Performance hashtag. Did it? Okay. I have here a plugin for Visual Studio that is called Mfacto. Um, Look for it. It's really nice. And also, I give you, if you are using shared images, if you want those images to be in each platform, you have a really nice plugin that is called Research Dicer MT. Really nice. You can see it. Let's talk about quality, but quality with dependencies. I don't know if you like this kind of session because I'm just telling you the tips that you need and sharing the resource that you need. But we don't have time to detail all of those tips and we need to cover a lot of tips. So sorry, but wait for the post or look for um, the resources that you need if you need something that I'm sharing with you, right? Dependency. What best practice? Optimize dependency being used. Remove everything that is not being used. For example, extra nugget, extra dependencies. Sometimes we replace a library for another one, but we forget that we need to remove the library that we used before. That's a common scenario. So try to remove everything that you are not using. And also you can set your Nugget Package Manager option to use package reference as a default. Do it. For this, we have here just two blog posts. If you want to migrate a package that config file to package reference, you can do it. Here you have a blog post talking about it. And Jonathan Peppers also talk about underperformance guide, and it's a really nice post that is talk about dependencies there. So go there and see what Jonathan Peppers need to tell you. Okay, let's talk about. Let me see the time. Okay, I'm running on time. Let's talk about quality and tools. When we want to get all sort of useful data from our app is when we need to use Profiler. Profiler help us look for memory leaks, large images, large objects, wide scope, cross-reference, contents, to prevent the garbage collector from working properly. It helps us to measure startup time, um, operation time, memory consumption, CPU profile, and so on. It helps you a lot, and it's going to give you a lot of data that you can use to help your application to be better, right? You have some profiler option that you can use in case no one knows. I know that profilers is one of those things that not most developers use, but it will increase your application performance a lot. Use them. You have Xamarin Profiler, of course, you have Xcode Instrument, and you have Android Studio Profiler. You have those three options that you can use. In case you are wondering how to start to use these tools, I give you all the resources you need later. Visual Studio. I have some extensions for you. For example, extension that we will help you a lot just installing them. For example, Xamarin help you to streamline your Xamarin Forms development and reduce your debugging cycle. Install it. You have XAML Styler. XAML Styler is a Visual Studio extension that format XAML based on a set of styling rules. So if you are working in a team with this extension, everybody will have the es- the XAML style code in the same way. So everybody can read what other people write before, wrote before, right? So use that. I really like that extension. And also you have a sync method name feature. The easy way to analyze and fix method names for asynchronous methods. That's the extension you need to use. And that's what it does. It will help people that is new in this programming world. So you can use it if you want or if you need. Resources. I have the resources here for quality tools. I have the profiling, Xamarin iOS application with instruments, the profiling Android apps that are from Microsoft. You can see what they have there. Really nice documentation. I want to okay. The best documentation in the world for a framework that I have seen in my life is the Microsoft documentation. I really like because all the things that I need is over there. Of course, there is something specific that maybe you want to do and you are not going to see it there. But the best things you can do when you need something is go to the official documentation that Microsoft has because it's really nice and it's gonna change your life if you start using it. Right? Do you understand? Right? Okay, got it. And also you have here all the extension for Visual Studio that I showed you before. And we have 10 minutes for questions. If you have questions, this is the time. Hi, David. Oh, sorry. I can't have. Oops. Sorry, give me a minute. Okay, I can hear you now. Oh, I can't. Sorry.
David, you're muted.
Okay, right now, yes, I can.
David, you're muted. David, you just have to click on that unmute button on StreamYard. Just click unmute. David, just click on unmute button on StreamYard.
Unmute.
I'm talking to David. Luis, you're all good.
Oh, I'm
Okay.
sorry.
Okay.
Can you hear me now?
Yes, I can hear you.
Sorry about that. I didn't know I turned on the mute.
Doesn't matter.
I think we have some comments. Do we?
I'm adding them on
Well,
the screen.
Yeah, I think one is, sir, can you please tell me how I can share code between cross-platform on Xamarin?
If you are talking about native project and you want to have a single project, a single shared project for having your common business logic, you can just create a .NET project and add the reference to those projects and start working with the structure and the framework that you want to use. I don't know if that is what Aditi asked.
Okay. But when you create a, when you create a shared project like that, does it have to be .NET standard?
Yes,
So,
it needs to be .NET standard. Yes.
Yeah. So make sure it's .NET standard because that will go cross-platform. If you don't, it's not guaranteed to go cross-platform, right? Yeah. And the next question is, will these tips still work in .NET MAUI in November?
Okay. Most of the tips that I show are talking about code, are talking about things that you can do today. And because Maui is an evolution of Xamarin Form, you can use the same tips that I give you there. But there are some things that it will change. For example, we have right now different projects for each platform. But with Maui, we are going to have one project. So we are going to have one file configuration for all of those platforms that we are going to use. So you can use themes like code and something like that. But for configuration, we need to wait and see what they have for us.
Okay. The next question is, what are the code sharing techniques, Xamarin's Forms? I think we kind of covered that already, right? Doing a
Yes.
.NET standard assembly. So can you please tell us about triggers? I'm not even sure what that refers to, so you're going to have to tell me what it means.
Yeah, I don't know. What do
Yeah.
you want to know about triggers?
Okay, if you use an MVVM framework to build Xamarin, which would be and why that one?
Okay, you have different options. I show you a post where I talk there. If you have a project that is for long-term, framework like Prism is going to help you a lot. If you have project that may be a small project for the long term, you can use, for example, Shell. Shell have a structure, an MVVM structure that you can use, or you can use Fresh MVVM, you can use MVVM Lite. It depends on what you need. For example, for those people that are comfortable with reactive programming, can use Reactive UI. React UI is a great framework that you can use too. Depending on what you need and what you know, you can use a framework for that.
Okay. Any other questions? We got like 1 minute left. Questions? Any more questions? Nope. Okay. Well, I think that pretty much wraps it up. I'm really happy that you were able to come on and be the second speaker at this conference. I really appreciate you taking some time from from where you are and taking some time out of your day. I know it's a work day for most people, not me. This is my work today. So I'm really glad that you came here. And I wanted to tell you if you have any .NET conferences down in your country, please let me know. I'd love to come speak.
Sure, we are planning some conference with some people, but we have, we need time.
Yeah,
We are really busy, but
yeah.
we do. I want to tell you something before we end this session. Thank you for the opportunity. Thanks to the teams, to CHR Corner for doing this kind of thing to the community. It means a lot. It helped a lot of people. When I start in the programming world, what it helped me to do what I do was because a person that I see doing a conference. So I really like it, and I really appreciate all of the effort that the community do for this kind of thing. So thank you.
Yeah, thank you. And thanks for being on the conference. I really appreciate it. And hope to see you again sometime soon. I definitely want to come to different countries. So make sure you let me know. You have my email address now, so make sure you let me know when you do a .NET conference down there.
Sure.
Okay, thanks.
Goodbye.
Well, that was great. I learned some things about Xamarin, and actually, I'm really looking forward to Maui coming out in November, so we can, start working on the new cross-platform from Microsoft.NET. So, pretty exciting. So, I want to talk a little bit about some things we're doing here on the show. So, could you show my slide, Simon? So, we're raising money today to help the kids in the slums in India. And so I hope you go to this this link here, that bit.do support slum kids, and donate as much as you can. India is going through a pretty tough time right now, and they don't have any vaccines, and they're opening up for some reason, but no vaccines. So, but we really need to help the kids because I've been to the slums in India, and they definitely need your support. So. So I hope everybody goes there and donates whatever you can. It's everything helps, especially in India. A few US dollars goes a long way in India. So, okay. So don't forget, we're giving some things away today. We're giving away 3 copies of anything Grape City makes for .NET. We're also giving away some copies of my book. We're giving away some Amazon gift cards, and everything there tells you how to win. And how to win is to make a comment and include the hashtag CodeQualityConf21 either in the comments while you're watching the video or social media. We have a program that will go through and pick somebody by random. So first, let's give away some Stratus bucks. We want to give away 140 Stratus bucks to somebody who's commented on the show. And Simon, do you want to pick the winner? I think we have a little app that will pick the winner. Yeah. Who's going to win? Who's going to win? Desi Boy, if I pronounced it correctly. So, Desi Boy, you won $140 Stratus bucks and 140 Stratus bucks. So, thanks for making a comment on the show, and congratulations. That's fun. So, our first winner, and I hope I pronounced your name right. If I didn't, make a comment and get mad at me. Let's see, what else do we have to talk about? Oh, we're right about time anyway. So our next session is profile and monitor web applications with Azure Application Insights. So with Praveen, if I pronounce his name correctly. I'm really bad at pronouncing names that aren't simple. I'm sorry. And I'm looking forward to this because, I don't know, I know a lot of companies out there try to choose, which cloud platform they want to use and everything. And, if you compare apples and oranges, with something like Application Insights and what they have on AWS, Application Insights flat out wins in my book. I would use Azure. Well, I'm a Microsoft MVP, but I would use Azure just because of Application Insights. Looking at logs and stuff like that on AWS is a real nightmare. So I want to welcome Praveen, and we'll start the session in about 1 minute. Welcome.
Hey, David.
How are you doing?
I'm doing great. How are you?
Good. Can you turn up your sound a little bit? I think is there a way to turn up his sound a little bit, Simon? Okay, we'll work it out. Doing a live conference is always who knows what's going to happen in any minute, right? The internet could go completely down, and we're really screwed, right? But I really appreciate that you're here. Are you from India?
Yes, I'm from India.
So thanks for staying up late. I don't know what time it is there, but I know it's in the evening. And so I really appreciate you being up late and, teaching us all about Application Insights. I'm looking forward to it, like I said, because I love Application Insights. And it's a really, really, really useful tool. So I want to turn it over to you for the next 50 minutes or so.
Absolutely. Thank you so much.
Thanks.
Yeah. I would like to share my screen. Can you please confirm if this is my screen?
There you go.
Portal that I should have.
Great.
All right. Hi everyone, good morning, good evening. So today we are going to learn about Application Insights profiling. So let's start. Before we start, quick intro about myself. Oops. And thanks Dave for the nice video. And yeah, I am Praveen Shiva. I'm working as a cloud solution architect and developer. So that's a quick intro about myself. And yeah, today our topic is profiling using Application Insights. So before we dive into different stuff, so let's understand what is profiling. In software engineering, profiling is a form of analysis, some kind of analysis to a code that measures different metrics like CPU percentage, memory that our application is consuming. So this I copied the definition from Wikipedia. So today we are going to learn how we can profile an application running inside Azure with the help of a service called Application Insights. It's very easy. You don't have to install anything on our own. All the tools required for profiling the application are built into Application Insights service or the books. So let's dive in. So today we are going to learn about overview of app insights. Before we do profiling, we first understand what is app insights and how it fits into various components in a real-time project. I'll just take a simple application with various components and I'll show you where app insight fits in that application. And then we'll discuss about some of the app insight features that can be used to review our performance. And then we'll understand how to enable profiling. There are different uh, things that we should do. It depends on whether it is Windows operating system or Linux operating system. Right? We will understand what are those differences. And then we will see, we'll try to see if we can simulate some traffic. We already simulated some very basic traffic that would require a little bit. So let's first understand what is Azure Application Insights. So if you look at this diagram, this is Application Insight Service. It's a PaaS offering by Microsoft. Now, once you create this Application Insights, uh, it provides us, it automatically tracks the application telemetry and any other custom application logs that our apps would push. Right? So if you see this diagram here, this is a front end, probably an MVC based application. It could be an Angular application or it could be any other application. So all we need to do is we need to install an instrumentation package. For .NET, it's a NuGet package. For Angular, it could be an NPM package. For Java, it could be some kind of package. Right? So developer needs to add that package and write one or two lines of code. That's it. All the telemetry, everything will be automatically pushed to App Insights asynchronously. So we can integrate App Insights into our web applications or APIs or even background services. It could be any console application, or background application, or Xamarin application, anything. So once we integrate that, the application will start pushing the telemetry logs to App Insights. And from here, basically this App Insights store all the data. Of course, it provides many built-in reports. We can analyze the data and we can get insights about our application performance, exceptions, top 3 exception reports, response codes, top 3 slow running pages. All that information you get out of the box from application insights without recreating any reports. Now, apart from using the default reports, what we can also do is we can do all this. We can create alerts, we can create custom reports using Power BI, we can export the data and put it in somewhere, and we can do uh, further analysis. All those integrations are possible and they are seamless to integrate. Okay? And so this is a simple application that I have developed wherein we create various services. I already created all these services. The web application which talks to a database, and the web application also talks to some storage. These are all Azure services, and it talks to an API. It could be our own API or it could be an external API as well. And probably we are using some base cache. Right? So in real time, an application or an API can talk to many different services. Right? So now probably you want to track the performance of each of the calls made to all these services. So probably our web application is making some database calls, database trips. Our application might be uploading some files to storage account. Storage is another service in Azure. And our application might be talking to an API using HTTP client. It could be our API or it could be an API managed by someone. So now we want to track all the exceptions, logs, performance metrics, everything. So all that can be done very easily with the help of App Insights. All we need to do is link our web app with App Insights with the help of a connection string, with the help of a key called instrumentation key. So every App Insights will have a unique instrumentation key that should be plugged inside web application. Along with that instrumentation key, we also need to add the NuGet package in just one line of code. We just need to register app application inside telemetry service in our application. That's it. So now whether web application is making calls to storage, database or APIs, automatically all the calls are tracked out of the box by App Insights without rewriting any code. And unfortunately, there are some services which are not tracked automatically. For example, Redis. So as of today, the calls that you make to Redis are not tracked automatically by App Insights. Probably we should write some custom code for that. Right? Even if there is another service called Key Vault, so those Key Vault is tracked by our App Insight automatically. Right? Not everything is tracked automatically. Uh, so there are some services like Redis Gas whose calls are not tracked automatically by App Insight. Of course, you can write your custom code uh, if you want to log those metrics, performance metrics, or anything else. So you have to write your custom telemetry for that. So let's explore the code. It's very simple code. So let me switch to my Visual Studio. I'm using a .NET Core 3.1 application. And if you look at here, this is my web application. And I have installed a NuGet package. So this is specific to .NET Core. But similarly, if you are using Java based or PHP based or Angular, very similar. In similar way, you have to download the appropriate packages. So this particular package is sufficient for tracking everything except profiling. So for profiling, we have to add additional package. These two are required for profiling or application. So once you add these libraries, you will have to add the instrumentation key. This is the instrumentation key for our application designs. And then we have to add one line of code to track all the default telemetry for App Insights. But if you are interested in Profiler, you have to add this line of code. That's it. Now, the entire application, whatever calls it application makes, all those are tracked asynchronously. So adding application insights will not add any additional load to our web application. There might be slight load, but it's negligible because all the telemetry will be pushed asynchronously to App Insights. Okay. And once you add this in startup class, so all you need to do is in controller classes, action methods, you just need to have iLogger, and you can use iLogger wherever you want. For example, you can track the exceptions, you can push these exceptions in case if there is an exception, these messages will be pushed. You can also log your custom messages as well with just one line of code. Logger dot. You have various methods for various messages, log critical, log debug, log error, info, trace, and log. And all of them are available. Right? But for profiling, which is our topic today, we don't have to write any line of code except this. Right? Now, in order to show some code, I have added some thread.sleeps in the middle. But in real time, there could be a lot of complex logic in your application. So there, in case if the developer did not write the code properly, all that will be shown in the profiler once you enable it. So this is the code that I have written. I have a couple of controllers. And I'll be running this application very soon. Let's go back. Now, before even we talk about profiler, I would like to explain some nice features where we can get performance metrics. If you say this application This is a screenshot taken by one of the features called application map. Right. So I will also show you the screenshots on how to navigate to this application map feature in the portal in just a moment. But this is the application map. If you see this, these are application web application uh, which is talking to database. If you see this, there are 10 calls made by this application in this screenshot, and some of them are failed. I think 11% of them are failed, and 10%. If you see this, 10% of the database call were failed, and it was taking 11.2 milliseconds on average. Some of them might have taken more time, and some of them might have taken less time. But overall, on average, this is what the database calls, which looks good. But in case if overall, by looking at this application map, you can see where exactly the performance bottlenecks are, right? So here it's making a call to storage, and the average amount of time is 32 milliseconds. So at a high level, uh, when our application is talking to multiple components, here this view gives us which component calls are taking time. Right now everything looks good, but in real time when a lot of code is in place, and if it is not optimized code, then looking at this view you understand, okay, calls to storage are the culprit, or calls to database is the culprit. That is one view where you can get the insights about performance. That view is called as application map, right? And now this is at a very high level per component. But what if you want to analyze an individual transaction, right? Individual request? That request might be making calls to multiple components. Probably it is uploaded to storage, and once the file is uploaded to storage, probably it is making a database update, and once that is done, probably it is making call to another API. So a lot of components might be involved in one transaction or one request. So how do you do that? Right. So there is one more feature called distributed tracing. Right. So I have captured a couple of slides. So this is one request. So end-to-end transaction. Right. This feature is called as distributed tracing, wherein you track a request, and you see this is web application, and this is my action method. This is a URL which made calls to multiple different components. Of course, there were errors in the middle, right? But it made calls to storage multiple times. These are all storage account calls, right? And then you have a call to database in that SQL server. Now here, if you see this, it is giving us duration that it took for every other entity. Right? Here you are seeing empty spaces, but if you click on this, in the right hand side, you will see what exactly that call was. I was trying to create some storage related components. So it was taking around 49 milliseconds for that operation, and so on. Database call was hardly 2 milliseconds. But now this is another view. It's a single request which is making a lot of interactions with various components. Right? Overall, it took 10.2 seconds. But if you combine all this, it hardly comes to 1 second. So where is that next 9 seconds? That's the problem with this approach. So that 9 seconds or 10 seconds is my wait sleep time. So I intentionally added some sleep. So that sleep is not shown here. But otherwise, this distributed tracing uses lots of insight about various components that are being interacted in that particular single request. This is another view where you get performance numbers. In the previous view, you get insights about average metrics, average numbers for an individual component. But here, for a given request, you get the actual amount of time taken for each component. If you have more components, you get all those here in a sequence. Right? But this is not giving some information about the calls which are not supported. For example, if this call had made a call to interacted with Redis, that would not be shown here. So at this point of time, Redis calls are not supported yet, right? So that is where profiler comes into picture, right? So if you see this small icon, this is a profiler icon. So by default, you don't see this. You see this only when you enable profile. So if you're not happy with these numbers and you still want to research further, you can click on this link. It will take you to another view where you can see more details. For example, here you don't see how much time framework is taking. .NET framework is taking for doing some other operations. Right? Here you don't see UI execution. But when you click on this, it shows all that. Of course, profilers are not 100% accurate because it's just a sampling. It captures only a sampling data. We'll talk more about that in the coming slide. I have a separate slide for that. So now this icon is shown only when you enable profile. So how do you enable profile? So navigate to your app insights, and profiling can be enabled by navigating to a blade called performance. So click on performance and you will be taken to this blade where you see profiler. Click on that. It opens up a pop-up. It opens up another blade. In this slide you see that as a pop-up. But in the portal you see this pop-up somewhere in the right hand side. Now if you see this, these are the two recent profiling sessions. It is triggered on demand. I manually clicked on profile now, and it is one-time policy. I'll show you what policies are. And this is the app name, this is a server name, and this is the time. And there was no load during that point of time, but it will also show us if there is load while the profiler is capturing the data, then it will show us how much CPU, what was the CPU load while that profiler session was running, and memory load as well. Right? So you can configure some policies here. You can instruct app insights on when to start profiling session, and if you want to do it right now, then you can click on this profiler as well. And sometimes profiler will not work properly, so in that case you can use this button to troubleshoot further. Right? So, yep. So now these are examples that I have captured, because sometimes profiler doesn't load up for various different reasons. But if you see this is one of the profiler traces for one of my calls. Right? I'm making a call to external API. So this is the URL for external API, and it has taken 14 seconds approximately, out of which 10 seconds is sleep time. It is giving us all the complete data. And if you observe this, these are hard paths. You see these flames. So when you come to this trace, profiler trace, it directly shows us that this particular request or this particular section has hard paths, and this is where you should troubleshoot further. And these are good. Right? These are some other framework related stuff for front end execution, but this is where most of the time was consumed for this particular request. And this is the actual wait time. It waited because I have added a sleep time, and it has waited because it is making an external call to some other API. So overall 10 plus 3 seconds, it shows 13 seconds. Right? Out of 14 seconds, entire 14 seconds for this request, 13 seconds were almost wait time. So this is how profiler helps us in quickly getting insights about the performance of our applications. This is one example. I have one more example where I made some calls to database. And this is our .NET code, which is calling entity framework and internally calling the store procedure. So this took around five seconds, wherein unmanaged code, right? This is unmanaged code is a catch-all category which contains a lot of other things like multi-core, some dependencies. So here it took 2 seconds. Probably it is database took approximately 2 seconds to respond. Yes. This is another example. This is another example for storage. So these are application code and this amount of network latency probably. So this how profiler helps us in tracking all the performance issues. There are multiple different views in which application insights can be used to look at performance issues. Of course, there are some limitations or issues. Sometimes when you run profiler, it will fail. Right? So you have to retry again, and it only supports app services hosted in app service plans which are either basic or above. So sometimes even basic won't work, but standard or above will definitely. So these are the pricing tiers of app service plans in which web applications are hosted. So when many people think that profilers will hinder the performance of the server, but it's not completely true because the profiler runs only for 2 minutes every 1 hour. Of course, you can change it to 1 minute or 3 minutes, but otherwise it's the default is 2 minutes per hour. So it doesn't run within our application, but it's output it, so it doesn't impact the performance of our application. So let's look at that application. Sorry, let's look at the Azure portal. Alright, so I am inside portal.azure.com and I already created the services based on the architecture that I have shown in the PowerPoint. So this is my application insights and this is our web app service web app, which is inside this app service plan. The app service plan pricing tier should be basic or standard or above. Microsoft says it's basic, minimum is basic, but I generally try that in standard. Okay, because in basic or higher tier, you get a dedicated virtual machine. So profiler doesn't work in free tier. So in case if when you try to turn it on, if it doesn't work, then you should upgrade it to standard. You don't need to do that. And this web app is talking to database. It's talking to another app service, which is an API, and then it talks to storage as well. Right? So let me show you application map. I give it a shortcut in my dashboard. So we are inside application insights, and this report is running for last 24 hours. So this is a view. It's a very nice view at a very high level. It gives us all the metrics about various interactions with various components. Let's say your app might be talking to multiple storage accounts. In this case, I have only one storage account. In that case, this becomes a cluster. Right? And you can drill down further by that particular node. Well, now you can do that. So we'll see more details about this. If there are multiple storage accounts, then you will see all of them. And if you are interested to see what went wrong here, you can click on this and it shows us what those calls are and why it was slow. Right? You can click on this and it will take you to different place and you can investigate the performance further. This is one view. The other view is end-to-end transaction. Right? This view gives us at a high level per component. But what if you want to look at individual transaction? You can either click on this or you can click on performance. This particular blade will give us details about all different requests. Right? Again, this is filtered by 24 hours. You can of course change it to 30 minutes or whatever. So let me scroll down a bit. Now you see this. This is the average duration amount of time that it took. So far, this was called only once. took 13.8 seconds. This was called 6 times and it took an average 10.5 seconds. Now, if you want to understand and see what happened for individual 6 requests, individually for all 6 different requests, right? So click on that. On the right hand side, you will see all those 6 individual requests, or you can directly go to profile tracing. So out of 6 requests, the profiler was running only uh, while those 3 requests were happening. So this icon or this button will be shown only when profiler is enabled. This will not be shown when profile is not enabled. You will see only that, only this. So now if you want to see the load on individual components, then you can click on this. So you can pick one of them. Automatically App Insight suggests us to look at this, or you can see one of them. You can look at one of them. You can sort based on date. If you want to see the latest one, you can sort it by date. You can click on any one. Now this is end-to-end transaction. If you see this, I click on this. I think Microsoft guys have added this recently. Earlier we were not seeing this. These were individual calls. I'm checking to create a container, which took approximately 49 seconds. And this also took similar amount of time. And there was an error. It said container already exists. And this was another error with some other message. And I was trying to delete, but there is no such file. So this was giving some error. But that call took 9 milliseconds. So these are all individual interactions with various components within this request. Now you see all the duration here. In case if you don't see that here, probably you can collapse this. Sometimes this particular thing is not visible. Probably there's some UI issue. You see, it is not visible. Even if you scroll towards right, you don't see that number. So in that case, you make some room by collapsing these plates. We'll see that number. And here, right here, you see a profiler. Again, this is only visible when we enable profiler. Right? So I can click on this to see what happened additional to what it is shown here. You can click on this, or if you don't want to, if you're not interested in this particular session, but you are interested overall, then you should scroll towards left. We are inside performance blade, and you click on this. And for the very first time, if you want to enable it, you can click on this profile. It takes some time to install the agent on our application app service server, and it does a warm up, and then it starts the session. So it takes some time for the very first time. Right? And if you can also do some other triggers if you don't want to profile manually, you might want to do it automatically. Then you can click on this. So if you want to trace only CPU, then you can do this. It is currently turned on, and it runs only for 120 seconds. Right? So it automatically runs when the CPU threshold goes beyond 80%. It automatically runs when it reaches, when CPU percentage on the server reaches 80%. Then it runs for 120 seconds, and again runs only after 4 hours. Even if the CPU is beyond 80% after 4 hours, within 4 hours, then it won't run. So the next run will be only after 4 hours. And same thing you can do it for Mino. And of course, you can change the duration. By default is 120 seconds. You can decrease it if you want, or you can go up to only 100 seconds. So if you don't want CPU or memory, then some other. If you want to change the sampling rates, normal, high, and maximum. So it captures more data when you go to maximum. It's not recommendable to do this unless you are pretty sure on what you're doing, because if you choose this maximum, it might impact the performance. Normal should be good for most of the applications. So if you change it, don't forget to click apply. And you click apply. So I have 2 sessions, profiling sessions. So I can even download the trace, and I can use it in some other Windows-based tools. I can use this traces even in Visual Studio. Right? Sometimes this fails. Let's see. Let's try my luck. So these are four items which are tracked during that particular session. Is extracting the data from the event trace from the call stack. So sometimes it fails. So it gives us all the hard parts. So it automatically opens up whichever component is taking more time. Yeah, it takes time. Let's not wait because I already showed you that how this trace looks like. That's the reason why I captured all those screenshots upfront. So this is a view. You can see hard paths. Right in real-time application, there could be many calls within the application. Right? This profiler helps the developers to directly jump into where exactly uh, which component is taking more time for the calls. That's how profiler works, and you don't need to write any. Uh, it's not hundreds of lines of code. It's just one or two lines of code with some conditions. That's about it. I think I'm done. Um, any questions? Hello.
You're muted, David.
David, I can't hear you.
Sorry, I'm on mute again. I'm still trying to wake up. So I think we have some questions. Let's go back to some of them. So one is, yeah. Any important points to consider regarding application insights when moving code to production?
Sorry, David, can you please repeat?
Yeah, do you have to do? I guess do you have to do something different when you move the code to production? I don't think so, right?
No.
Yeah.
No, I don't think. Yeah, it's the same thing even in production. Whatever we discuss, it's all you can do that even in production. It doesn't impact your application. But generally, people don't do that in production. But if you really want to do that in production for some reason, you can absolutely go and do that.
Yeah. The next one is, does Azure Monitor require an agent? I don't think so, right?
All right. In fact, we don't need to install any agent because it's all PaaS. But internally, when you enable profiling, internally, Microsoft will take care of installing those agents into the app service instances. That will be taken care automatically. But we don't have to explicitly do that because it is PaaS. But in case if your application is hosted inside a virtual machine, then absolutely yes, you have to install those agents and you have to do some configurations.
Yeah. Okay. So I'm trying to juggle a couple screens. How Azure Application Insights helps. I'm not sure what that means, but I would say Application Insight, from even what you demoed, you can get a lot of insights to, what's going on in the cloud, with your application. The next one is for feature-related distributed tracing, we are able to set up custom timeline posts with Buffer Alert. I guess they're asking, can you do alerts? I think you can, right? With Application Insights, you can do alerts.
Absolutely, yes.
Yeah.
We can do custom alerts, yes. You can write some queries using KQL, custom query language. If you have any custom requirements, and you can set up alerts, absolutely.
Yeah. And can we block services which is causing latency? So I was interested in this comment because, whenever you're, logging and stuff like that, that can cause some latency. So I guess he's asking, can you turn things off to prevent that? Or, what is the whole latency thing by using Application Insights? And is there any latency?
Right. When you use application insights, it depends on what is a log level. Right? There are different log levels, right? Error, critical, warning, info. So if you make it trace or debug, then tracking, then your application will make many logs or traces. Definitely, in that case, your application performance will go down. So it's Microsoft recommends you to put either error or critical.
Oh, to do errors,
So
not tracing.
yes, absolutely.
Yeah,
Not tracing, not debug, not errors. It
yeah,
will then your application will become slow. That
yeah,
will
yeah.
cause performance issues.
Yeah, that kind of sounds, sounds, well, that sounds like the way you do it because, doing errors also gives a lot of more information, like the stack trace and, things like that. So, yeah, that would probably be, more, I guess that would be more useful, right? Um,
Absolutely.
Please increment Chrome font size. Yeah,
Uh,
we're aware of the poor audio quality, sorry about that. That I know the internet is not great in India, and that causes some issues, and there's some background noise going on. So yeah, we're aware of the audio issues. We apologize for that. Um,
I apologize. Sorry
yeah,
for the
when things are live,
pronunciation.
yeah, when things are live, this is what happens, right? It's any other questions? We had some time to kill, so anybody else have questions about application insights? One thing I would like to bring up, and I don't know if you've used it in this manner because I haven't done it yet. I want to with the app I'm working, the new version of the free app I'm working on right now for .NET developers. But you can use application insights not in the cloud, right? You can have a normal WPF application or WinForm application. You can add application insights to that to get the same information, right?
Absolutely. Even
Yeah,
for Angular single page applications,
sure.
also you can use background services. Absolutely. Yes.
Yeah, yeah. So Uh, yeah, so I'm definitely adding that in the new version of my app because that's, one of the things that, especially when I go into, when I go into a new consulting gig, and, pretty much, and I'm going to talk about this in my keynote, but, you know, pretty much every company I go into, they don't do any of this kind of, you know, monitoring, of their apps. They have no idea what's going on with their apps, and even, before I left my last contract a couple of weeks ago, one of the developers there was having um, an argument with somebody in another team that the person in the other team was saying, well, if you use the link, and this is an application insights, but if you use the link um, API to do link, right, as opposed to doing lambdas with link, right? They said, there's no speed difference. And, the developer rightly said, well, how do you know that? And can you prove that to me? That, doing link this way or that way is really any difference in performance. And the developer couldn't do it because they didn't do it, and so I actually added it to my benchmark tests for my code performance book, and actually using lambdas are faster. And I was actually surprised because I thought, you did do link this way or do link that way. It's pretty much the same thing. And I found out it's not. So, this, using something like application insights is super important to get this kind of information, right? And most companies I go to, I ask them for this kind of information. How long are your calls taking? How long, when somebody does a request into the site, and you return data back, how long is that taking, right? And, most companies can't answer that simple question, and the one thing that, I've gotten frustrated with, some of these companies is that because they can't answer these questions, how am I supposed to design a system that's better, right? I can't, how can I write a system that's faster when I don't know what your current performance is, right? There's nothing to guide, if you don't have this kind of data. And even one company I was working at recently, they have two big traffic days of the year, which is Black Friday and Cyber Monday here. America. And when I went in there, they hired me to improve their performance because they kept having issues during these 2 days. And I said, okay, well, and how many calls are you getting a second, last week? They couldn't answer it. I'm going, I'm not,
Right.
I kind of need something to go by, right? And so I'm going to be talking about this in my keynote speech at the end. And, one of the things that I'm going to talk about in my keynote is that, 100% of the companies I go to do not do memory profiling, right? Nobody does memory profiling before they release their app, right? And unless I'm there, but even when I'm there, there's this one contract I'm working on. And I put in some time to do memory profiling towards the end of the project, and they said, nope, we're not going to pay you for that. I'm going, well, how am I supposed to find the problems if I can't do memory profiling? And I actually did it on my own time just because I was curious, right? But, they flat out wouldn't pay me to do it, and, especially since I'm so, big into code quality and code performance, this is a really, I guess, pet peeve of mine that, companies just don't have this. Most companies I go to have no information like this, right? So, yeah, just implementing something as easy as application insights will give you a ton of information, and especially about the errors that are happening in the background, right? And the one thing that I like, about application insights, it's really easy to get to. You just go to the portal, you go look at it. There's no logs I have to get from a server, anything like that. The last company I worked at, they weren't using application insights because they use AWS, and so they were logging everything, to the server. And then, when an issue would happen, we couldn't even investigate it because they wouldn't give us access to the logs. So we need developers have to have this information. It has to be really easy to get to, right? Not in logs. It has to be in the cloud, so it's easy to get to, right? You agree?
Absolutely.
Yeah.
So just to add, right, some have seen companies, right, when they see their application running slowly, all they do is they bump up the servers, they increase the capacity of the servers, or they even increase more servers instead of doing all these profiling things. If they have done the profiling, they could have got the code which is not optimized. That way, they can save tons of money. So
Yeah.
these application insights will help us in quickly identifying those issues, and indirectly it will also help the companies to save dollars.
Right.
And just to add what you said, the application insights can be even used in your applications which are hosted in on-prem or even in AWS. So it's not the applications are not just to be hosted in Azure, but it can be hosted anywhere.
Oh, I didn't know that. Yeah. And application insights is free. All you do is pay for storage, right?
Absolutely.
Yeah.
All you
And
need
storage
is
is
to
pretty
store.
cheap. Yeah.
Yes, yes. And
Yeah.
first 5 GB of data per month is free of cost.
Oh, really? Okay. Yeah, I didn't even know that. So, if you're, no matter what, if you're using .NET, you should be using application insights, right? That's, to me, and I've yet to see anybody do it, like on it. I mean, well, unfortunately, in Southern California, most companies like AWS, which I don't understand. But because doing stuff like this in AWS is a nightmare. You just don't get this kind of information in AWS. And even trying to get to the logs and the CloudWatch logs in AWS are useless. They're horrible. I don't know if you've looked at them, but I can't say enough bad things about CloudWatch.
And many .NET guys definitely, as you said, go to App Insight. But nowadays, customers who are in who are Java shop, they are requesting us to integrate App Insights into the Java-based application to develop those awesome features that it has.
Yeah. I think we got a new question. What type of security required to deploy a web app on Azure? Oh, this is an application insight question. This is a website question. So I don't know if you can answer that. I don't.
So,
Yeah,
yeah,
that's
there are various different ways of securing applications.
yeah.
In
There's
case if
yeah.
you're talking about, yeah,
Yeah,
there are many different ways. Let's say,
that's a whole session in and of itself, is how to secure things on, for your web app. Yeah, that's a big topic that we're not going to cover in this conference. Sorry about that. So any more questions? We got like 5 minutes. Come on, people. We need to have questions. No? The questions take a little bit to come in, so we'll wait a second. But yeah, the one thing I know I've said this already, but I just really wish companies would do more of this kind of work, and yeah, it takes a little bit of time to set up and everything, but it's, the information you gather is invaluable, to me, and I remember when I was working at a company like 10 years ago, before Azure, before all this stuff, in .NET, starting at .NET 2, I wrote my own logging system. And my logging system still logs more information. I'm not talking about application insights, but other logging systems. My system logged more information than any logging system that I saw. And my boss said to me, said to people multiple times that because of my logging system, it saved us countless hours trying to track down issues, right? Because the biggest problem, especially when a problem happens in production, is tracking down where the heck it happened, right? And if if you don't have something like application insights, then we're left to trying to recreate the problem, and I don't know about you, but most of the time when I'm trying to recreate the problem, I can't do it. And so if you can't recreate it, you can't fix it. You can only guess at what the fix is, right? But using something, using application insights will totally be worth it. And like I said, I'm looking forward to putting it in my WinForms app. This app I have for developers, I wrote, I think in 2017, something like that. So, and I wrote it in WinForms, .NET 4.6 point something. And so I'm really looking forward to adding application insights. It's going to be my next thing I do before I release it again. Because again, I want to know that what's going on with the users and stuff, and that's the best way to do it. Any more questions? If there's no more questions, we'll just kind of let you go, I guess. Any parting thoughts before you go?
I think I should thank David, you, Team Simon, and C# for giving this opportunity and continuously conducting these sessions. I look forward to working again for upcoming sessions. Thanks again for the opportunity.
Thanks a lot for being on the conference. And I'm, like I said, I've been really excited about this conference for a long time, and I really appreciate you and everybody else around the world taking some time out of your workday, to help others, when it comes to code quality and performance, because that's what I'm passionate about right now, and I'm trying to get more people passionate about it.
Yeah.
So thanks a lot, and I look forward to the next time you're doing a session on C# Corner.
Sure, absolutely. I look forward.
Thanks. Well, that was great. Yeah, sorry about the audio issues. That's kind of what happens. Not everybody has nice microphones and lighting and stuff like that. And actually, I don't really have any lighting. And Simon comments all the time how great my lighting is, but I really don't have any lighting. This is the natural light in my home, and the sun's coming. The sun's up now, and so this is it. Most of the lights actually comes from the computer screen. So anyway. So can you bring up the slide so I can do some talking before the next presenter? Let me see if the next presenter is here. Oh, he's here. Great. So I want to talk a little bit. I wanted to mention my weekly show on C# Corner Live. It's called Rockin' the Code World with .NET Dave. It's most Saturdays at 10 a.m. Pacific Standard Time, because that's where I live. And my show really features the top people in our world, talking about all kinds of subjects, diversity, coding, all kinds of things we talk about in my show. And right now we have a lot of people viewing the show because it's simulcast on 4 different platforms, just like this conference is. And I think people are liking it. And I really like doing it because not only do I get to catch up with my friends and meet new people and, present, get all these world-renowned people, talking to you on Saturdays. I learned a lot from the show, and I have a lot of fun on the show. And, we started the show last September during the lockdown, which, in California, they just don't, our lockdown is over as of this past Tuesday. And so, and I'm so happy that I can see people's smiles again. We went a year and a half and I couldn't see anybody's smiles. And so, going in the stores and stuff like that was kind of depressing, but I'm glad we're off the lockdown now. And, we're doing better with COVID, but, and also my show at the end I have a new segment on my show called New Code Rules. And I do a short little commentary about something that probably happened to me recently. And, I want to talk about it and bring it up and maybe, bring up some ideas on how to make things better. Like last week I talked about just, because right now I'm looking for a new contract or a full-time job. And, dealing with recruiters right now is a freaking nightmare. And I want to find a way to make it better. And, it's so hard to find good recruiters now because it's just so many crappy recruiters, scammers and things like that out there now. And it's, even for a guy like me, it's pretty frustrating to deal with them. And on every show, we give away a free copy of CodeRush to everybody watching from DevExpress. CodeRush is a code refactoring tool. It's the only code refactoring tool I've used since Visual Studio came out. I love it. It helps me be a more productive developer, and it teaches me things because I don't know everything, but I learn things from CodeRush. So if you watch the show, not only do you get to learn some really cool stuff, but you get a free copy of CodeRush. What's better than that, right? I wanted to talk about my book I've been trying to work on for a little while now. It's called the Hello World Cookbook. And the reason I started this project is, the last time I was in India, I went to the Voice of SLUM in Delhi, the NGO orphanage in Delhi. And I was so moved by that experience that, as soon as I came back to America, if you buy my code performance book right now, 100% of the proceeds goes to the Voice of SLUM every month. So everybody who buys one, I really appreciate it. But I want to make sure that, we keep helping the kids in the slums in Delhi, India. And because, they don't get a lot of support from the government. And so the only real way for us to support them is to either donate money. And then so I started this project called the Hello World Cookbook, where I'm gathering food recipes from all over the world from technical people just like you and me. And it's going in a book. I've actually been working on, recipes for this book for a couple of years, actually. And I'm perfecting them so I can put them in the book. But I really, really need your help and support to send in your own custom, your own food recipes to the book. I don't have enough recipes right now. And if I don't get them by October, I'm going to have to let this project die because, I bought the domain name for 2 years and it's up in October. So that's kind of my cutoff. So please go to helloworldcookbook.com and submit your food recipe. And if you don't, I know a lot of software engineers aren't great at cooking and don't like to cook. So you can also help out because I need unit testers, and unit testers are going to test the recipes for me because I can't test them all because I eat gluten-free. And I also need some help with editing the book itself. And then I need some help with the graphic arts, pictures and, the picture, yep. Simon? Okay.
Let's bring the guest. Yeah, it's time.
Okay. It's time. Okay. And and also we're raising some money for today through the conference. So please go to that link right there and donate some money. We're going to give all that money to the kids in the slums in India to help out with the COVID relief. So please go to that link. We'll display it more. And do you want to give away the prizes real quick, Simon? I know.
Yeah, let's do it.
Okay. So we got 1 minute left. So we're going to give away some prizes. So first, let's give away the Stratus Bucks. So we're going to give away 140 Stratus Bucks to somebody that's we pick soon. All right, there's our winner. I don't even know how to pronounce the name. So there you go. You win 140 Stratus Bucks. And the next thing we're going to give away is an Amazon gift card for one of the creative posts on social media. So if you want to win, any of these things, make sure you comment, make an actual comment, and use the tag hashtag CodeQualityConf21. And if you do it on social media, you also need to use that hashtag so we can pick you as a winner. So do you want to pick the $50 Amazon gift card winner, Simon?
Maybe towards the after this session.
Oh, after the session. Okay, we're going to do that after the session. Sorry. So let's bring on our next guest, Bob Kemper. He's going to be talking about 4 big software app challenges for finance services. Hey, Bob. How's it going?
Hey, all right. Can you hear me okay?
Yeah, I can hear you.
Great.
So which country are you from? America? Or
Well, sort of. I'm in Florida, so it's questionable.
yeah. I don't know if Florida is really part of America anymore.
Yeah, I think we've tried to secede somewhere, but who knows?
Yeah, I don't want to get into all that craziness down there. I'm glad I'm here in California, to tell you the truth. And Texas would be another state I don't really want to go to either.
Yeah, I'm sort of glad California's reopened. I'm used to going out there like monthly for a bunch of years, and the last 18 months I've been sort of trapped in Florida, and it's like I need to get out. So.
Yeah. Well, if you make it to California, you make it to San Diego, let me know. We can hang out.
There you go. Perfect.
All right. So let's get your session going. I'm excited.
Okay, great. Yeah. So yeah, and actually, it's as a continuation of sort of the conversation, I think a lot of this is going to be fairly relevant. This is called the 4 big software app challenges for financial services. In reality, it's just some macro trends that we see in the industry overall today. When we think about it in terms of financial services, it's mostly because the impact on these financial services and these applications, as they're moving things faster and faster, the impact to the global economy as well as to the business themselves is really tremendous. So that's really sort of the, what our focus is. So a little bit about me, just real quick, as to why you should listen to me if my slides will work. I've worked in the enterprise software business for a very long time at this point. Dave, I was looking at your bio, and I think I've got you beat by a handful of years. I started my life as a software engineer working with Windows apps. I actually used to write video BIOSes and video drivers for a PC manufacturer, and I worked with Windows in the Windows 1.0 days where we were doing both OS2 as well as Windows. So I've been sort of around the entire incarnation of the Microsoft stack since really the late 80s, early 90s. I've held leadership positions in a lot of large and small companies, from the incept of 5 to 10 people all the way up to thousands of people, and watching some of these companies get built. All of these have something in common, which is really about building software and applications for the enterprise, for enterprise software companies, or for enterprise businesses. And most of our customers at Overops right now really tend to be in the financial services space or in the large enterprise, in these big complex distributed applications. So these big distributed apps really, they do everything they possibly can on code quality. And that's sort of the focus across all of these guys, is how do I, sort of get high quality product out? But we're straining these systems terribly. And a lot of what you were talking about with application insights, a lot of this tooling that we're seeing coming up these days, really, this tooling is really about how do we do a better job at monitoring things in production? How do we make sure that when we get code changes and we propagate them across the pipeline, you'll hear things like shift left and shift right, which is really about continuous delivery, continuous integration, and where we find things in the stack. Because I agree with sort of the commentary you made earlier, which is profiling and those things. People aren't doing enough of that in production, in particular. And the reality is that as much as we do with unit tests, as much as we do with integration tests, really until you're under load, until you're in those production environments, there's scenarios that you just can't anticipate. Software tends to only survive until it hits the first user, and the user starts playing with it, and next thing you know, God only knows what's going to happen. So OverOps, our whole business is really driven around, similar to when Praveen was talking about profiling. It's about running under your applications when they run in production. So in .NET, we run directly within the CLR. We analyze the bytecode that happens in the CLR, and we capture any exceptions as they occur. So logging only gets you to a certain point. Logging is really about telling, the developer put log statements in that tells you state of the system. But the challenge with that is that if the log statements aren't where you thought they were, then you really still don't have enough information for the developers to actually reproduce those cases and make them possible. OverOps' goal is really about how do we get you to that root cause when that exception occurred or when that error happens in your code. How do we get it back into the developer's hands as quickly as possible? And that really is part of what we see when we talk about the main challenges for the financial services space. So if you think about in the financial services, right, there's two terms that are really probably not well known in the development community, but they're super well known in the site reliability engineers, the guys that run these large scale websites and the large scale applications for their customers. And those two terms are MTTI and MTTR. And in net, what they really mean is mean time to identify and mean time to resolve issues. So one of the challenges in these financial applications, and really in anybody that's hosting these more complex apps, is the time to identify an issue, even if one's occurring, and recognizing it happened, is extremely valuable to these users. The sooner they can identify an issue, the sooner that they find it before it impacts their customers, the more important it is, particularly in these financial services areas. Something as trivial as a slowdown that occurs that's causing a transaction to time out. When you're in a financial services business and you're dealing with a credit card transaction, that could be the difference between whether or not that customer actually buys or they walk away because they got frustrated because they were timing out. So they can't afford that timeline for identifying issues in production environments to be very long. And a lot of times these things may happen silently. There may be silent errors. Your throughput may be gradually degrading. One of our customers we saw was having a problem with cache, and they were getting a tremendous number of cache misses, which was causing transactions to slow down. In a financial services aspect, that timeline is extremely important, where you've got 500 millisecond response time requirements in some of these areas. Similar to mean time to resolve is once you identify it, how fast can you recover? In some cases, it might be as simple as throwing sort of new hardware at the issue. In others, it's, I need to turn this around. I've got to get a fix out of my development group. It may be I have to roll back an application if I just did an upgrade, or it may be that I've got to turn around fixes. The more that you can give to the developers, the less that trial and error is. I think we've all, anybody that's been in development for more than a few years has experienced the, well, I can't reproduce it in the lab. Okay, let me add some more log statements. You run it, you get a new set of logs. That timeline can be extremely lengthy for trying to get things promoted back and forth between production. So the more that we can do to sort of help these companies, solve this MTTI and MTTR, which is really what they care about. And the reason they care about them are the bullets on the right. It's not just the fact that they can lose money. It's reputation, right? We all hear about it. When you see a big website go down, when you hear about, a major outage or a major transaction, that a bank couldn't process financial payments for a period of time. That damages their reputation. It can damage their stock price. So the ripple effects across a company for any kind of a significant application outage is very huge. And in reality, if you look at some of these places, particularly like some of the big financial services, they have more resources allocated to their development and to their engineering operations than they do towards some of the basic financial services cases. In cases some of these customers have 10 or 20,000 developers out there, they've got to make sure that those developers have the tools that they need to solve these issues. The ripple effects of these Sev1 bugs, they also tend to propagate through, and they can hurt your overall timeline. If I'm pulling developers off of new development to fix bugs, then the reality is that that ripple effect throughout my company winds up being extremely high. And the third thing that we see quite a bit is really about the who figures out what the problem is. The challenge is that right now in these microservices, just identifying the right team and the right person who can actually help resolve and fix that problem, that alone can tend to be a very time-consuming effort. And so what winds up happening is that they pull these war rooms together of 30 or 40 people. They're all sitting around trying to analyze a project. There's probably one person who knows what that fix is. So their big challenge right now is how do they reduce that MTTI and MTTR? The second thing is about avoiding downtime overall. Now, let's be honest with ourselves. Nobody writes perfect software. Nothing survives the first interaction in the wild. If you think about a system that is now composed of a set of microservices, and each one of them has a 99% reliability, and you say, yeah, so my system should be up a lot. Well, if I've got 25 microservices, my total product has a life cycle of about 93% or 92%. And that means that 8% of the time your system's going down, right? So when you hear about people talking about, hey, I need to get to five nines, is because it's the multiplying effect of where that downtime comes into play. Now, unplanned downtime versus downtime are two totally different things, right? There is planned downtime for system maintenances. You need to minimize that. That needs to be sort of as mitigated as possible. I can't take an entire credit card processing system offline. And that's where you see things like people doing A/B and canary type tests, where people are running applications, sort of in a test in a production environment. They're gradually swapping users over to it versus doing a wholesale system upgrade. Unfortunately, a lot of customers really can't do that. They just don't have the scope or the breadth to do it. So we really need to do everything in an industry to make sure that downtime, even in planned downtime, is as minimal as possible. System failures and unplanned downtime really is the stuff that's an ultimate killer, though. It's things that they didn't have an ability to prep for at a customer. Errors and failures, they're just going to happen, people, right? I've been working in this business for a long time. I've never seen bug-proof software, and I don't think we ever will. Perfection is not progress and perfection are sort of sometimes at odds with each other. And you really don't want to struggle for perfection in your software at the midst of progress. You have to accept that certain bugs are going to get there out there in the field. So it's really about understanding what is your failure strategy when these things inevitably go wrong. Are you doing things using feature flags? Are you dealing with things relative to rollback capabilities? Can I enable or quickly turn on and off specific features when things fail? How do I have built-in redundancy? So if a certain node goes down, I can fail over to other ones. The cloud does a lot of that stuff for us, but it doesn't come for free. There's costs associated in sort of active deploys. So it's really a lot of things that those customers care deeply about, particularly in the financial services space. And then really most of these customers and a lot of these enterprises are evolving from these monolithic architectures into a set of microservices and Lambda functions, understanding what those communications are and how they work. When a service goes away, or if a service comes up with a different version and it suddenly fails on you, how do you handle that? Can you roll back the microservice quickly? We had one customer, they were getting an error deep down in a component, in a module that they had been using literally for 5 years, and it suddenly started throwing null pointer exceptions on them. They were swearing, but they were looking at trying to figure out what happened. They were swearing that nothing changed there. The reality is that upstream on a website, somebody wasn't scrubbing an input parameter the same way they used to be, but it was propagating all the way down in the system. And it was just as they were swapping into and building these things more as services and using them in ways that they hadn't used them in the past, they were exposing errors that they had never seen before. All of these things, any downtime, it costs real money and it costs real reputation. So anything they can do to avoid downtime is stuff that we as in the software industry really need to be particularly sensitive towards for these people. Ultimately, it's all about the same thing that we all face with every day, which is this speed versus stability, right? There's a trade-off that you need to make between I want to get releases out as frequently as I can. Years ago, if you go back into some of these monolithic applications and sort of even the early versions of Windows and stuff, you had 2-year to 3-year release cycles. At this point, people are looking at daily updates in a lot of these sites, right? You don't expect your website or your iPhone apps, they just update, right? They just get pushed out to those updates. So you really want to drive that balance between speed and stability. And how do you balance that? That creates a lot of challenges across the spectrum in here. One is that we tend to generate a lot of interdepartment and across-departmental communication throughout the software lifecycle. We've got much more distributed teams these days. We've got different lines of communication. We really have to sort of focus on, are these teams coordinating and communicating well together? So if I change an interface, is the consumer expecting that interface to actually travel with it? We've got bad logging that pops out of these systems, right? Dave, I know you were talking earlier about logging and your logging framework, and the answer is logging's great. The challenge is that some of these sites get overwhelmed with too much logging. And one of the things that drives me crazy is that I've been out to a number of these larger customers in production where their ops people have literally turned off logging in its entirety, or they've set it only to error because the amount of noise in the logs that the developers was pushing out there was actually filling up their hard drives, and they just literally couldn't deal with their logging anymore. The other is that the logging gets stale, right? So you wind up with, I put a really robust set of log messages around the, some set of capability, and then I added 3 extra parameters into the function, but I didn't update the log statement to include that variable state within there. So you wind up with the logging is either incomplete or it's creating just a tremendous amount of noise. What that means is that it's got to go back and forth in these iterations between the developers and the site reliability engineers and the production people. And that drives, just the velocity is a killer. That totally will ruin any ability for these customers to actually get any significant velocity in their release cycles. And the fourth big challenge for them is this distributed workforce, right? We're global at this point, right? That's great, right? We've gained such tremendous benefit in the industry by going to this global distributed workforce. We've got pockets of expertise across the globe. We're able to take advantage of intellectual capital and of resources, in any place where those skills are available. And so that's all a great thing. The challenge is that creates time zone challenges. It creates communication challenges where we've got language barriers, where we have people use a lot of colloquialisms. I know I do. I use a lot of US slang that doesn't necessarily translate well. One of our core development sites is over in Tel Aviv. Their workday is Sunday to Thursday. Our workday here in the States is Monday to Friday. So we've got several days that we just don't even have a staff overlap for us to communicate through. The other is that we've got tribal knowledge that exists in the Tel Aviv site that they all talk to each other, but we don't always replicate that information to our group here in Orlando, and vice versa. So you've got to get really, really good in these larger enterprises about how do I distribute that tribal knowledge, whether or not it's through Microsoft Teams, whether or not it's doing better jobs on commentary, whether or not you're sharing things in Git or Slack and the various channels out there. We really need to make sure that those pieces are through there. We also need to look at it, the more that we want to do agile development, how are you coordinating your agile delivery with these global teams, right? They're on different timelines, they're on different schedules. There's things like SAFe, the Scaled Agile Framework and the like that are geared to deal with those, but a lot of companies don't really handle those. And then the third part is that, or the final part on the distributed workforce challenge really tends to be in the cases where, when I have these site outages, where I have these challenges on the site, and I'm pulling developers on a regular basis off of their product, it kills the employee morale. The morale of the development team, when they're constantly firefighting and they're not doing new features, that tends to drag down and really sort of can slow down your entire engineering activity. So, like I said, I mean, the challenge really is that on these financial services sides, the issues for those companies are really the same as they are for most enterprises across the space. The difference is more what the impact is, right? It may not be a big deal if you've got a minor site outage on something that's lightly used. But when you're a large distributed global provider of credit card services and credit card processing, you can't afford any outage, but you still have to get your software rolled out as fast as you possibly can. And you have to have the tools in place. One of the things that we've done a great job on in the engineering and in the technology industry over the years is we've done a great job of providing tools for the developers all the way up to the line of production. But we've never really focused well at the engineering side about how do I bridge between these developers and the complex production environments that are out there to make lives simpler for the developers. And I think that's really part of what things like Application Insights, some of the new observability platforms, Wavefront, some of those places are really focused on. It's also things that tools like OverOps and tools like some of the profilers. That's really what we focus on. It's about how do we enable customers to roll things into their production environment, to get their products out the door as fast as they possibly can, and still do it with a high degree of quality and a way to fix as quickly as they possibly can, so that when the inevitable goes wrong, you actually can recover from it quickly. And I think that's the majority of what I really wanted to sort of talk about today. I did see a couple of quick comments on there about big data and hybrid cloud. I will tell you, for all of the financial services, they're heavily invested in both, right? You can't be in the financial services space without dealing with big data in some fashion. In my prior life, we were all big data oriented. But if you think about the sheer number of transactions, if I'm a credit card processing company, the number of transactions that they have streaming in on a regular basis that they need to respond to quickly is enormous, right? Some of these guys, I was dealing at one point with FINRA, which is the financial regulatory industry in the United States, and they can get anywhere upwards from 3 to 10 trillion records a day that are popping in across all the global financial trades. And they need to process all of those. They need to be able to store them. They need to be able to monitor them. They need to be able to analyze those for regulatory purposes and really on that watchdog side. And so really they can't do that without the cloud. But again, I think Sarva had a question on hybrid cloud, and the reality is that almost all of them are hybrid cloud. Particularly in the financial services space, a lot of them are not going to a full public cloud. They're not comfortable with with putting all that information, even with high security that you have around AWS or around Azure or Google Cloud. In reality, what they're doing is they're building private clouds that they then will branch out processing nodes into public cloud capabilities, and they'll tend to blend their on-prem data rooms with a private cloud as well as a public cloud strategy for offloading heavy processing tasks and for heavy load tasks. And again, this is where tools like distributed tracing need to come into play. This is where profiling needs to come into play. It's where all of these, understanding how these moving parts all impact each other, because one piece goes out, it really truly is a weakest link problem, unfortunately. So that, I don't know if there's other questions I can answer, or I think we're sort of close to on time here.
Oh, there I am.
Yeah, there you are. Hey.
That was great. this kind of information is super important, especially from somebody who, deals with large systems like you do. Financial systems are usually pretty big, and your insights to this is really valuable. And and also, before I forget, I want to thank you for cutting your session down a little bit because I accepted too many speakers, and but I think we're planning to have you on the Rock of the Cold World soon, right?
That's the plan. I'm just trying to clear a weekend with my wife.
Yeah. Well, tell her, it's required for your work or something,
Yeah, exactly. I told her that. She doesn't like that answer.
Yeah. So I did have a question. So I know you probably deal with a lot of different systems and things like that, but what generally are you using in the background to do this kind of monitoring in your applications?
So in our case, OverOps itself runs both in .NET as effectively in the CLR. It's a C++ app, actually, largely behind the scenes. And then we also have a JVM monitor that's C++ with some Java in it. But we integrate pretty closely with those, both with sort of the standard Microsoft tools, Azure pipelines and dev boards, and some of those for monitoring and understanding things. We're looking at application insights as well. And then our SaaS version is actually currently on SaaS and on AWS. And we use quite a bit of Java on that front end. It's actually Spring Boot based. There's sort of legacy for where we came from. But we're seeing a lot of movement for us in integrating into some of these observability platforms like App Insights. The reality is that all of us and sort of developers and some of these other tools, these enterprises, they have every tool known to man. The last thing they want is a new one, right? And anything that you're trying to provide information out to an end user for, the more you can bring it to the tool they live in today versus asking them to learn a new one, the more value they're going to get from it. So where we see a lot of our uptake is we will automatically generate Jira tickets. We'll automatically notify through Slack or Teams. We'll automatically tag things in GitHub so that we can actually, if we see an error occurred, we can actually trigger a message using Git blame to tag a commit as, hey, this thing just caused an error in your build environment.
Mm-hmm. Yeah. Well, I can't wait to have you on my show. It's so much information in 30 minutes, and so I really appreciate you taking some time out of your busy workday, and make sure you get with your guy there, and let's set up a show soon. I want to have you on the show soon.
Will do. I look forward to it.
All right. Thanks a lot. That was great.
Thanks for the opportunity today. I appreciate it. Take care.
Thanks. That was a great session. I can't wait to have Bob on my show again. It's a lot of great information. It's something we need to think about, especially in this cloud world. And, the other thing I keep forgetting is that, performance is super important, especially in the cloud, because in the cloud, you're being charged for everything you're doing. So if you can, squash your performance down, you get a lot of cost savings. And so anyway, this is why it's so super important. So can you bring up my slide? So before we bring on Mahesh, one of my close friends, I'm really excited to see his session. I wanted to talk a little bit about, again, that we're raising money to help the kids in the slums in India with that are affected by COVID-19. COVID-19 for everybody else around the world, COVID-19 is not doing well in India. They're having a really bad time right now, and they're opened, which I'm not sure why, but they have no vaccine. So we really need to help support the kids there. So please go to that link and donate as much as you can. We will really appreciate it, especially me, because, I really, have a close connection with people in India, and I hate to see any more people, suffer through this terrible thing we're dealing with. And actually the India strain is actually in America now. And there's some parts of America that are getting worried about we're going to have an uptick in cases. So, but anyway, I hope you'll donate to that link. You'll have my undying gratitude, that's for sure. Let's do a giveaway. I think we're giving away an Amazon gift card right now, right, Simon?
Yes, David.
Yep. Are we doing the Amazon gift card now?
Yep, we're doing it.
Okay, so the Amazon gift card, please make comments and tag it with code QualityConf21, whether you're making a comment in the chat window or you're doing on social media. Those are the ways you can win. But make a comment, just don't comment the hashtag. That doesn't count. And so make sure you make a comment, and so we can know that this conference is helping you guys out. And so, yeah, so let's give away the Amazon gift card.
All right, David. So we went over the social media platform. Many people commented it, and the person that we found out who has been very active at commenting is Mridul.
Yeah, can you make that a little bigger? Okay, great. So congratulations, you win a $25 gift card from Amazon. I wish I could win one of those. And so with that, congratulations. Make sure you make your comments so we can give away some stuff during the breaks. And with that, I want to bring on my the next speaker, Mahesh. He's going to be talking about top 10 tips for architecting secure first software, which is super important these days.
Hey, David, how are you? Good afternoon from Philadelphia. I'm here.
So you don't get a video before your session, I guess.
No, Simon is just being, he pick and choose whoever he likes.
I guess he doesn't like you.
Yeah, definitely not.
How's it going? How's it going there in Philadelphia?
Good, all good. It's nice weather. I can't complain. I was outside all day yesterday, and working on my garden, my flowers. It's beautiful. It's like 75 to 80 degrees, and you saw my Twitter photo.
I did. I saw the photo of your patio.
Yeah.
I wish I was there.
Yeah. Hey, listen, you can come anytime. You're most welcome to come. Just stay here for a couple of weeks, work from here. Who cares?
Yeah, you have a huge house, right?
Yeah, take a trip. Yeah.
I got some miles.
Listen,
let's do it.
Yeah, whenever you want to, I'm here.
I want to get the heck out of San Diego. So far, I went to San Jose about a month ago, and I was so excited. I know San Jose is not very exciting, but I was so excited to actually leave my 10-mile bubble, that I've been living in for about almost a year and a half. And even going to San Jose excited me. So, and I'm actually from, I actually was born in your neck of the woods. And so I have
Delaware, right?
Yeah, all my relatives live there. So in Delaware or Maryland. So anyway.
Yeah, whenever you want to take, just book a ticket and just come and let's talk after this.
Okay, great. So.
Yeah. And again, thank you for having me here. This is great. Looks like it was awesome, great session on performance. That's great. Looks like giveaways are great, and I think we appreciate all sponsors helping us. Grape City and Stratus. Thanks for giving away all these nice goodies. Keeps people engaged.
Great. Well, take it away. I'm looking forward to your new talk.
All right. Thank you. First of all, I want to thank David for organizing this conference. It's a kind of unique. Just focused on quality, right? Code quality and performance, which is a big thing actually. If you are writing software, and if you don't keep in mind the quality and performance, it's a problem. It's a problem in long run. So in this session, however, it's a little different. I want to talk about security, right? Security. And I call it the secure first software. You probably heard other, cloud first and so on and so forth, but this is secure first means what it is. In this session, I'll talk about what secure first is. And when you are either a software developer, you're a front-end developer, back-end developer, you're an architect, lead, or even a full-stack developer, or a database DBA or database developer, doesn't matter, whoever you are. The goal here is like how to build the secure first software. So Simon is going to drive me. Somebody who doesn't know, my name is Mahesh Chand. I'm founder of C# Corner. I run a company, Minscracker Inc. here. And I have been running this company, Minscracker Inc. is a software consulting for past 20 years or so. All these experience I'm going to share is based on what we learned from when we build new software for our clients, and some are for ourselves. So when you think of a software security, right? When you are, let's say you are a software developer and you're building a software, a client comes to you or your manager comes to you, hey, we have this new application we need to build. So most often you don't think about security. You look at the UI, you look at the requirements, you look at, okay, what kind of backend database we need. However, you don't really spend too much time on security on day one when you are designing and architecting software. And that's really I want to talk about today, is that software security is not just a job of IT people, okay? That's one thing sometimes people really kind of think of it that, oh, it's a security, it's probably the security team will handle that. That's their job. But that's not how we have to think. No matter if you are a front end, you're back end, or even writing APIs, you're working on databases, or you're managing your servers and networks. Everywhere you have to think of security. And you would say, why do I need to think about worry about security these days? Because there are more than 1 million hacks every day. Not hacks, at least attacks. Cyber attacks. There are more than 1 million cyber attacks every day coming from different parts of the world. So I don't know if you hear these news, but they're always, okay, today's Twitter account got hacked, Twitter database got hacked, Facebook got hacked, Target got hacked, all these financial services are getting hacked. Why are they getting hacked? Because there are not enough security, measures in these softwares when they were built, and not just from the backend side, not just from the hardware side, but also from the software side. This session is for everybody. It's not just for software developer. It's basically from you. You're a front-end developer, you're a back-end developer, you're an architect, you're a lead, or even you are a data. Everybody. At least there are some tips in here. And again, this because we're gonna shorten this for 30 minutes. So I'm just gonna go run through these tips. If you want to know more details on these tips, there are certain articles on C# Corner. Or there are some references as well in this document. If you need this slide, I will share this slide. Simon, reach out to Simon. He can share the slide with you. So let's think about the security first design principle. And before, one more thing I forgot is please let us know what you're thinking about this conference. Are you enjoying it? What is your feedback? Because we may end up doing this every year. David would probably love to do this once in a year. Any feedback you have for us, for David, for Simon, what else you would like to see in this conference? Did you learn anything from it? Post your comments, share your comments, win some prizes. But definitely, give us feedback, because without the feedback, it's hard for us as speakers or even organizers know that are we doing these conferences? Is it even worth doing it, right? So more feedback we have, better it is. So, all right, so let's get back to this session, security first design principle. So what does that mean really? That means when you are architecting a new software application, it doesn't matter, it's a web application, is it a mobile application, it is even a client application, or it's an enterprise-wide system, or even it doesn't matter what kind of software you're building. When you are design and architecture phase, you're sitting down and designing with architects or your leads and working with it. That time you also have to think about the security. You cannot just say, oh, we'll think about security later. That's not how you should be thinking in today's world. In design first principle, everyone in the team has to include in these security discussion. It's just not software developers. It's just not DevOps. It's just not IT people. Everyone in the team, front-end developers, back-end developers, architects, DevOps, engineers and testers and IT, whoever is managing the servers, they all have to sit down and work on this together. This is not just one person's job. So that's what really security first design principle means. Also, it's very important if you read latest blogs from, say, Microsoft or these companies, you will always see there's more updates coming. Every time you see a new framework updated, every time, say, Microsoft updates .NET framework, there may be some changes related to security, related to authentication, related to authorization. You have to keep up to date with your data. It's just not like, oh, I know already how to do this in previous version, because security is changing very frequently, because patches are coming up, a lot of things change there. So make sure you keep up to date with those. So let's look at some of these tips. So, and again, in my title, it says top 10 tips, but it's more than actually top 10, because what I did is I end up separating these for the front end, back end, and server, and so on and so forth. So these are some of the tips I will run through. And obviously, I can't go through all in details, because each of these tips really a one session on itself. So if you want to learn more, there's separate articles on C# corner and everywhere on the web. If you search, for example, how to implement HTTPS in a website, you can just find a lot of articles on that. So I'm not really going to explain in the detail, but I will just go through these tips. If you have any questions related to these topics here I'm mentioning, just let me know. Just post questions. We're going to have at least 5 minutes in the end to take some questions. Hopefully I'm not going too fast. David, you good? Simon, you think I'm good? All right, looks like I'm good, because no answer is a good answer, right? So first thing is, make sure every website, if you're building a web system, public website, or even, make sure it's HTTPS. That's the first requirement these days. All browsers, if your website is not HTTPS, some of web browsers actually not is going to show you. Google already announced that Chrome is not going to display your website if it's not HTTPS. And HTTPS, what it does is really, when a client, a person visits your website, let's say they type in the browser your website URL, if it's HTTPS, what happens is that the data being sent from the server to the client is now secure, encrypted. So that kind of is one of the very, very basic feature you can implement to make your website secure. If you have an API, for example, don't keep it HTTP, make it HTTPS. It's not really hard. It literally takes, I would say, less than 2 hours to enable and make your website or your API HTTPS. There's a lot of articles out there, and it's free too. You don't need to even pay. There's certificates that are free. So that's one thing you can do that. Now, second thing start with that is, I always, I talk to developers. We start a new project, and I go and, for code reviews and audits, I'll go and I'll ask developers, like, hey, is your connection string secure? But like, no, we will come back later. Right now, it's just in config file. Or, oh, right now we have a connection string variable in our code, and that shows everything, what the server name is, user ID, password, database name, everything is there. I understand you can go and fix that later, but that's not what secure first design principle is. Secure first design principle is that from the day one, you have to make those secure. You have to make sure all your connection strings and your login credentials, they're not in plain text anywhere in your config files, in your app settings, in your code. That's rule number one. And because I know how developers think, and that we will do it later, and later may not come never, right? This happens all the time. Number three, you got to enforce complex password and with rules, right? This is very important. If you look at the history, if you look at all the data coming from hacking, like bank passwords, have bank accounts hacked in, the reason they're saying is that most people have these simple passwords. You know what is the most common password is? Anybody? If anybody can answer what is the most common password used in the world, they will win. Let's say what? I would say we'll give away 100 stacks to them. 100 stack is worth probably $115, $120, $30. So if you can tell me what is the simplest password in the world, which most people use, you will win this 100 stacks. I will answer this later if I don't see that. Yes, keep those coming. You will be surprised. One of my articles actually I made on, it's an article on C# Corner I wrote. I made a list of, I think, top 20 passwords, and you'll be surprised. Even like some US senators, their passwords like very common, which is default password. Also, let me ask you this. How many times you guys, let's say your email is created by your admin, how many times do you go and change that password? Unless it's not enforced, right? Think about that. That's where most hacks comes is. So when you are building a new web page and login functionality in it, make sure from the day one, you enforce these complex password rules. If you have a server, make sure you have policy that every 30 days or 90 days, password has to be changed, right? If you have, let's say number 4, let's go to number 4. If you have a form where you're asking the data, email, somebody wants to contact you and all that, make sure you disable bots, because that's another way. Bots are checking your emails. They will send you this some kind of message on your website, and that will have a link in there, and somebody is going to click on that link to just see, and boom. So these are some things as software developers, these are our responsibility. When we are building this, software, this is our job to keep this in mind. And make sure you have number 5 is industry standard authentication authorization. So don't just use what you've been doing for so long. Make sure you also update yourself. See any change I've done in .NET framework for authentication authorization. And there's changes all the time. If you look at every year, new version comes out, there are some changes. Look at number 6, don't expose code, right? So I have also seen that JavaScript files from time to time. Code is there, everything is there. If you look at the JavaScript file, you can literally see everything. So try not to put everything on the client side. Number 7, implement acceptance error handling has to be thorough. That should be from day one, right? And then don't rely on server security. As a software developer, you cannot say that, oh, my IT or servers are secure, we are good. Sometimes, I hear from people. I hear is that, oh, this is just internet-based application, so we don't really worry about security because only people in the company are going to access it. Yes, agree. But it doesn't mean that you cannot implement security on the front end, right? Imagine in your house, when you think of security, think of this your house, right? In your house, you have a safe, which is locked, and then you have money inside that. Your money, you have gold, you have watches, everything in your safe. And you say, oh, my safe is locked, so let me leave my door open. You think that's a good idea? So front end is your door. Front end is the house, door of your house. You cannot leave the front end open so thieves can come in, walk in, and go to the safe and steal the, in this case, is data. So you have to think this is our responsibility as software developers and front-end developers is to make sure that these points are discussed in our design and architecture meetings. I hope you guys learning something. Let me know your comments. Oh, by the way, I'm still waiting for, let me see, password. Nope. I don't see the password, which is most commonly used by, by most people. Yeah, but I'll tell you right now, it's called password 123. Password 123 is the most common password in the world. So that's the answer. So this, so we just talked about the front end security. So if you are a software developer, front end developer, you cannot just say that, oh, I just need to build the UI. I'm not worried about security. This is not my job. There's an IT guy, there's a security team. They're gonna come back and look at that, because security. IT guys don't think on software terms. They think is if their server is secure, the network is secure, they think everything is secure. But do you really know that 62% of hacking is done through front ends? Not from the back end, not from the servers, from the front end. That means the door of your house. You cannot leave your door open. That's important part. Yeah, thank you, Joe, for comments. Yes. Password 123, there you go. It's not even at the rate, actually. It's a password 123 without at the rate. That's one of the most common. All right. So that was, so you just saw the front end security. So if you are responsible for building the front end, you have to keep those things in mind. I can add 10 more things to that, but that's the minimum thing. If you take care of those minimum things, automatically your software is more secure than it was before. And these are not hard to do. That's the good part. All these things we just saw earlier, they're not hard to do. Code is already there, functionality is already there. All you have to do is make sure you have in your checkbox in the, yes, we did this, yes, check, 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 check. Once you do that, your software is already way secure than it was before. All right, so now we talked about front end. Let's go to data security. So data security also, again, it's not just DBAs, it's also in job of developers, right? A lot of us, we work on database as well, right? If you are a backend developer or you are a full stack developer, we end up doing all the work. We end up creating database tables, we create store procs, we also work with the data direct, right? DBAs are great, they will initially help, but in most cases, in some large corporations, DBAs do control the database. But if you are a DBA or a developer working with the databases, there are some things you also need to keep in mind. Number one, encrypt sensitive data. From day one, I have seen again and again and again, the most systems are hacked because databases store the emails, the password, the logins, the credit card, they're all plain text. If you're using any of the latest databases, SQL Server, Oracle, doesn't matter, whichever, as long as you have one of the latest versions, they have these features where it can automatically encrypt those columns and it decrypt automatically. There's not much overhead. Okay, it's not going to affect performance much. You won't even notice it. Those features are already there. Okay, so yeah, and it's all there. It's all there. All we have to do is make sure it's implemented or it's like enabled, right? They even suggest that, I just saw the other day SQL Server team announced SQL Ledger. SQL Ledger is pretty much a blockchain in SQL Server. It's not a chain, but at least it's the same. It's basically it's an immutable database. Let's just say that. Immutable means once it's written, nobody can go and change it. So if hacker goes and try to change the data, they can do that. So the point I'm making here is that the functionality is there, the feature is there. You just have to go and look at it and make sure it's enabled. Make sure it's implemented. If you are using SQL queries or, make sure it's there. It's done, implemented there. Number two, SQL injections. Look at that. 62% of cyber attacks. I did research on that. 62% of cyber attacks are done through SQL injections. So, that's kind of thing you have to make sure. And number three, embedded. I still see some people writing queries in their HTML, JavaScript files and putting all there. That's the bad way to do it. You do not want to expose your database column names or anything in the front end side or client side. Server side, okay, sure, maybe. I still don't recommend SQL at all. Personally, if you ask me, I'm not a big fan of putting SQL in code. It should not be there at all. And we just talked about number four, the SQL immutable ledger. Number five, yes, this is very important. Do not, when you are creating new database objects like tables, store procs, by default, it should be read-only, okay? It should be read-only access, and it should be minimum access to the users when you are creating those roles and users. Only admin should have more control over the things, right? But let's just say you have an application that's going to read and write and update and all that. Then you just create a separate application user, and you have to see what functionality. Sometimes one user may just need access to 3 tables, so you have to figure that out. But you have to make sure you look at the right roles, right permissions, and by default, they should be the minimum access required. That should be the default. It shouldn't be default like make admin. Sometimes what developers do is, or non-DBAs, they end up doing is like, what, I'm not going to come to this. Let's give them admin access to everything. So that's a bad way to do that. That's definitely, you do not want to do that. So yeah, let those comments coming. That's exactly, yeah. Joe said DOS, those attacks are nasty. Yeah, you're right. And then that's where history tells us. We should learn from history. There is a question how to overcome from malware attacks. I have written actually a perfect article on that on C# Corner. Maybe Simon can find it and share that. It says how to keep your data, secure. I did a lot of research and I wrote a detailed article on that. But I'll take this question in the end. So let's move to our next screen. So we just talk about the front end. We just talk about the data. Now, if you are working on a back-end code or APIs, there's definitely you need to also think about security. You cannot just say, my database guys are taking up database, my front-end guys taking up my front-end, so I'm good. You need to think about security as well, right? So here are 9 tips here. Secure APIs, you have to figure out the latest technology. If you're using token-based authentication, whichever it is, make sure it's secure. Obviously, it has to be HTTPS, rule number 1. I talked in my previous slide, right? You have to definitely separate read-only and write APIs if you can. I know developers love, creating just one single API, call, and that's where you can do all that. That's great, but you have to look at, is it going to impact this? There are security problems with this. If that's the case, you have to fix those holes, right? Definitely do not store sensitive data in plain text. Do not also input parameters and user validations are important. That's very important sometimes. Input parameters and user validations are important. And what I'm seeing on our C# corner on forums, we don't have, I'm telling everybody what to do, but even on C# corner, we don't have some of these user validation input parameters. Sometimes people can just type ABCD and that will be the title of the forum. Sometimes they can start. So the point I'm making is that even though these are little things, but they should be part of our day one design, right? Let's look at number 5, implement logging and capture exceptions. That's very common, right? Passwords, if you are storing password and passing through, hashing is the best way to do it, because good thing is hashing, nobody can read it and nobody can find it, what your password is, right? Only user can change it. And these days, passwords, you see, these days also the double multi-authentication, right? You can implement all those as well. Number 7, never expose sensitive data and URLs, right? This is not always do. I've seen sometimes you will see, okay, in my URL, I can see the ID in there. Sometimes you can see the, bunch of data. That's just do not pass that if it's any sensitive data. I'm not a big fan of URL, too much data being passed in URL anyway. It also makes your URL too long. Implement latest industry standards. There's so many tools out there, third parties for being used for these authentication. If your company is implementing that, look at those, right? Most large corporations they use one of those services. So if you're using that, that's great. If you're not, even you don't want to use, that's fine. Make sure you look at Microsoft or whatever technology you're using for latest security guidelines, right? There's always guidelines released by Microsoft, Google, whichever technology you're using, right? So make sure you read those. These are important. And this is not just for security team. This is not for somebody called IT security, okay? That's different. I'm talking about software developers. So software developers also need to become at least these security experts, at least considering these points. If there are requests, timestamps also helps, because then you can easily audit and track things like that. So that will also help. Now, you want more details on that? There's a detailed articles on each of these topics on C# Corner. Again, as I said, if I start talking each of this is pretty much one session on each of these topics. I just want to make sure I cover these. So when you take a screenshot of this or you download, then you can go and read these details, how to implement, depending on what kind of API you're building, right? You're building API using ASP.NET Core, then yes, it's different. So you have to look at how you are going to use these, tips in your software when you're building. And now this is the last one, server security. Server security is more for this is for the IT people, right? This is not for software developers, but that's where IT people will work with, say, architects and lead developers to set these. That's how you manage servers, right? Make sure we got hacked actually early last year just because our hosting company did not have the latest patches. Okay, C# Corner got hacked and we were hosting with the Rackspace. and we got hacked with this WannaCry ransomware, which asked for bitcoins because this came in 2017. That means they have not updated some of our servers for that long. Server means operating system. I'm not talking about the software. I'm talking about operating system. So security updates and patches, that's where IT teams, they do already. I'm not saying you are going to do that. This is not as a software developer's job. This is mostly IT teams. But when you are in the meetings, when you are designing the software secure first approach design principle, you're going to put these points and make sure IT team is also on the same page. Firewall and port security, that's by default. Every company does that. Separate environment for dev, QA, prod, that's pretty standard. There's nothing new here. Separate hard drives. This is very important, number 4. Right? Separate hard drives for web versus storage versus permissions on those hard drives. So sometimes you have this website where this website may also have people upload files. If they're uploading files, this should be going totally on different drive where just in case something goes wrong, it does not affect your website, does not affect your database. And again, I'm running out of time here, but we can still quick run through these. Disable any scripting. Scripting and write permissions should not be on any hard drive by default. Only limited number of access. Yes, by default should be the limited number of access. Separate databases in web servers, definitely. Monitor apps, logs. So this is more like IT people. Implement, again, do regular third-party audits and make sure update yourself with latest changes in that operating system or security patches. Microsoft releases security patches every week. I can tell you that's the fastest thing they release. So that's something to look for. And these are some of the references. If you like to have this, again, this slide, I will make sure Simon has access to that. He can share the slide with you. But if you keep those some 20 some points, 25, 27 points in mind when you are designing a new software, I bet your software is going to be much more secure than without these. So that is all from these tips. I hope you enjoyed it. I hope you at least learned something from it. I think we are running out of time. David's here. You're mute again, David.
Sorry, I keep doing that.
No worries. No worries.
That was great. And, we kind of went over a little bit, but man, I have so many bad security stories about, what companies do, like even, one company I worked at 10 years ago, I talked to the architect and I said, we need to make sure this is all secure before we go live. And he goes, no, we'll do that after we go live.
Exactly. Exactly.
And from then on, I never listened to a word he said, because if our architect is saying stuff like that, I don't really trust anything he says, Yeah,
and, listen, because we think that, our job is to build the house without the locks, right? Imagine building a house with no locks and no doors and windows, right? It's all open. Go ahead. Hey, house is built.
Yeah. I could talk for hours on all that stuff I've seen. It's crazy. And, even at that same company, on another feature we were working on, I tried to get the QA team to be in on it from the very beginning, which I think is a very important thing.
Yes.
The QA team, security people need to be in discussions when you're planning what you're doing before you even code, right?
Yes, that's the first step.
Yeah, and I think they came to one meeting, and that was it.
Yeah.
And so, yeah.
Yeah, thank you, everybody. Yeah, thank you, Joe, for listening and all the comments, awesome comments from, KR Reddy, Candy, everybody. Joe Muller, thank you. Appreciate it.
Yeah. While you were talking, I was looking up airplane tickets.
Oh, there you go. Yeah, listen, whenever you just let me know. If you come around July 6th, before that, we'll even go to Atlantic City. My son has tournaments. So let's do after. Let's have a call. We'll figure it out. Yep. Yeah. Thank you, everybody. Thank you so much for joining my session. Again, reach out to Simon if you need those slides. And David, thank you so much for hosting me. This is awesome. Simon, good job again, and team behind the scene. Awesome. Thank you.
Yeah, thank you, Mahesh. And that was really great. The one thing I did think I want to part with is, this is such a big topic. I think we need to do a conference just on security.
Yep.
Yeah, especially these days with all the hacking that's going on and the craziness and stuff like that. Yeah, we should do a conference, like that someday in the future.
Yep, absolutely.
All right. Well, thanks, Mahesh.
Thank
That
you
was
all.
awesome. Yeah. These are really great sessions so far, and I'm having a good time listening to all this stuff. I think this might be the first conference I listened to the whole thing.
Nice.
But that's only because I'm hosting, right?
Yep. You have no choice.
I kind of have to listen to it, right?
Yes.
All right. So let's go back to the slides and the giveaways. Again, we're raising money for the kids in the slums in India to help with COVID relief. So please go to that link and donate, as much money as you can. And I'm talking to the developers not in India because I know, they don't make near as much as the rest of us do. So I know you guys can give something. So please go to that link and give some money so we can help the kids in India. Let me make sure I'm on the right slide. So let's do a giveaway. So the giveaway we're going to do right now is my book. You'll get an autographed copy, and I'm going to put in some other swag and stuff like that. So you're not going to know what you're going to get, but you get an autographed copy of my book. And this will be shipped anywhere in the world except for Middle East because there's some kind of shipping problem there. And so, Simon, do you want to pick the winner? It's coming. All right, there you go. That's who won my book. So congratulations. And Simon will be contacting you because I need your shipping address because I'm going to ship it from here. And so I need your address. So congratulations. And the next break, we're going to give away, more things. So thanks, everybody. And I want to mention, especially to so forget his name already. Joe Bankin. Joe's been doing a lot of comments, and I really appreciate that, Joe. But you have to use the hashtag pound code quality comp 21 to win something. So next time you do a comment, Joe, make sure you do that so you can win something and before the conference is over. So I want to bring on the next guest. Next guest is Vitaly from the Ukraine. And he's going to be talking about testing your web apps. Welcome.
Yeah, hi.
Did I pronounce your name correct? Did I pronounce your name correctly?
Yeah, right.
Okay.
Vitaly. Yeah.
Great. And before you start, I didn't realize you were from the Ukraine. And I was in the Ukraine in 2015 speaking at a conference there in a user group. And I've been dying to go back ever since. I love the Ukraine. I wasn't sure I was going to love it before I went there, but man, I fell in love with that country. Especially the food, and the food there is amazing, and all the old. I went to 2 castles that were built in like the 11th century or something like that, and I had such a great time in Ukraine. I really want to come back. So I want to put it out there. The next time you guys do a conference, make sure you let me know. I want to come back.
Yeah, great. So which cities did you visit?
Lviv.
Oh, yeah, it's really great. It's a small city with different historical places and cute streets.
I loved it. I stayed right in the middle of downtown Lviv at a really old hotel. And man, I hated leaving. I was there 5 days, and I remember the last day I was at the top of the hotel eating some food, and I was going, man, I don't want to leave. And And the people there invited me to come back in the winter because I hear you had some beautiful winter festivals and things like that in Ukraine, right?
Yeah.
Yeah. All right. Well, I don't want to eat into any more of your time, so go for it.
Okay, thank you very much. I'm happy to see you all here, and let me start. So the topic is testing your web apps on ISP.NET. So I'm Vitaly Honcharuk, and I'm a full-stack software engineer, and I mostly work with C#, .NET, Angular, SQL, and Azure. I have more than 8 years of experience, and okay, the goals for today's topic. So we are going to get acquainted with the testing pyramid, and we are going to understand different software testing types, software testing methodologies, and get acquainted with BDD. So in case somebody didn't hear about it. So if to go in general about software testing, so here is a testing pyramid. I hope you guys heard about this, and if not, so let's go through it. So it's described the different levels of testing that like ideally should be present in your project. Manual testing should be less than 10%, or even don't exist on your projects. And also sometimes in case it's like a big projects, there should be automated GUI tests, and this ideally should be performed by automation engineers. And if to speak about automated API tests, also we have like 3 levels of integration testing, and one of them it's automated API tests, automated integration tests, and automated component test. And usually all of them are done by software developers, and some of them, like API tests, can be done by QA automation engineers. And surely, like we probably in almost all projects, we have unit tests, and it's also usually done by software developers. And what I want to mention also that if to look at this pyramid here at the bottom, we can see that if we go down by this pyramid, we see that there are much more surface. So it's like a little. It's like more unit. For example, unit tests we have much more than integration tests, and integration tests more complex, and it's. Okay, if to look from other perspective, here at the bottom we see that tests amount is on this axis, and the fragility and coverage and duration, effort to support and effort to implement is on this side. So if to go a little bit deeper into it, we can understand that integration tests can cover much more components at the same time as unit tests cover only some single components. And many developers know that we can't create a lot of integration tests without stable environments, because integration tests always depending on the environments, and that is why it requires a lot of effort actually to create it, to support, and when it uses real database, it takes much more time, and and yeah, it's more fragile. So let's go probably to another slide and speak a little bit more about what I've noticed. So on in small non-tech companies, usually I don't see like a separate software testing role. So software developers test their own code. So I guess it's not applicable for, for building great software, because software developers should not test their own code. But in like non-tech companies, like managers may not fully understand about necessity of having the separate role to even have more than one developer, more than one engineer to test each other code and implementation. And also in many projects, lack of unit integration and automation tests, or they like these projects can even don't have tests. So this leads to manual testing, and this has really long-term implications. Actually, let's go to this slide first. So if to see on this slide, like on this axis, we can see, okay, on the blue axis, sorry, on the blue line, we can see like manual effort for doing testing, but on the orange line, sorry, forget. On the orange line, we have like automated testing, and if to analyze this, we can see that integration or automation testing, it requires much more effort at the beginning. That is why in most of the cases, teams decided to not to start creating unit tests, integration tests, and automation tests. But after some time, when a project grows a lot, and while it's growing, the manual testing effort become much grows also, and at some point cost of manual testing and regression will be equivalent or start being even higher than having automated and integration tests, and this brings in my mind the idea that many teams should estimate, should include to the estimate of project development that time to create environments and all required for integration tests and automated tests in case it's really needed. So that is why this point will be never met, because in case team will spend half of the sprint or the whole sprint to create, to prepare everything to have integration tests and automation tests, they will not spend time on manual testing a lot like this, like here. So and if to see, also in the how to say, so if to dig into the cost of the bug, if you will write this query to Google, you will find such table in the Wikipedia, and here you can see that it's like approximate estimation of the cost of the bug when it's found. So in case bug found on the requirement stage, this will cost 1x. And in case this will be found on the post-release phase, it will cost 10 to 100 times even more than it's like found on the requirement stage. So really cost to fix will be really high in this post-release stage. And here, like, you can see and get some ideas when should be found the bugs. So definitely on the requirement stage. And from my experience in many projects, there are many issues, many problems with the requirement stage. And I think the most, like, a lot of bugs came from there. A lot of communication effort involves, because in case requirements are not clear, developers often start like creating additional groomings, additional meetings, communicate between each other, and try to find the truth. Where is the real requirements? And actually, this is a pain for many projects. So let me read through what did you write in the comments. Maybe there are some questions. Yeah, thanks for welcoming me. So here is a question about usability testing. Actually, usability testing, it's more about QA specialty, but here I am speaking about like more programming testing, like unit tests, integration tests, and a little bit more. So here is like a full, probably almost a full hierarchy of testing, and here we can find a lot of different like testing testing methodologies, testing, how to say it? Okay, different testing ways, and we will not dig into it and continue to integration testing. So we have different ways of integration testing that I actually already mentioned. And if to speak about simple integration testing, it's usually done by developers. And so integration tests, they need it needed for test a bunch of code nodes and components. So for example, business logic along with database calls and calls to other services in case it's actually needed. And this is like almost the same as unit tests, but with some real implementation. So it can be tested partially as a system, because always when you have, for example, a bunch of microservices that are dependent between each other, and it's probably easier to test 1 to 2 to 3, for example, services, and mock some dependencies to some other services. And if to speak about API testing, it can be done by developers and by QA automation engineers. And in this case, like actually testing API, this is required for testing API for expected behavior, for example, with REST API calls. And it may be implemented on C# and in the same way as unit tests, or any other language can be used with which actually has testing frameworks like NUnit, like XUnit we have in C#. And what also I need to mention that this probably will require to have a QA API. Actually, what does it mean? In different cases, for example, for creation scenarios, we may have like creator and endpoint, but for example, for getting this data, we may not have this endpoint, or and that should be probably created in separate QA APIs that will be only visible for for like testing environments, for development environments, but hidden on production. And yeah, same probably will be required in case you, for example, case when you have some special system notifications that should be created for user once some, for example, event in the system appears, and this case like cannot be easily replicated, and this will definitely require to create some test QA API to create such notifications like on demand for tests. So I'm reading through your comments. Yeah, that's true about Selenium. Selenium is cool things. Yeah, and yeah, let me tell a little bit more about it. So automated UI testing, it's probably another way to do integration testing, and this can be done by developers and by QA automations. But usually, from my like experience, it's usually done by QA automation engineers. Because it requires, again, to have a separate QA API to get to expose like more data from the database to make assertions and so on. And this can be done. This automation tests can be done by Selenium or Tosca framework. Tosca, it's pretty new one that is really awesome, but costs a lot. So yeah, let's go to the next slide. And restrictions to the integration tests in comparing with unit tests, it's probably I already mentioned, it's take more effort to implement and support, and it's very strict to test in environments and like third-party integrations, and also it's very strict to existing database version and existing data. So it's like not easy to have lots of integration tests. And if to like speak a little bit more about how we can do integration tests on in C# and especially in XUnit, there are some small tips that may be useful. So like from my experience, I found that sometimes for integration tests we use in-memory database in case we use like entity framework, and this can be a little bit tricky because like with in-memory database, LINQ will not be translated to real SQL, and this may cause like fail. It may really fail on the real database, for example, in production. In case on testing environments, you use like in-memory database. That is why like ideal way or to eliminate this issue, you can do integration tests on the, for example, SQLite or on any real database. So yeah, and other like tip for actually XUnit to have. For example, to share the context between different tests, you can use a constructor and dispose it for each test. And if you want to share context for different tests in the same class, you can use class fixture. And to share all the like to share context with, for example, database or other connections or other useful things, you can use collection fixture, and this will be easy to use for several classes. Also, other way how to do integration testing in C# in .NET applications, you can use Microsoft ASP.NET Core MVC testing package, and this is a very useful thing when you want to run the server and replace some dependencies. So let me go deeper into it. So this such integration tests requires to have a test project that will contain all the tests, and this will be an entry point for running tests. Sorry. And this test project will have a reference to system under test. So in our case, it may be some web application. And this test project will create a web host for the system, and will use a test server and client to handle requests and response with this system. And this test runner will be used to execute the test and report to the test results. And actually, this package doing everything under the hood for this scenario, and it actually copies dependencies to dependencies file to the folder, and this sorry. So it will copy all the dependencies in the bin directory. Then it will set the content root to the web application project root. So the static files and pages views will be found for the tests and will be executed. And this library provides a web application factory class that will be easily used to streamline and bootstrapping the system web application with test server. And actually, I will try to show, in case I will have time for this, and yeah, let me just continue. Yeah, the cooler thing that I found from this library is that, along with creating a test server and providing a client for it under the hood, you can actually provide stubs for third-party services and check your system partially integrated to your environment. And yeah, this is awesome. And if to speak about as a way of integration testing, yeah, as already mentioned, we can do automated UI testing with Selenium. And this is end-to-end test tool, and it's usually a tester's tools, but yeah, it can be useful for software developers to understand how does it work. And if to speak briefly about it, Selenium has different different languages support, and C# that is awesome for us. And this actually, Selenium uses web browser driver, and for example, in case we use Chrome, it just operate with this browser driver and open a real browser, and then it make swipes and find objects on the page, like components, HTML tags, so by CSS selectors and so on, and how to say, interact with the page like a real user. And it can wait while some parts uploading, while some AJAX calls doing, and So also we can like put a flag that we want to see or hide actually actual browser, and probably it will be faster to have multiple threads running with Chrome driver, and in this case probably you will want to hide the real browser window. So let me read what did you write. So yeah, so Selenium project is definitely like a different project, and it will not be in the same like library in the same project that you have for integration tests. So usually it's like a separate environment, because for this you need to create some abstractions that will handle like your CSS selector to get items that you need. Why we need integration tests? Interesting question. Actually, we needed to be much closer to user scenarios. So integration tests, with integration tests, we can cover more components working together, and in this case, this will be like system will be tested more complex than like by single component. Okay. Yeah, somebody writes that I love mediator. Yeah, I love too. So let's continue. So behavior-driven development, let's spend a little bit time on this. So if to speak about BDD, let's probably start from DDD. Actually, domain-driven design, it's like a business subject focused development for every piece of code. So when teams has like DDD in mind, they think and okay, they create common language with all stakeholders, with QA team, and each system part has like more business involved meaning. And if to speak about TDD, test-driven development, this is like tests first and logic second development. So API always, or like different code abstractions covered with tests. And there are, it's like common things that probably all of you already know, but if to go a little bit, how to say, a little bit back, there are always a lot of mess in requirements, and the formulation of complex scenarios, and support and understanding of the implementation details for all involved parties. So BDD came to solve this problem, and behavior-driven development, it's like when coding begins with the requirements written in Gherkin syntaxes, which translated into acceptance tests, which requires to develop a logic to satisfy them. So this when requirements actually, requirements may be written by business stakeholders, and they can do this in some IDE. For example, actually, they can do this in Visual Studio Code with some special plugin for Gherkin syntaxes, or they can use a Visual Studio or some other, I don't know, Cucumber or other IDEs that can support Gherkin. And so once business stakeholders wrote requirements in the syntaxes, they probably should commit this to Git or any other like any other system that you use to store your repository. And then these tests can be written by developers or QAs. So I will try to show, in case I will have time. Oh, I should be much quicker to, to show you. So then these tests that created by QAs or developers should be read, because they don't have like a system that actually implements the logic, and that is why developers then should implement the logic that will satisfy such tests. As a result, app logic will fully be covered by requirements via integration tests. And if to see briefly how does it work. So here is Gherkin syntaxes, and here feature name. It's for example, user stories. It can be split on some scenarios, and here is a scenario that like a particular test case that somebody starts a game, and when maker starts a game, then maker waits for breaker to join. So it's it's very similar to arrange, act, and assert. So it's like a given. It's a first part. It's arrange and act and assert. Given its initial state, when its action take place, and then we check in expected outcome. And here how it look like. And this syntaxes has a lot of other features. So here is a small example of how we can provide more than one hard-coded value, and here can be a table, and there are lots of different other features. And here, how we can see this in the how we can work with this in the Visual Studio. So here is a feature file, and we have some Gherkin scenario, and then we go to definition, and in case it doesn't exist, we can generate it, and then it will be generated like empty step. And this step will look like this. So it will have almost the same string here, and this will mean that it provides a value. It can actually get the value from the table that you can create then after this rows. And then you need to implement the logic for this actual step. And here we have already instantiated calculator class instance in this class, and here what we actually add in the first number. And after we implement all the steps in the following way, then surely we should implement the logic of the calculator, because on when syntax on when step we will execute actual calculator action, and this should be implemented to have a green test. So the main advantage is a single source of truth. Because requirements will be inbuilt in the project repository, and always actual since tests are generated on the requirements basis. So as we see, here is requirements written in the Gherkin syntaxes, and here we have already tests. It's a step for a test, and we will have a lot of steps, and we will have tests, and to satisfy these tests, we should have correct logic. Let me read again. So, okay. Yeah, so for front end, we can use different how to say frameworks on front end side, like I don't know, Protractor or some others that I saw here. So it's like front end unit tests in frameworks, and probably you can build their integration tests with it, but I'm not an expert in this area, so I will not answer. Okay. So I hope BDD will come into your mind when you will start a new project, or I hope it will help you. So if to speak about stress testing and load testing, it's a little bit different from integration tests, but it's actually, the purpose is to for load tests is to help to understand how system behaves under the expected load. And stress tests, it's help you to understand the upper limit of system capacity using the load beyond the expectation maximum. So when actually, from my experience, from probably 7 projects, I heard only one project that was used load and stress tests. It's probably not a common thing to use, but it's pretty interesting, and you can find actually bottlenecks in very interesting places. And probably if you have projects with pretty high load, you should definitely use load tests and stress tests. And with stress tests, you can find some bottlenecks, and after resolving them, you may probably change your cloud configuration to have less CPU usage, less power of your cloud instance, so you will pay less. Okay, I have about 10 minutes, and let's continue. So here lots of tools that you can use for stress and load testing, but usually it's not a developer usually developers do not do this, and some special people doing this kind of test. So I have pretty less time, pretty small amount of time, and let me go quickly to the project. So here is a project that follows the clean architecture principles, but this is not as the purpose of this speech, and I just want to show the way of testing with API with ASP.NET Core MVC testing. So here we have a test, and here how we can instantiate a client when we use actually this library. Let me just show the test, and then I will go to the web application factory. So it's looks very simple, and here is a client creation, and here we execute our API with just direct URL, and we just do, for example, get async. And here is the response, and we can check is it successful, and status code, and we can deserialize data, and we can check how many items we have in the collection. So as I already mentioned in the slides, when we use this ASP.NET MVC testing library, we can have default web application factory, or we can have like our special application factory with our how to say, with overridings of default startup file. So actually here you can see that I'm using startup file that is in the actual web project. And under the hood, this test will create the application host and the client, and also will provide the ability to override for any dependency, any service in your services. So here I am getting the service from the services, and I'm removing it, and then I'm adding again this application DB context and saying that I'm going to use here SQLite instead of default SQL Server. And here, like I am creating a service provider, and here is a scope, and then here I'm creating, I'm getting again DB context, and I'm doing migration here. Then I'm doing some my special things like getting user manager and role manager and creating data there, and then I'm seeding some default data for the tests. So here, how it can be overwritten. So also here is example how to, for example, overwrite or add some, I don't know, dummy implementation of some notification service, for example, in case we don't want to spam our, I don't know, email provider. And yeah, so that's probably it for this test factory, and I'm having probably 4 minutes. So here, how we can do this like very general for lots of classes and reuse it, but here is example how we can redefine for some special test some dependencies. And we can do this directly in this test, and this will actually work. So here is it. And yeah, that's cool, because when you run this, stop lagging. And so once I run this tests, it will create a test server, and it will provide me a client to actually execute it. Yeah. So let's continue to the, it's building. Let's continue to the next probably class. Okay. And here is example a little bit more complex. So here probably I'm missing authorization, but here is how we can see like to-do item creation. For example, at first we create to-do list, then we create to-do item, and all of that we can do with direct post queries. And then we are getting some paginated data from our API with using just simple HTTP calls. And the last thing is again about spec flow. So yeah, tests are successful. Here is it. And last minute. So here is like features, and I can press F12, and I'm going to the direct implementation of this step. And again, I'm going to some other step. And other cool thing that in case we need to implement some new some new scenario, we just copying existing steps that already implemented and just change whatever we need to change. For example, we want to do here something else, and for example, we will check something else. So I will and not implemented steps just shown with this color. And okay, I will not show how we generate it, but it's very easy. And actual steps will look like this. And then you will be able to run your tests from SpecFlow implementation. That's probably it. And so we found our goals, and that's it. So please ask your questions, and the end.
Well, thank you. That was a great session, and I appreciate. What time is it there in the Ukraine?
So currently it's 9:30 p.m.
PM. Oh, well, thanks for spending part of your evening doing this conference for us. That was really
PM. Yeah.
It's been really helpful, and there's been a lot of comments. So I think you have a very popular session so far. I made I made a note that towards the beginning of your session, you were showing that how much it costs when you fix a bug.
Yeah,
it's basically not really much of a cost during requirements, and by the time you get to production, you're talking like 100 times the cost, if not more, to fix the bug. And that's actually that's actually something that I talk about in one of my conference sessions. And when I show that information, I show it as a graph, and when I show that information, I don't know if people believe what I'm talking about, but so I'm glad you showed it, because that means it's just not me that's showing that kind of information. And I wish I would. When I show it in my conference, it's a nice graph, and I tell people screen graph. Get a copy of this slide and print it out and staple it to your boss's door, right? Because the one thing that managers understand is money. Right. And so
right.
Yeah, if you can tell them in money costs how much it costs to fix a bug in requirements, as opposed to like even when you go to user acceptance testing, if they can understand that, they'll get behind it, right? And to try to squash the bugs before they are even here. So.
Yeah, definitely. On many projects, I see that there should be much more time for the requirements negotiations and clear requirements creation. And also, on the very beginning of the starting project, people should invest more in the creation of everything that's needed for integration tests and this automation scenarios.
Yeah, and and that's the other thing I'm going to talk about. I'm going to be talking about a little bit of what you talked about in the keynote, but not as much detail, of course. And that's one thing that I've struggled in teams, is trying to get management and PMs on board on doing this in the beginning, right? And because in the end, you're going to be saving so much money. You'll have a better app. Your users will be more happy. And my last contract that just ended, there's a team that worked at the company that I wouldn't work for because of some things. But one of the biggest things, why I wouldn't help them is because do you know where they do all their testing?
No.
In production.
Oh my God! Really?
Yes.
Did they create some other environments like staging? I don't know.
They couldn't test in those environments. They could only test in staging, and part of it has to do with using Salesforce as part of the back end. But some of the other members on my team would get sucked into helping fix their bugs and things like that, and I would have meetings with the people on my team. and they go, Dave, I'm doing this code, but I have no idea if it works because I can't run it local. There's no dev box I can run it on first. And, the people on that team, which was in the East Coast of the US, they said, yeah, we'll test it when it gets to production. And I'm just.
It's really terrible. So they definitely need to create some, replication of the prod data with some masking of some sensitive information. And they should also have some test third-party integration services with what they will integrate for testing scenarios.
I just, I was just completely floored that it's, 2020 or 2021. And here's a team that, they think they're awesome. And I'm going, no, and the one other thing I want to bring up before our time is over is that, going back to, doing, this kind of stuff in requirements and stuff like that, I can't stress enough, how important it is, to do documentation and good architecture before you even sit down and start coding. And again, I'll be talking about that in my keynote. But but unfortunately, and I think part of the reason might be the way that people implement Scrum in their teams. But I've just seen that amount of documentation and charting and things like that just go really down, in the last 10 or 15 years. And even in the last company I was working for, trying to get them to document something was just like, it's really
just
hard.
additional time needed for this. And this is actually a problem when a new person came into the project, and he will just ask a lot, how does it work, how that part of the system works. But in case they will have actual documentation where this person can read through, it will save a lot of time. And also there should be lots of onboarding documentation, and I see in most of the project they are missing. And when I come to the project, I always starting with creation or with the idea to create this like onboarding documentation, because it's very useful not for only onboarding, but for reference later, because always you will not remember everything you heard, and you should not go to some recorded Zoom meetings, and you should just go to the special page where everything is written.
Yeah, I totally agree. And I have a .NET Dave meme that I think that came out this week or last week that says that, if you don't document your projects, how are coders supposed to code it, right? How is QA supposed to test it if there's no documentation? How do they know how it works? And even some of my close friends have recently, because I complain about the lack of documentation all the time, especially with open source projects. And one of my friends said, well, they don't need documentation. You can just look at the code. And I'm
in case it's a Hello World application or calculator, definitely you can read through the code.
Right. How am I supposed to go through your code base trying to figure out how the heck it works? How one function works? I've got to go through your entire code base, and
after 5 years or even a year, you will not remember what did you write, and you will not remember why did you write this magic number here.
Right. Yeah. They at the last contract I worked on, they implemented some really strict new security rules and monitoring and things like that. So, the people in my team, I didn't have to do it luckily, but the people in my team had to go back to these old code, old stuff that was written like 5 plus 10 years ago, right? And not only is there no documentation, but a lot of the people who worked on it don't even work there anymore, right? And there was one project we didn't even have the code.
That was a pain for me on some of my past projects when I had to migrate database. from the old 4 databases to the new one with different schema. And this was really terrible because people who actually built that system, they was already not in this company. And I had to guess how actually does it work and why there are a lot of different like columns that I didn't found where it's used. And it was really a mess.
Yeah. I can't stress documentation enough, but we've run out of time, so I've got to let you go. But thanks a lot. So thanks so much for being on. And make sure you let me know when there's a conference I can come speak at in Ukraine, because I really, really want to come back.
Yeah, thank you.
Yeah, thank you.
Have a good day. Bye.
You too. Thank you. So I'm really short on time because I was talking too much. So let's go to the giveaway. So next we're going to give away 140 Stratus bucks to somebody who's made a comment using the hashtag CodeQualityConf21. And so let's go. Dun, dun, dun. I should have some music. I have my guitar right here. All right, Joe. Congratulations, Joe. I told you if you use the hashtag, you might win. So there you go. Joe's been commenting a lot, so he won. I'm glad you won, Joe, because you've been doing a lot of great comments, and I really, really appreciate that. And so let's go to the next talk. Oops, sorry. So next we're going to be discussing cloud microservices to serve the next billion. I'm looking forward to this because this is something that a lot of people need to think about these days. Is we're not talking about small numbers of people hitting your microservice and stuff. Or these days we're talking about huge numbers, and so quality and performance really, really is important for especially for microservices. So yeah, let's bring on the next speaker. Welcome.
Hey, hi. How's it going?
Good. How do you pronounce your first name so I don't screw it up?
It's Tejas.
Tejas.
Yeah, Tejas.
See, I'm horrible at names.
That's okay. I'm used to it in California.
What? Where are you located?
I'm in North San Jose, California.
Oh, you're in San Jose.
Yeah.
Oh, I thought you were somewhere else because I would have scheduled you a little bit later then. But yeah, I was in San Jose like a month ago, and I was staying right downtown in San Jose at one of the hotels there. It's
nice.
it was kind of dead there, because we're still under lockdown. But
yep.
I found this really cool cafe to have breakfast at every morning. I don't remember the name, but it was called Waffles or something like that.
I see.
Yeah. So anyway,
nice.
Welcome. I'm glad you're here, and let's talk about serving the next billion.
Sure. I guess I'll get started because I have the sharing on as well. So let's see. Hi, everyone. Today, I'm going to talk about how you would build cloud microservices for the next billion users. And the agenda of my talk would be as follows. I'll first start off with an introduction. Who am I? What am I doing? How did I reach here? Problem space definition. What exactly are we trying to solve here by building microservices? Requirements of the problem space and ideating a solution. How do you get towards iteratively designing using agile techniques to reach a solution? And finally, some results and takeaways as an engineer. And here is a picture that I have of a typical retail store in India. As you can see here, there are a bunch of food items, perishable items, and non-perishable items that are present here. And India is dotted, like the cities and the towns of India are dotted by like millions of these stores. And these are small and medium businesses, mom and pop shops that are run by common people for common people. So um, we found an opportunity to disrupt this space, and we felt that this would then disrupt like technology and introduce technology to a billion people. So that's why the name of the talk. Let me first begin by an introduction to myself. My name is Tejas Chopra. I am a senior software engineer at Netflix, and I'll talk about my journey. So I started off with a master's degree in Carnegie Mellon University with a specialization in computer systems. From the year 2012 to 2016, I worked at Apple and Samsung, where I was working on distributed systems. In the year 2016, I started working at a startup where I was the first hire. And what this startup was doing was it was building a marketplace for FMCG. And I'll get into what that is. You can think of it as just like Amazon, but Amazon is B2C. This one is B2B, where the buyers are retail shop owners and the sellers are wholesale traders. And my goal was to build software that can enable them to do their business in a better way, thereby enriching their lives and the lives of the customers that they serve. From 2017 onwards, I started working at a startup called Datrium and then at Box, where my job was distributed file systems, storage, replication, cloud storage. And 2020 onwards, I joined Netflix. So I'm a part of the data storage platform team here at Netflix. My job is to build, architect storage infrastructure for Netflix Studios and Netflix streaming platform to store and efficiently retrieve petabytes to exabyte scale data that is produced at Netflix. Coming to the problem space definition. Like I said, there's a category of goods called fast moving consumer goods. And this is an image that captures it quite well. These are packaged goods, beverages, toiletries, cosmetics, food, other perishables. And they are typically found in the US in big stores such as Macy's and Target. But in India, they are found also in a bunch of retail stores, small that are run by small and medium businesses. The market for these is around $50 billion in India. And the business model, like I said, is there are wholesale traders on the one end and the retail shop owners on the other end. And in India, there are 0.33 million of these wholesale traders and 12 million of these retail shop owners. So that's the business model that they have. The problems in this domain are that there is a lot of wastage of food, and the wastage is actually 70 tons per year for perishable items. And there are several reasons why there is this wastage. Firstly, the last mile delivery is very untimely. So the last mile is between the wholesale traders and the retail shop owners, and the delivery is generally handled by the wholesale traders, the shipment. And that is very untimely, very fragmented, which results in these consumable items perishing. So that's caused a lot of wastage. There is no feedback mechanism. So if a food item goes bad or is close to getting bad, there is no way for the customer to inform the store from which he or she has bought this that this food is bad, and there's no way to relay that information upstream. There is no catalog maintained. So generally, the way that this domain works is they use pen and paper to just keep a track of what is the inventory in their store. So there is no technical way of managing the catalog. And finally, there are deeply entrenched relationships. So typically, a retail store owner has relationships with one or two, just a couple of wholesale traders, and they only deal with them. So that way, they do not have choice to explore other wholesale traders. And these are some of the reasons why there has been a lot of wastage. And we thought, let us try to use technology to disrupt this space. This is a typical wholesale retailer that, as you can see, it is pretty fragmented. Very little technology has touched this sector. So we thought, what if we could prevent this food loss or make a dent into it? Create a marketplace for FMCG, which does not exist today for small and medium enterprises in India. The buyers would be the retail shop owners, sellers would be wholesale traders. What it does is it gives buyers a choice and sellers a platform. Choice is good. You can explore offers from different sellers, you will also have the ability to provide feedback back to the uh, wholesale traders from whom you're buying this stuff. It also gives you the ability to search and seek offers. So typically, when you open up Amazon or any other app, you can search for products, look at different offers, create a cart with a bunch of stuff, and then get the amortized cost of shipment. So that's what we wanted to bring to this sector. And finally, we wanted to build empathy for customers. And I'll expand on this point a bit in the next slide. But what we wanted to do is we did not want to just take the model that worked in different sectors and just apply it blindly here. One of our learnings was that it had to be customer is at the forefront. So you need to recognize what are some of the challenges that they face and try to solve them. Um, and that is a good segue into what were some of the challenges that we saw initially. Um, First and foremost, this sector, the people that we were trying to solve the problem for, had never used a smartphone. So to explain to them what an application is, what a smartphone is, how do they like interact with an app was a challenge and something that we actually did on our own. So we provided them smartphones and we taught them how to use a smartphone, which was a very enriching experience as an engineer. They care about battery life. Generally, the retail stores work on extremely thin margins. So they want to save on as much electricity and other resources as they can. So for them, any product that consumes less battery is a win. And so they really focused on having a good battery life for whatever app they wanted to use. Thirdly, generally you see a product like an iPhone or a Samsung phone, they have data written in English about the features of the product, the attributes. But a lot of our customers were not very well versed with English language. So we had to localize the product images for consumption by these people. And that was another challenge to do. The concept of a cart, the concept of order history or tracking of orders was new to them. So we had to teach them what these things are and how they work. And finally, product images. So typically, we would when we look at a product page in these different apps, we read about the like what the product is, and generally we do not focus too much on the images beyond a point. But our customer base actually just focused on the image. For them, it's easier to reorder the same stuff that looked similar to what they had, and they don't go about reading what exactly are the features of the product. So product images had to be much bigger than the text that they had. So these were some of our learnings by talking to a bunch of customers. And whatever solution we built had to take into account these learnings and try to solve them for our base. That actually led to defining requirements. What exactly should our app do or platform do? The table stakes for a marketplace are product search. You should have the ability to search and browse like products. They have different images and different variants of the products. Have an order management system that gives you an ability to add items to a cart, track your orders, and look at your history. Authentication when you log into the app, whether it is OTP or some other way of authenticating a user. Offers, which are associated with bulk orders, and they are provided by sellers. So that is again a feature that you will generally see in Amazons of the world. And finally, a way for the sellers, which is the other side of the spectrum, to ingest their products and offers into our platform. So these are some things that we have to build for it to even take off. And some of the initial design choices that we took were, we started with cloud because cloud was the easiest way to bootstrap any idea. It allows you to have elasticity, scalability, security, manageability is handled by them. So it's a very low barrier to entry if you want to build systems. We relied on DynamoDB. So DynamoDB is a database that is NoSQL database, and the problem domain that we were solving or trying to solve, I did not know the structure of the data there because products can have so many attributes and the list is endless for different types of products in this domain. So I started by creating tables in DynamoDB. I used Kinesis, which is event like producer consumer model where On the one end are producers that produce events, and on the other end are consumers that consume those events. It's like Kafka, but it is managed by AWS. And it is leveraged for asynchronous updates and other async workflows. We used Redshift. Redshift is a data warehouse where you can track different like user clicks or product searches or browsing, and that data can form insights that you can build businesses on top of it. And you can provide a view into, let's say a consumer is about to buy more chocolates because it's Christmas time. So that is the kind of insights that you can get from data warehouse, and that will help our sellers to get inventory beforehand. Given that we've chosen this system and a set of requirements, we have to now start working towards a solution. The simplest way is to take a long time and to build the perfect thing, but there is no such thing as perfect, and perfect is the enemy of good, as they say sometimes. So the right way to do it is to use agile techniques and design iteratively, and seek feedback. That was my motivation, because I was so new to this field. So I wanted to like see what works for customers and what doesn't. So I started off with a pilot, and the pilot was very humorously simple. It was an SMS-based solution. So I would have a Lambda that sends an SMS every day with a list of all the products, and it would be a long SMS. And we would send it to the buyers, which are retail shop owners, and they would respond by scrolling on the SMS and then saying that they wanted a particular product and how much quantity of the product they wanted. So the advantages of this approach were, it got us to bootstrap in AWS by using Lambda, DynamoDB. It got our buyers the ability to work on feature phones without requiring to buy smartphones right away. And it allowed us to scale up to 10 stores, but not beyond that. So it was a solution that was a pilot just to see, if such a thing can work in this market. The backend would have sellers uploading product information in DynamoDB, and on the other hand, the Lambda would send SMSs. What was my conclusion from this? First of all, Lambda works great for timed delivery of messages. Human vetting is painful, and it has to be replaced by programs. And this approach is very rigid. It has no offers, no real-time quantity updates, no searchability, browsability, and it's just scroll-based. The person has to scroll to find which product they want to buy. And even with this broken sort of a solution, we could see a surge in orders, and we were doing about $500 revenue per day. So once we were fine with the pilot, we thought, let's start developing like services. And the first stage was to split the seller portal APIs from the users, the app APIs. And we did that by having a monolithic service for the seller portal and a Lambda for the app. So whenever an order was placed by the user, a Lambda would get invoked, which would actually deal with the order. And the sellers would ingest the product information through this service into DynamoDB. And finally, the Lambda that is invoked on an order placement would interact with DynamoDB and do real-time quantity updates. So this worked very well beyond 10 customers as well, and there was no human vetting required for this. It was automated, the flow. But there were challenges even with this approach. For example, it works with single orders. There was very minimal state management, and there was no concept of a cart here. So people just had one item that they would order. Also, let's say that the seller changed the image of a product. In that case, it was very because we did not have any async workflows in place. It was difficult to reflect it on the consumer's app. And one learning we had was AWS Lambda is extremely slow to warm up. So the orders would take multiple seconds to even be placed. It did work, but it was not the greatest of user experiences. So we went to the second part. We replaced Lambda by a monolithic service. This service had multiple database tables that it was interacting with, such as products, order management system, notification, authentication, and thus there was a lot of business logic inside this monolithic service. The framework that I used to build this is Drop Wizard, and I will get into more details. It did not have any browse or search capability. It was still scrolling down to find the product. And the one thing that I did introduce was a swipe based order. So the user would look at the products, enter the quantity that they wanted, and just swipe, and it would place an order on the back end. And it did result in a lot of false positives, but it was simpler experience for our customers. Also, we introduced localization, which means that we now have product images that had content not just in English but in other languages as well. One thing to note is that this does not have any relationship models. Let me get into a bit more details on what I mean. When you look at a Samsung phone today, you know that the brand name is Samsung or Galaxy. The manufacturer is Samsung. The product line and product verticals are very well defined. So product vertical is that it's a smartphone, and the product line, it's like it's Galaxy Series 5 or something. So these are different attributes of a product. And you can search on your app today by saying, give me all products that are created by Samsung, or give me all products in the Galaxy brand. So that means that your searchability and browsability is based on these attributes, and you want a collection of products that contain these attributes. So that means that there is a need to map these relationships between products, manufacturers, brands, product verticals, etc. And that did not exist. So that is something that we had to build to enable browse and searchability. And once we realized the pitfalls of monolithic services, we went the microservice way. So what microservices do is, the problems with monolithic services are that they're difficult to scale, difficult to modify and test and release. One single service is dealing with multiple database tables, so there's a lot of mixing of business logic. There is no clear separation of concerns. And monolithic services generally will only scale up to a point. There will always be a need to split it into multiple microservices. And microservices, again, there is something called as a curse of too many microservices. So you must be very careful that you do not have too few or too many, because I've seen people sometimes create small microservices, each one talking to a separate table. And what that results in is more like latency when it comes to cross-service interactions. And you'll have to make a network hop, which you can avoid if multiple similar functionalities can coexist in a single microservice. Generally, the rule of thumb is if there are two or more functionalities, such as cart and order management, that live and die together and scale together, then I try to put them in a single microservice. So we introduced microservices. That was the first step that we did. The second thing that we did is we did not end the flow at DynamoDB. We wanted to have asynchronous flows to workflows that can like update either our insights or some other metrics. So we introduced Amazon Kinesis. Amazon Kinesis is like Kafka that is managed by AWS. Any update to a DynamoDB table can be captured by Kinesis, and you can write connectors and indexers that can consume these updates. So as you can see here, we have 3 different indexers here. And the catalog indexer is when the seller updates a quantity or updates an offer to a product. The catalog indexer will read that data, and then it'll finally update either the S3 bucket or the DynamoDB table again to reflect that quantity on the app. A Redshift indexer is used to track all the metrics that the user has captured and put them into Redshift for building insights into the data. And the Elasticsearch indexer, so we used Elasticsearch for searching. And this indexer's job was to, whenever a new product was ingested, it'll figure out the different attributes such as manufacturer, brand, product vertical, product line, and then index it appropriately in Elasticsearch clusters so that the user can get browse and searchability. I was talking about Drop Wizard. So what Drop Wizard is a collection of services. It's also a framework, but it's mostly a collection of libraries like Jackson, Jetty, Jersey, and Metrics. Jetty enables an HTTP server to be embedded inside the main method. Jersey maps the REST requests to Java objects, and Jackson allows JSON serialization, deserialization. And it's very simple to use Drop Wizard. It's similar to Spring Boot, and I could have used Spring Boot as well, but a quick Google search showed Drop Wizard above Spring Boot, so I just started with that. And there is really no reason why we couldn't have gone that way. As you can see here, it's very simple to define the resource path, what is produced, and give query parameters, have a get method that is timed implemented. This is a very simple example of a hello world resource that we've created. And with Spring Boot, if we would have gone that path, we would have got a dependency injection that came with it. So that's just a little nugget on how we built our microservices. And I was talking about the different attributes. So I thought I'll just share a good diagram or a good picture of what these different attributes are. So this captures all the products or most of the products by Procter & Gamble, which is a manufacturer. As you can see here, these are the separate verticals, and these are product verticals like home, hair, grooming. Product line is effectively Pampers diapers would be a product line. And you can see that there are two products that are sitting in that product line. So that's an example of how there are product verticals, product lines, manufacturers associated with a product. And the problem in this particular domain is that some products may just have a manufacturer. Some of them may have a brand. Some of them may have a product vertical and a brand and a product line. So it's really not a tree anymore. It's a graph. So we wanted to model relationships that are dynamic in this world on our DynamoDB tables. And for a lot of them, it is very difficult to get this information, which is the brand, which is the product vertical. So we had to rely on a lot of customer inputs to fill those gaps there. What we wanted is the ability to search products by one of these attributes. So if you wanted to search a product by manufacturer, you would have products by manufacturer ID and brand ID, or products by product vertical. To allow building such a system, we had to have a lot of secondary indexes in these DynamoDB tables so that you can search a subset of products from this humongous list of products. And so we had to place the product vertical ID, product line ID, brand ID, all of that in the product table. Similarly, in the brand table, I had to put the manufacturer ID. And it was the job of the catalog and the Elasticsearch indexer to, whenever a product is ingested, to update these different tables and put their secondary indexes in place. So these were some of the search and browse conundrums that we had to deal with. At this point, after we dealt with all of this, the state of the app was that the buyer could do product search and browse and place objects in a cart and order. And there was an order management system as well in place where he could track the shipments, he or she could track their shipments and inventory and look at their order history. Sellers were able to ingest new products, update quantities, offers, and get invoices for all the orders that have been placed. At this point, I think I'll get into some of the key takeaways that I had from my experience building these microservices. And I'll divide them into technical learnings and product learnings. Technical learnings. DynamoDB is not the best database for relationships. So like I said that there are different relationships between products, manufacturers, and brands. They cannot really be modeled very well with DynamoDB. Instead, I should have used a graph database. A graph database allows you to model these relationships, and it is not a secondary index lookup. The lookups are really O of 1 because the relationships are a first-class citizen in a graph database. So in hindsight, I could have used an Amazon Neptune, which back in 2016 did not exist, I think, but I could have still used Neo4j, which is a graph DB backed by DynamoDB. And I relied on DynamoDB to generate these event streams for asynchronous workflows. By having Neo4j backed by DynamoDB, I can still leverage these event streams, but the advantage is it makes those indexers very simple. I do not have to now manage these secondary indexes. Secondly, I leveraged a lot of Kinesis, which is Amazon provided Kafka alternative. But Kafka is much faster than Kinesis, and it allows for faster retrieve and stores the data for longer periods of time. I think Kinesis by default is 7 days. Kafka is much more than that, and it can be configured. Back then, Kafka did not have a lot of connectors for DynamoDB or Redshift. or Elasticsearch. But today, Kafka has connectors for all of them as source and destination. So it would be much easier to design things with Kafka than Kinesis. The only challenge would be to manage it, because it'll be we'll have to manage the zookeeper or the clusters of Kafka. Containerization is another thing. So the way we deployed it were several EC2 instances and of these services. But if one of them went down, we had to manually check for that, and we had alerts for it. But we had to manually bring up another one, or even set up some scaling. But I think making these apps as containerized apps and using Docker and Kubernetes, it would have made our lives much simpler, because I think the manageability aspect and the automation frameworks that they provide for microservices is really useful. CI/CD pipelines, again, are the backbone of agile development, and we could have done a better job at introducing them earlier in the development cycle. Spinnaker is one of the open source alternatives that is actually developed by Netflix. Had I known that back then, I would have used that for automated deployment on cloud, different types of cloud, and not just stick to AWS. Today, something that's picking up is the communication between microservices. So there are several ways in which you can have one microservice talk to the other microservice. It could be REST calls, it could be HTTP calls, or GraphQL, or whatever sort of interfaces you provide. But I think that things such as service mesh, like Envoy or HA proxy, are picking up, because they allow you to build a framework for microservice to microservice interaction, embed metrics in it, and get more insights into the kind of data that flows between microservices. It also allows you to have authentication and authorization between microservices. So that would be a very nice thing to include in our architecture. So these were all the technical learnings. Then come the product learnings. So first and foremost, what we did was we allowed customers, we gave customers this notion of a cart, but we understood that customers were not able to grasp this concept of a cart. For them, placing an order by doing a swipe was much easier and a better user experience than saving it in a cart and at the end of the day trying to place an order on the cart. So the only challenge is when you place individual orders, you will incur a shipping cost for all of these. Whereas if you place a bulk order, the shipping cost gets amortized. So what we did on our end, which Amazon has been doing forever, is we would bulk up these different orders and create a virtual cart on the backend. And that resulted in around 27% savings for customers. Like I said, searchability and browsability to give a better user experience was one of our top priorities. And we did a lot of customer research to fill the gaps between these attributes that a product has. And per product, there were different attributes by which the customers wanted to search. For example, customers wanted to search chocolates by their brand, but they wanted to search for some other commodity, such as toiletries by the manufacturer. So having a curated list of what these different API calls should be was very critical in giving a good experience. And that increased the orders by 24% by just introducing these different product-based searching. I mentioned that we have Redshift, that is our data warehouse for capturing insights. What we saw is that by just introducing insights into the data, we increased the revenue by 34%. And that told us a lot about customer behavior. For example, when customers during the summer season, there was an increase in demand of ice creams and chocolates as well. And we saw that customers were trying to browse them beforehand. So that gave us insights that we could forward to our sellers, and they could have the inventory ready in case customers order that. Also, customers tend to order products in clusters. So for example, rice and wheat were ordered together generally. Sugar was never ordered in monsoon season. So all of these learnings and insights were things that we learned from the data that we collected, and it was very useful in driving our revenues. And finally, coming to the results of all of this work that we did within a span of 6 months, The number of wholesale traders on our platform, that is the sellers, increased from 1 to 7. Our retail shop owners increased from 10 to 400, and they were touching a population of around 4 million people. The insights that we capture increased from 7,000 data points per day in Redshift to 780,000 data points per day in Redshift. And our revenue increased from $200 per day to around $8,000 per day. And finally, the reason why I'm giving this talk is the efficiency improvement. So we calculated that because of our efforts, we were able to save 27% of the food wastage that would have otherwise occurred if we were not in the play. So I think that was really the biggest takeaway for me. And I worked in bigger companies such as Apple and Samsung, and the way things work there, the technology there is very different. And sometimes when you are on the infrastructure side, you're not closely like you do not see the customer directly, and you're building something to enable workflows for someone that may not be the direct customer. But this experience in the startup made me wear several hats and gave me exposure to product, gave me exposure to customers, and that's why it was a really fruitful experience, I would say. And here are some of the takeaways that I take from this experience that I have. Firstly, you must always build software for the customer and show empathy. So in my case, I realized that the customers are not very tech savvy. So you cannot directly apply things that work for a tech savvy audience to these customers, and you need to enable them to take baby steps towards the technology and build a system and a user experience that they are comfortable using. One of the very good examples of this was the localization part of it, where I realized that they were not very well versed with the languages that we had. So we had to go back and click pictures and curate the content that we show them, and that increased their experience, improved their experience. More code is more bugs. That's a common adage that there is a bug every 100 lines of code. So if you want to have less bugs, write less code. The goal is to write simple code, not too complicated code, and pick and choose your battles. So if you have a small array of 5 or 10 elements, you do not need to write an extremely complicated search like algorithm. You can just simply iterate over the array, and if it's very irregular, you can iterate over the array and find an element. So that's an example of simple lucid code that can save you a long time in debugging. Pains of scale. Things work when you scale to like 10 people, but as soon as it becomes 1,000 people, things fail. And there may be so many reasons that they fail. It could be that AWS places limits on read and write throughput of the database, so things are slower because they are throttled. It could be just that your network cannot take up that much load. What's important to know is to design systems in which you fail safe, which means that you can fail when the customer is about to place an order. And you can say that, oh, I'm unable to place an order right now for you, and we'll get back to you. But you can't fail when the customer has already placed an order and not send them that order. So how do you design systems that fail, that it's okay to fail, but that fail in a good manner? Performance on smartphones. So a lot of infrastructure where these customers are, they do not have proper networking infrastructure there. So what that means is a lot of calls to the cloud may not work there. So how do you employ caching techniques on the phone to allow them to at least browse products? And then how do you also batch a bunch of updates together and send one network call instead of multiple heartbeats to the server? Those are some of the things that you should always be cognizant of when designing systems. Invest in learning about the business and the pain points and see if tech can solve some of them. As software engineers, we often tend to just go into our own rabbit hole and try to just focus on the problem at hand. And sometimes we do not care too much about the business, and we assume that there'll be a layer above us that will take care of translating the needs of the business to tech and tell us about it. But I felt that it is also very important as an engineer to learn about the business and to see what are some of the places where technology can improve their life. One good example was that, like I said, there was no good way to track inventory for these customers. And I thought that, our order history can be a very good way for them to know what they've ordered and maybe the first steps towards tracking inventory. So I just built something on top of the order history to tell them how many things they have in their store. And that was something that was orthogonal to what we were actually trying to give them. But it really enabled them and empowered them. So it was something that was just because I wanted to learn about the pain points. Data is gold. Uh, Having insights and metrics will always keep you a step ahead of what the customer is wanting to tell you. So you can always infer their behavior from the data. And that's why investing in data during bootstrapping is often the right thing to do. Cloud costs spiral out of hand if not designed correctly. That's something that I learned and through Redshift, my experience with Redshift back in 2016, when we went from just $500 per month to $4,500 per month, just because we had so many more insights that to look at. So it's very important to design intelligently for the cloud and see what is the footprint of the data and the costs that you have in cloud. These are some of the takeaways. I hope that I have been able to communicate my learnings, and I hope that as an engineer, I have been able to put a seed in your mind as to how to design systems and software that is empathetic towards the user. With that, I end my session, and you can reach me on LinkedIn, email, or Twitter. Thank you. And now I welcome any questions from the audience.
Sorry about that. I'm on mute again. That was really great. It's a lot of great information in that topic.
Mm-hmm.
I did have one question really quick for you since you work at Netflix.
Yes.
Sorry. So does I know early when Netflix started, they were using .NET. Do they still use .NET or they moved away completely?
Completely moved away.
Yeah. That's what I figured.
Yeah.
Because like their first like cross-browser viewer was actually done in Silverlight.
Yes,
Yeah.
that's correct.
Yeah.
Yes. Yeah. Now I don't think they use .NET anymore. Most of our things are like some of them are built within Netflix itself, and we essentially use a lot of Java. A lot of those are mostly like I work in C++, Java, and what else? Scala. Yeah, a bunch of them. So
yeah. So how do you like working for Netflix?
Oh, it's a great place, I would say. The things that I like about Netflix are its freedom and responsibility. So as an engineer, you do not have any processes that tie you down. They give you freedom to explore any language that you want to write the code in, and you can decide, pick and choose what you want to work on. So it's a very, for a company at this scale, this is really amazing how they work, and I like that. There is not a lot of control. Netflix believes in context, but not control. So these are some of the cultural attributes that, anyone coming in has to align with. So that has really worked well for me.
Yeah, that sounds like a great company to work for, actually.
Yes.
I was just thinking the next time I'm in San Jose, I want to come visit your offices and you check out exactly what you guys are doing there.
Of course, please feel free.
I don't know if you go in the office anymore, but I would definitely like to learn more about, how I know Netflix doesn't use .NET, but I'm still really interested in how you implement these kind of, the company culture,
Yes.
Company culture, I think, and I think Mahesh would agree with me that, company culture is super important, to the
absolutely
not to the health of and the I guess the enthusiasm of your workers, but because then that will create better code and better outcomes and things like that. And when you work for a company that's toxic, it just makes everything so hard.
Yes.
And for what reason? Just because people want to protect their silos or pretend they're better than they are. So it's refreshing. Yeah, it's refreshing to hear companies that actually are kind of seems like doing it correctly.
Yes, and it permeates, like you said, it permeates in the entire organization and different things that you do, like your
Yeah.
work, the way you talk to people, your relationships. So I think it's very important to be aligned with the culture that the company you're working for has.
Yeah.
And you spend so much of your time with the company and with the people that you're working with. So it's very important to like be cognizant of that. Yeah.
Yeah. That is important. So we got a couple minutes. So I'm going to look at some of these comments and see if we can. I think people are just making comments, not asking questions too much. Does anybody have a question? Oh, you want to answer that one? I'm not even going to read it. It's so long.
Yeah, agreed. But you have Dapper, gRPC, etc. to help and simply spin off new service instances for throughput. That is true. Yes, that I agree with. I think this is in relation to like service mesh and like using Kubernetes and for building microservices. And I think I agree with that. You can simply spin that off. I just wanted to use Kubernetes because I've seen the benefits that it has provided, not just in terms of rolling out features, but rolling back features as well. So that is something that I've really enjoyed looking at Box, which was my previous employer. So I think, and again, this was back in 2016. So hindsight is a great thing. Today I know a little bit more than what I knew back then. So how can I apply my learnings from today to what I had built previously is what it was about.
Yeah. And I just thought of, information like what you were showing is the type of information that, kind of, the way you architect things and, the way you set up things and how services talk to each other, is something that doesn't go away. Frameworks and languages might come and go, but, practices like that stay,
Yes.
and,
Yes.
I still use, practices that I learned when I was a beginner, and that was a long time ago. I think I started programming before a lot of people here was even born, so those kind of things stick with you. The languages will come and go. It's the other stuff. It's the other stuff you need to learn and take with you from, company to company or, challenge to challenge, however you want to talk.
Absolutely. And I think you have to burn your fingers, burn your hands many times before you learn your lessons. And it prevents you from future, like you could have burnt down the entire like infra. So it prevents you from that sort of situation. So yes, I agree with you.
Yeah, you could have sent out, 44 million emails, like like that guy, somebody who works for HBO Max did yesterday. That everybody's making fun of.
Yes.
And it's a mistake, and it's something we all laugh about. But I started to do this, but I had to jump on the conference. But you know how much carbon that put into the atmosphere, sending out 44 million wasted emails.
Absolutely. I think it's a 2 grams of carbon dioxide produced for every email that you send or something. Because I actually do some research on the carbon footprint of software that I write. So it's interesting that, yes, you mentioned that.
Yeah, that's the thing I've heard recently. And I know Mahesh is really cognizant about, CO2 and things like that. The one thing I saw recently was, 60 emails equals driving 2 miles in the US, so.
Oh, wow.
So when you send out 60 emails, that's like driving, is putting that much CO2 into the air by driving 2 miles, and 2 miles. Yeah. So it's,
that's interesting. Actually, Netflix just did a recent study where they were seeing the carbon footprint of streaming. And if you stream a movie for an hour, and it doesn't matter what's the bit rate of streaming, it wouldn't take a lot of carbon footprint because we've been investing a lot in trying to reduce the carbon footprint of the services that we write and the content that we generate in general. So it's interesting.
Well, tell Netflix to turn off that the videos that just start playing, when you're trying to look for something. If they could turn that off, we could save a lot of CO2 and a lot of bandwidth, because I know Netflix is the biggest bandwidth hog in the world, right? So,
but actually, we have our own content distribution networks, CDNs that we have. So we try, yes, our bandwidth footprint is pretty high, but the technologies we employ, it is, I think, for an hour of streaming, the amount of energy we use is equivalent to boiling an egg or something like that. So it's not too bad, but it is something that we can definitely, always improve on.
Well, I burn a lot of CO2 at nighttime when I'm watching Netflix. Netflix, I'm not saying this because you're on the conference, but Netflix is my favorite streaming service, hands down.
Thank you.
And I love their original content, on Netflix. So keep doing a great job, and I hope you come back the next time we do this conference, hopefully next year.
Absolutely, and thank you for having me here. I really appreciate it.
Yeah, I really appreciate you being on too. Thank you very much.
Thank you. Cheers.
The one comment I wanted to make really quick before I forget is, hey, Joe, next year when we do this conference, I think you need to submit a talk. All right, so let's go to the slides and talk about a few things and then give away some really cool software. So again, the last time I checked, no one's donated yet, but if you could take a few minutes and donate some money to help the kids in the slums with the COVID relief, because, COVID's doing really bad in India right now. And it's actually coming to the States too, unfortunately. And so, but we really need to help the kids out. They're stuck in this mess. And I'm really glad my kids were older during all this, but so please go there and donate, and I will definitely appreciate it. And if you tweet about it, I might even send you some free stuff. So, so let's do a giveaway. So we're going to do the first of 3 Grape City giveaways, and the winner of this gets to pick any product that they make for .NET, which range from $495 to $895 US. And this is a real license, real product. And if you haven't used third-party components and stuff, you need to, because it will dramatically increase how fast you can get things done. And not only how fast you can get it done, but it does a better job than writing it from scratch, So, so let's give away the Grape City. Ta-da! There we go. I need a drum. I need a drum roll. I don't have any drums in my house. All right. There you go. I'm not going to say your name because I'm terrible at saying Indian names, but congratulations. Simon will be contacting you because I need your email address, and so I can send it to Grape City, and then they'll let you pick whatever you want. So thanks a lot for making a comment, and I hope you like the Grape City products. I love the Grape City products. All right. So, oh, we're a minute over. So I want to leave all the time I can for our next speaker, who's Stephen from Microsoft. And he's going to be doing unlocking performance improvements in .NET. I've been really looking forward to this one. Welcome, Stephen.
Thank you. Good to be here. Thanks for having me.
I'm really glad you're here. I've been telling all my friends that, there's one person I really wanted on this conference, and that's you.
Oh, that's very sweet. Thank you.
From what I've heard, you're the expert at .NET performance. And, I do follow your blog, and I don't read it enough, unfortunately, but because I missed the tweet or whatever. But you're the man at Microsoft. So I've been really looking forward to this.
Oh, thanks. There are many of us that are very good at performance in .NET, but I appreciate your saying so.
Yeah. So take it away.
Oh, thanks. So thank you for having me. My name is Stephen Tobe. I'm a partner software engineer on the .NET team at Microsoft. I spend most of my time focused on the libraries that make up .NET, but also sort of up and down the stack with other people, really thinking hard about the performance and how we evolve it moving forward in the future. .NET has been going through something of a performance renaissance. It's been around for 2 decades now, and for a large portion of its existence or its youth, performance was always a consideration. It was always important, especially at the lowest levels of the stack. But other things often trumped performance. For example, usability would often be really paramount. Obviously, security is always and continues to be first and foremost, but usability would end up taking precedence over performance, to the point where we might not expose something because we were concerned about someone maybe not using it correctly, or we might make something not quite as fast as it could be in order to make it a little bit easier to use. And with .NET Core, over the last, say, 5, 6, 7 years, we've really revisited that and made sure that performance is right up there with security and safety as being the most important things. Now, usability absolutely is critical. But when it comes down to deciding, do we make this slightly less usable for something slightly more, something faster? That's a conversation that we have now, whereas previously it generally always went in favor of usability. Performance does end up being key at all levels now of everything we do in the stack. .NET is open source. We get dozens of PRs every day, and every single one of them, whether it came from folks that work on the .NET team, whether it came from folks elsewhere in Microsoft, or whether it came from folks in the broader .NET community, every single one of them is viewed through a performance lens. Even if it's a bug fix, it's very likely that one of us will comment on it saying, hey, I'm wondering about this aspect of perf, can you share some benchmark numbers? Because we view everything through the lens of performance. On top of that, we're also spending a huge amount of our time building features that are very much end-to-end engineered for performance, not just thinking about performance as part of some other feature, but actually building features explicitly focused on performance such that a developer can take advantage of them and make their apps scream. One of my favorite things about all of this, and we'll talk about this a little bit more when it comes to open source, but the .NET community really gets to vote with their feet. Meaning, it used to be that if you working on your application hit some sort of performance bottleneck in some .NET class, and you wanted to make it faster, you had to write up your issue, somehow get it to the relevant folks at Microsoft, have it find its way to a program manager thinking about the next version of .NET, have that be prioritized and triaged, and eventually find its way to a developer who might be able to work on it for the next release in 2 years or whatever it may be. But with .NET Core, you can clone the repo, find the area you want to improve, make the change, submit a PR, and it could very well be in a nightly build the next day. Which also means that all of us are spending a good portion of our time actually collaborating and reviewing a lot of these PRs that are coming through. So a good portion of my time is actually spent thinking about perf, not in terms of my own changes, but in terms of other people's changes. So it's a really exciting time. I've described a lot of this over the years in some blog posts. If you haven't read them, there are links here. I'm not sure if I can distribute this deck after the fact. I'm happy to, so you can click them. But you can also just search for these titles and my name online, and they'll pop up in Google or Bing or your favorite search engine. Around .NET Core 2.0, I was realizing, looking back over all of the perf improvements that had gone into the various .NET Core releases, and realizing we hadn't really talked about it much. So I took a stab at summarizing some of the key changes that had got into the release. And it got a lot of good feedback. So for .NET Core 2.1, which, while being a quote, dot release or a minor release, it was actually a pretty substantial major release. I spent a lot of time going through and documenting a lot of the performance improvements that had gone in. And along the way, I try and also sort of educate the reasons that the changes were made and why they helped and what the trade-offs were and so on. Then again for .NET Core 3.0, again for .NET 5, and sometime in the next few weeks, I'll probably sit down and start working on a .NET 6 post. Since we're currently working on one of the last previews for .NET 6, which is due out in the November timeframe. So after this talk, if you haven't read them, I humbly encourage you to go read them. I think they're pretty extensive. They're fairly long and hopefully educational in one way, shape, or form. All of these changes, the ones in the blog post, some of the ones we'll talk about today, they really exist for 2 reasons. One of which is we really want you to be able to take your .NET application, let's say it's on .NET Core 3.1, and change your CS proj to update to .NET 5 and have everything just get faster. Like, that's a key goal. We want to be able to, you don't have to rewrite a line of code. We want you to be able to either recompile or just redeploy and have everything get better. On top of that, we also want you to be able to do a little bit of work and take advantage of new functionality that is, again, explicitly focused on performance. And so you can upgrade, get benefits, write some code, get benefits. And those same APIs, we also then try to use wherever we can within the rest of the stack, such that those existing APIs benefit from the new ones. And so a lot of the changes we're going to be talking about today fit mostly into the former category, as do most of the things I've talked about in the blog posts. But this kind of is the scope of the changes that we work on when it comes to performance. Now, various changes we'll look at are about this or that change we made to the code. But I would argue that the most impactful change, bar none, that we made for .NET Core versus .NET Framework was distribution vehicle, which might seem a little strange. You don't normally think of how you deploy bits as impacting the runtime throughput or memory consumption of those bits, but it's been absolutely critical, and for one key reason. .NET Framework is distributed as part of Windows. That means that however billions of machines out there are running Windows, those billions of machines are running .NET Framework, and there is one per box. So whatever version of .NET Framework is on the box, every application on that machine is using that framework, separate from VMs and the like. If we make a change to .NET Framework as part of a patch, as part of a new version, and we push that out, every machine that gets that automatically picks up that new behavior. Every app is now running against it. And at that scale, no matter how safe the change you've made you think is, you are going to break someone, guaranteed. To the extent that we have made changes in the past that were 100% functionally correct, all they did was make something significantly faster. And that still, quote, quote, broke people because, for example, in this one case I'm thinking of, they had a latent race condition in their code, had never manifested because the area of code that would have caused the race condition simply wasn't fast enough. We made a change, we improved performance, we pushed it out, and all of a sudden we're getting calls about how Microsoft broke this customer's application simply because we had made something faster and the race conditions started triggering in their application. But there are also cases where we simply have made changes and there have been subtle corner case niche bugs, and they have, again, broken people. In fact, there's a fairly famous case from around 2008 where in the late March, I think early April timeframe, we pushed out an update to .NET Framework and broke printing in TurboTax. And if you're in the United States, you can probably guess that the one application you don't want to break during tax season is TurboTax. You think we'd learn from our lesson, but no, in 2012, we did it again. And to this point, we basically try and avoid any patches other than critical security patches to .NET Framework during US tax season. So we're extremely careful now about what kinds of changes we make to .NET Framework. And we've basically announced that while we are going to continue supporting .NET Framework and shipping security updates and patches for a very, 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 very long time, it's also not where we're investing. We're investing in .NET Core. It's where all the new functionality is going. It's where all the new perf improvements are going. It's where all of our primary energy and thought is going. The reason I say distribution vehicle matters here is because largely .NET Core is side by side. On the same machine, you can have .NET Core 2.1, .NET Core 3.1, .NET Core 5, .NET 6 preview, whatever we just released, preview 5. You can have all those on your machine at the same time in different applications. Excuse me. Different applications can be targeting different versions. So if there's a breaking change that went into a version, you don't have to upgrade to it until you have adapted your code to handle it. On top of all that, you can actually ship your own private copy of .NET Core with your application, which means you're totally walled off from anything that might have been done on the machine, and you get to choose exactly which bits you use. And in fact, there are even benefits to doing that. If you do want to deploy in that manner, you can then trim or tree shake your application such that anything from that framework that's not being used just sort of evaporates. And you get it down pretty small. For example, with the new WebAssembly support we have in Blazor for Blazor WASM with .NET 6, I think the number is a sort of the default template app for Blazor WASM is something like 1.5 or 2 megabytes for the entire application and framework, everything that kind of heads down to the browser. So lots of different mechanisms, and all of this means that our risk tolerance is way higher. So breaking changes, still a very big deal. We still think about them very thoughtfully, but we do make them. We also have a much higher tolerance for churning the code base, because even if something creeps in, there are mitigations that end users have. They can choose to wait until we fix an issue. They can choose when they roll forward, when they move to a new version. So all of this means we do large, massive rewrites. We do lots and lots and lots of small tweaks, all with the safety of knowing that our distribution vehicle enables this in a much better fashion. So distribution vehicle has been key for performance. The other thing that I alluded to earlier that's been absolutely key for performance is open source. There are only so many of us at Microsoft that actually work on .NET itself, but we want the broad community at large to benefit from the broad community at large. So if you look at, for example, the blog post that I wrote, this was around July of last year, on performance improvements that have gone into .NET 5 since .NET Core 3.1. The post at that point covered around 250 PRs focused on performance. That was a minor subset of all the PRs that had gone into release. And it wasn't even all the ones that were focused on perf. Between July and when we actually shipped in November, I think there were another 30 to 50 perf-focused PRs that actually made it in. But the key thing here is more than a fifth of them were actually from folks outside of Microsoft. And then there was another percentage from folks outside of the .NET team, and obviously a large portion from the .NET team itself. And if you look at what I'll be writing about for a .NET 6 post, it already has way more than that, which is really exciting. Now, sometimes these performance improvements are things that impact everyone. For example, there was a change, I think it was in .NET Core 3.0, that went in from one of our prolific external contributors that helped with how much time we spend doing some zeroing of stack frames in support of making sure the GC is able to do its job correctly. This is something that impacts every single method that you call. And he made it faster by employing vectorization to do the zeroing faster. Sometimes they're still significant, but way more niche. So for example, an external contributor was found spending a lot of time doing color conversions using the drawing color class and was able to submit a perf improvement for some of those conversion methods. And then there are other things where sometimes they're entirely experimental. For example, the Bing team wanted to play around with using operating system large pages as part of their application. And when it added experimental support to the GC, we reviewed it, we got it merged, and now it's an option for everyone to use, still experimental, but anyone can throw the flag and try it out. And we love all of this. So if you haven't contributed to .NET Runtime or .NET ASP.NET Core or .NET WinForms, and you're interested, I'd highly encourage you to. We love the contributions. They benefit everyone. So those are sort of two big areas of changes. But obviously we take many changes. And so the question is, how do we decide what we're going to take? Well, one way we do that is just focusing on data, micro benchmarks. So we've standardized basically on benchmark.net, which we use for measuring micro benchmarks on pretty much everything. And anytime you submit one of these PRs and we have a question about performance, we'll ask you for some benchmarks that demonstrate what it is you're trying to improve, or maybe have you tested this to see if maybe that's regressing. We also have a full regression suite of benchmark.net based benchmarks that we run on a continuous cycle. If you haven't used it, super easy. .NET add package benchmark.net goes up to NuGet, downloads the bits, updates your project file, and then you can write an application like this. This is my entire program. This line of code here is basically telling benchmark.net to find all of the benchmarks that exist in my application, of which I only have one right now. And that one benchmark is just taking a field, storing it in int32 and calling toString on it. So this is the benchmark to see the performance we have for formatting integers into strings. I can run this using however complex a command line I want, but right now I'm saying I want to run this in a release build. I want to target the lowest surface area that I care about. In this case, that's .NET Framework 4.8. I want to run all the benchmarks, and I want to run it on .NET Framework 4.8, .NET Core 2.1, .NET Core 3.1, and .NET 5. And benchmark.net is going to proceed to run this benchmark an appropriate number of times on all these platforms, doing all the statistics it needs to do to separate the noise from the signal, and end up spitting out lots of interesting information, including results like this. These are the results I got on my machine. And you can see in this particular benchmark, .NET Framework 4.8, it was taking us about 48 nanoseconds to format this 1, 2, 3, 4, 5 value into a string and allocating about 40 bytes. A few years back when we released .NET Core 2.1, that cost was cut in half from 48 nanoseconds to 22 nanoseconds, still allocating the same amount. When we moved to .NET Core 3.1, we got a tad faster, but we also shaved 20% of the cost of the memory off the operation. And then for .NET 5, the performance doubled again, getting down to 11 nanoseconds. So we can really see the progression, lots and lots of changes in each release, something as simple as int32 formatting, improving every single release of .NET Core, and that continues. Other things we measure, we don't just look at micro benchmarks, we also look at, say, industry benchmarks. So Tech Empower is a key one that we focus on. This is a set of web server focused benchmarks, web service focused benchmarks. We pay attention to different ones every release. For a long time, we were focused on the plain text benchmark, which is sort of just how fast can you send and receive the smallest possible response you can think of to the server. And you can see that ASP.NET over, I don't know how many of the previous rounds, has been in the top positions, tied for basically #1 with any number of other frameworks. But for example, in the last release, we picked 2 specific benchmarks. For .NET 5, we really wanted to improve our standing on the JSON serialization benchmark, which, while it does involve JSON serialization, is really another request response. And then also the Fortunes benchmark, which is about a request coming into a web server that then contacts a backend database as part of the request and response. And you can see for the Fortune benchmarks, for example, we had 2 entries with 2 different database providers sitting behind it, or sorry, 2 different transport layers sitting behind it. But they were both approximately the same, about 280,000 requests per second. This is on Linux. And you can see this in the rankings, this put us at about 24 or 26, depending on which transport we were using. When we moved to .NET 5, you can see that 280,000 requests per second in the official numbers went up to 400,000 requests per second and jumped ASP.NET to be in the top 10. So these are the kinds of things we're paying attention to. And there are many, many changes where a PR will come up, and either we'll ask the contributor if they have access to our backend test systems to try it out with Tech Empower, or we'll take it ourselves and try it out with the various Tech Empower benchmarks to see if and how a particular change may positively or negatively impact the various benchmarks that we're looking at. Obviously, you know, we care about performance on benchmarks, but at the end of the day, there's some reason we're trying to improve the performance of something. Sometimes we want to improve the user experience. We want requests to make it to the user faster so that they show up faster. We want to be able to allow more users at the same time so that people aren't timing out or whatever. We want the user interface to be snappy, but it can also just be, at the end of the day, saving dollars, right? If I can do more with less, if I can get things done faster and use my machine for less time, I can use that machine for something else, and this can translate into real dollar savings. So one of the things I focus on is various internal and external systems where I'm able to sort of see, waving my hands, how many cores are being used for some duration of time in the execution of particular functions. When that number reaches something like, say, 1,000 or 10,000 or 20,000, I start to really pay attention to, wow, this is really an area that we should go and invest, because at the end of the day, that's going to save everyone lots of money. And to David's previous comments about the environment and CO2, it's going to keep a lot of emissions out of the atmosphere. So, for example, in the last release in .NET 5, regex was something that was popping, that was really showing up as being used by lots of folks, Microsoft and non-Microsoft, in Azure, out of Azure, as being a real consumer of cycles, of CPU cycles. And so it's an area we invested. So I grabbed this regex off the net. This is a regex for parsing emails. And a simple example here, just looking for someone at example.org. Again, this is with the benchmark.net syntax. So just paste that into the previous example I had and see if this particular address matches with this regex. And we can run it again on .NET Framework 4.8 and then .NET Core 3.1 and .NET 5 and see the kinds of improvements that went into the release. So for example, on .NET Framework 4.8, we were taking about 470 nanoseconds. Then on .NET Core 3.1, between the few years in between there, we managed to shave off about 20% of the costs. But then for .NET 5, we were able to cut that by another third or so, getting it down to 148 nanoseconds for this particular operation. That is a huge savings when it comes to CPU cycles and the money we're spending on on these resources. If you've got an app and you're paying per core in Azure and you can do it with 1/4 the cores, that's going to make you pretty happy, and it's going to make your budget pretty happy. Another example in the sort of 1,000 cores club from recent releases is compression. Compression shows up in all manner of workloads. So here, a little benchmark, it's grabbing, I think I grabbed the complete works of Mark Twain from Gutenberg as a text file. I'm compressing it as a setup step. I'm compressing it into a stream. And then the benchmark is just repeatedly decompressing it and seeing how fast we can decompress that. Ran this on .NET Framework 4.8 and ran it on .NET 5. You can see we get about 20% faster. We also dramatically reduced the amount of allocation required, going from 350K down to basically nothing. But what's really interesting about this is, I mentioned we're very careful about what the changes we make to .NET Framework 4.8, to .NET Framework in general. This one was so impactful. The improvements that we made to compression were about 3 or 4x previous releases. This was so impactful and showed up in so many workloads that this .NET Framework 4.8 number actually includes having backported this particular set of performance improvements back to .NET Framework, just because it was of that order of magnitude. This is one of, I don't know, I can probably count on one, maybe two hands, the number of performance-focused changes that have gone back from .NET Core to .NET Framework, but this was one of them. So this is, for .NET 5, this is 20% on top of that 3x gain that was already ported back. So these are, we think of compression and regex as being sort of meaty examples. There are also things we're spending just a whole lot of time simply because the sheer number of times you invoke them. So for something like dictionary, right, shows up everywhere, and you expect something like try get value to be so fast that who cares about how much it costs? It's going to be so fast, it doesn't really matter. But you do that millions and millions and billions of time, any performance improvements there actually add up. And so it's an area where every release, and again, I mean the broader we, because a lot of contributions here have actually come from external sources, external to Microsoft. We have every release driven down the cost of operations on dictionary. So for example, .NET Framework 4.8, you can see this particular example is basically doing 1,000 lookups, 1,000 ordinal ignore case lookups on strings in the dictionary, summing up and returning that value. So that was taking about 16 microseconds on .NET Framework 4.8. We halved that for .NET Core 3.1, getting it down to about 30 microseconds, and then shaved off another 30% on top of that for .NET 5, getting it down to about 20 microseconds. So we make changes to things that are big, and we make changes to things that are small but used a lot. And just one more example, since we're talking about the web, and UTF-8 is very prevalent on the web. Something like UTF-8 encoding ends up being used a lot, and is part of this, what I term the thousands of cores club. And so this benchmark here, all I'm doing is I'm turning a string into an array of bytes, then going back to a string. And we can see on .NET Framework 4.8, this was taking about 190 nanoseconds on my machine, and we more than doubled the throughput down to about 80 nanoseconds for .NET 5. And all this stuff continues to just get faster for .NET 6. So there are many ways that we have achieved these improvements. And again, I mean the broader we, I'm not just talking about folks at Microsoft, but all the contributions from folks at Microsoft and in the broader .NET community. Sometimes it's via complete rewrites, and these are the kinds of things that we would always shy away from in .NET Framework for fear of any kind of compatibility issue. But for example, concurrent queue. Concurrent queue first shipped in .NET Framework 4.0, and it was a good implementation. but it wasn't a great implementation. And so for .NET Core 2.1, we completely rewrote it, focusing on the kinds of costs, the kinds of use cases, the kinds of scenarios we saw concurrent queue being used in, with a particular focus on, for large scale, reducing synchronization costs, and most importantly, reducing memory usage. We got it to the point where it was so fast, we were able to throw away thread pool's queue and replace it literally just with concurrent queue. So now the system.threading.threadpool, its global queue is a concurrent queue of T. And we can see why. If I have a little benchmark here, I've got a concurrent queue of ints. I spin up two tasks. They both wait for each other, so they start at the same time. One of them then queues 1 million integers, and the other one tries dequeues, spins until it can dequeue all 1 million of those integers. We can see on .NET Framework 4.8, this particular benchmark on my machine was taking about 45 milliseconds and was allocating about 8.5 megabytes of memory. And on .NET 5, we dropped that by 4x down to 11 milliseconds and basically got it to allocate nothing. So from 8.5 megabytes to a few hundred bytes for this particular benchmark, which is pretty great. Sometimes it's not about doing complete rewrite. Sometimes it's being thoughtful about the algorithmic complexity that's being used in these various various operations. So for example, in link, we can see in this benchmark, I've got some data in an array and I'm sorting it, and then I'm going to skip the first 10 and I'm going to grab the first thing after the first 10. And previously, this operation would have done a full sort, an order n log n sort, and then skip through the first 10 and then return that element. But we can actually pass data from the order by to the skip to the first, which is actually where the execution happens. And the first operation could say, interesting, you're doing an order by, but you only care about one value. So I can do, instead of doing, say, a full sort, I can just do a partial select to only zero in, to only sort the pieces of the data that I need to find the one value that's critical, changing the algorithmic complexity and the amount of work being done. And you can see that then drops me, in this particular example, from 3.7 seconds to about 200 milliseconds. And that difference would grow dramatically the more data I threw at it, to the point where I probably couldn't even put it on the screen because my operation wouldn't have finished in time. So sometimes it's complete rewrite, sometimes it's algorithmic complexity, and sometimes it's totally changing the way we write our code. So for example, in .NET Core 2.1, we introduced span, and this has been a complete game changer for the code that we write throughout the .NET stack, permeating all levels of the stack, from the runtime all the way through up ASP.NET Core and to applications on top of the runtime and core libraries for developers that care about performance. What is span? Well, I'm using a little bit of made up C# syntax here because today in C# you can't actually express what span is. You probably will be able to in a future release of C#. But essentially span is a tuple of a ref and an int. So it's basically a pointer, just a managed pointer, like if you were passing a ref to a function, except this one happens to be a part of a struct, and a length. So basically we're referring to some contiguous piece of memory where it starts and then a length. And I can use a span to represent a string. I can use a span to represent an array. I can use a span to represent some data on the stack. I can use a span to represent some native memory. So I can represent all these different things with one type, so that I can unify all of my logic around all of these data types. And that type is fully safe just as array. So it's fully bounds checked and all that. And then I can do really interesting operations on this. So the conversion to span is zero allocation. Indexing, and I can index just like I can with array. I can slice it in an allocation-free manner, since all I'm doing is moving the pointer and changing the length. I can also reinterpret this. So with an array, if I had an array of integers and I wanted an array of bytes, I would have to allocate a new array of bytes, copy over the relevant data and then use that. With spans, I can just reinterpret, effectively a reinterpret cast like you had in C++, reinterpret that span of integers as a span of bytes and then continue to operate on it. And then throughout the framework, there are hundreds upon hundreds upon hundreds of methods now that operate on spans in addition to strings and arrays and so on. All of this gives us performance and safety, and in a way that we're able to leverage throughout pretty much everything that we now do. On top of that, there are now optimizations, more and more optimizations in the JIT focused on the spans, so that certain patterns that developers write are now hyper optimized, whereas previously with arrays they may not have been. And also optimizations showing up in things like the C# compiler itself for generating more efficient code when you use spans because of certain constraints the compiler can trust based on it. So let's just take one simple example here. We've got a function here where I'm taking in a quoted string and I want to say hello to that person's name, in this case Stephen, by stripping off the quotes. So I have to do a substring operation and then I concatenate hello and the substring. I run this on .NET Framework 4.8 and .NET 5, and you can see it's nice, we're maybe 15% faster on .NET 5 already, but we can do better than that. So if I wanted to use spans, I could, for example, first stack allocate a span. And you notice I don't have to use unsafe here because the C# compiler trusts that if I'm storing a stack alloc directly into a span, that is a safe operation. I'm not directly accessing a pointer. I can copy the literal hello into the span. I can slice that string as a span, the name string, to slice off the quotes, copy that to the output, and then I can finally return the relevant portion of that span as a string. Now I run this on .NET 5, and we see that 22 nanoseconds drops to 18 nanoseconds, but I've also cut my allocation in half. But now we can say, all right, well, that's nice, but that's a lot of code, some complication there. Couldn't we wrap that up into helpful functions that I could reuse? And so we end up exposing things like an overloaded string.concat that accepts spans. And now I can write almost the exact same code, shorter even than the original code, just using spans and slicing them. And now not only do I allocate half the amount, but I'm more than double the throughput that I had in the original code. There are also other significant benefits to span. One of the things that we've done in that we focused on as part of these pervasive coding changes is we've actually focused a lot on moving code that was in C and C++ into C#. And this might be counterintuitive. Most people think, oh, C and C++, they're way faster than C#. But there are many cases where that's simply not true, and many reasons for that. We can look at an example of this. In .NET 5, we added a whole bunch of sorting routines for spans. In fact, we took all of the code that was in the runtime for sorting arrays. It was written in C and C++. We deleted it. We instead wrote it in C#, almost entirely safe C# with just a few unsafe pieces in very constrained regions that we could, hyper focus on reviewing. Did it in terms of spans, and then we actually have array.sort on top of that. So array.sort is actually using span sorting. And we can see the impact of this. I've got a benchmark here that just fills an array with some reverse sorted numbers, then sorts it. And we can run it on .NET Framework 4.8. This particular operation was taking 95 nanoseconds. There were some minor improvements that had gone into .NET Core 3.1 that shaved about 10% off of that. But then you can see for .NET 5, where we moved this into C# and wrote it with spans, you can see it's twice as fast as what it was in .NET Framework 4.8. And there are lots of great benefits to spans and also to this kind of rewriting that we're doing from C, C++ to C#. One of them is this kind of pervasive use of spans. Because the logic was in C#, it was a lot easier for us to then use spans with it. This then allowed us to not only use it internally, but expose it out for other code to take advantage of. But there are other advantages. When that code was all in C and C++, it was all sort of unsafe. It was all pointer manipulation. Whereas when we moved it to C#, as I mentioned, we were able to keep it almost entirely in bounds checked C# code and only make the one or two critical tight inner loops in a few places, I think 2 places, in the entire implementation ended up being quote unquote unsafe. Another benefit of this is, a lot of the contributors that come to the .NET Runtime repo prefer working in C# than in C++. They can experiment faster given the syntax and the niceties of the language and the libraries and whatnot. And so we end up finding that more people are interested in experimenting and contributing more when code is in C#. And so we end up seeing many more PRs to further improve performance and experiment with things than we did when they were in C or C++. So it's not that C# in this case ends up being faster, it's that more time was invested in finding ways to optimize the code. At the same time, we're also, because it is safe, we're happy to accept those kinds of changes because we don't have to, or we're happy to more readily accept them because we don't have to worry about the same kind of potential security vulnerabilities or buffer overruns and the like that we would have had to scrutinize the native for. And therefore, we can spend less time doing a better job reviewing the changes and having a higher level of faith in them. But there's actually another benefit to this this moving stuff out, and that has to do with garbage collection. So for any of you who run, who do web services, and you're focused on things like, I'm running my server GC, but every once in a while it pauses for a massive period of time. And my latency shoots up. And so, my 95 or 99th percentile latency is much higher than I would like it to be. That's because of GC pause time. When the GC needs to do a lot of its work, it has to pause the world, make sure all the threads are in a stable position. Then it can do its work, and then it can allow the threads to release. But there are certain operations that you could do. Well, let me take a step back. Every time we transition from C#, like corelib, into the runtime, there's transition costs. Like when you make a p invoke, there's some overhead associated with the p invoke. When we transition into the runtime, there's some overhead associated with that. And for certain really fast operations, we try and eschew as much of that overhead as possible by cutting some corners. And sometimes cutting those corners means that the GC isn't able to do as good a job of interrupting those threads as we would like. And we can see an example of that here. So I've got a little application that is spinning up a background thread, and all it's doing is sitting in a tight loop, sorting an array, which which is always going to be sorted. So it's just very fast, try and sort it, already sorted, try and sort it, already sorted, in and out of managed code between C# and the runtime when the sorting code was in native. And then I've got my main thread is 10 times, it's forcing a garbage collection, and then it's sleeping for about 15 milliseconds, forcing a garbage collection, sleeping for 15 milliseconds. So because I'm doing this 10 times, you'd expect it to sleep for 15, 16, 17, 150, 160, 170 milliseconds. And then the GC is going to take some time. So let's round it up and guesstimate that this is going to take about 200 milliseconds to run. But I run it on .NET Core 3.1, and I get similar results for .NET Framework 4.8. And we see it's nowhere close to that. It's taking 3 seconds, 4 seconds, 5 seconds to do this operation. And the reason for that is because of those fast transitions where we cut some corners, the GC is having a really hard time interrupting that background thread that's calling into the runtime. And as such, it's having to pause the world and that main thread while it keeps trying to interrupt that background thread. When we moved all this into managed code, the GC was able to do a much better job at managing this. And so now when we run it on .NET 5, you can see that 2, 3, 4, 5 seconds is much closer to the 200 milliseconds that we initially sort of waved our hands at and predicted. So span is sort of one very pervasive change we see throughout. Another has to do with async. So async await and tasks in C# have permeated everything everyone does. And as a result, in .NET Core 2.1, we completely rewrote the infrastructure behind async await. And you can see the results of this in a simple benchmark. Here I've got a benchmark that is 1,000 times its yielding. So it's basically awaiting something that completes immediately after the await. So it's always just sort of forcing it to post back. And just for fun, I've added an async local since that shows up in a lot of these. When I run this on .NET Framework 4.8, you can see this was taking about 2 milliseconds. When I run it on .NET Core 2.1, you can see that more than cut in half to about 920 or 930 microseconds. And by .NET 5, we got that down to about 800 microseconds. But the big thing you can see here is in memory allocation, the jump between .NET Framework 4.8 and .NET Core 2.1, we went from over 600K to about 100K allocated for this operation, which is great. And you can see why here. If I do a memory trace this is using the allocation profiler in Visual Studio, you can see all the objects that were being allocated in .NET Framework 4.8, and then in .NET 5, we just have this one allocation per iteration. So this is very nice, but we're still, that one allocation is for the task that's being returned from that yield once method. So what if we could do something about that? So in, I believe, .NET Core 2.0, we introduced value task of T. Value task of T was nothing more than a discriminated union between a T and a task of T, which meant that if you returned this from one of your async methods, and the async method completed synchronously, which is actually very common. In fact, probably 95% of all async methods end up completing synchronously. The first time you call, say, reading from a buffered stream, it's going to have to go out and do some I/O. But the next time it's got data buffered, and so that async read actually completes synchronously. For that case, we can return the T in the value task rather than a task of T and avoid that allocation. But even for asynchronously completing operations, for asynchronously completed operations, this didn't help. But we actually in .NET Core 2.1 introduced the ability to help by adding a new interface. And so not only could a value task wrap a T or a task of T, it could also wrap an I-value task source of T, which then allowed an implementation to plug in its own sort of backing object behind a value task, and in doing so, enabled it to pool it or reuse the same object over and over. And we can see this as an example using sockets. So sockets, as of .NET Core 2.1, take advantage of this because it's extremely common to do, say, very, very tight hot loop receive and send async operations on sockets, and we want those to be as allocation free as possible. So I run this benchmark, which is just doing 1,000 receives. So there's no data available. It is going to yield. Then I send some data. And then I wait for the receive because the receive is now able to be satisfied by the sent data. And we can see for this particular benchmark of 1,000 receives and sends, on .NET Framework 4.8, this was taking 35 milliseconds and allocating over 300K. And on .NET Core 2.1, you'll notice the allocation column has a dash. There is zero allocation associated with this benchmark now, because once the socket is created and the object that is being used to back these value tasks has been created, we know we never again have to allocate anything for synchronously or asynchronously excuse me, completing send or receive operations. And you can see over time then in the networking stack, we've also made further improvements. So in .NET Core 3.1, things got, throughput got better. And again, in .NET 5, things got even better. So async has been a big area where we've made pervasive changes across the stack. And you can see many more places taking advantage of these I-value task source implementations. In fact, for .NET 6, one of the likely things we have landing is both framework support and compiler support for being able to use pooled I-value task source an implementation behind your own async value task methods automatically, just via tagging them with an attribute. So I'm excited to, hopefully that will land for .NET 6. One other thing that's been pervasive has been array pool. I don't have a benchmark for this, but just as an example, this is very similar to the code that we have in stream.copy2async. It used to be that we would allocate a brand new array for every time you did copy2async. Now we rent one from the shared array pool, which we can optimize to our heart's content. We rent the buffer, we use it, we return it, and in general, this drastically reduces the amount of allocation while doing better around cache coherency and not thrashing caches and the like that we might otherwise get. One more example of pervasive changes we've made, and that has to do with vectorization and hardware intrinsics. So for years now, .NET has had vector types for doing multiple operations at the same time, taking advantage of functionality in extension architectures and things like SSE, SSE2, AVX, AVX2, and so on. But we've also in recent years started adding direct access, individual access to these instructions, yielding literally thousands of new methods in .NET Core 3.0, 5.0, and 6.0. And these operations are now being used pervasively throughout the lower levels of the libraries in span and string, encoding, JSON serializer, even things like WebSocket are getting it on the game. We can see example of why this matters. I've got a little bit of Shakespeare here, and I'm just searching string.contains for a particular word in this text, doing an ordinal search. And when I run this on .NET Framework 4.8, you can see this was taking about 40 nanoseconds. This was not vectorized. In .NET Core 2.1, we took advantage of the vector types and vectorized this, and we went from about 41 nanoseconds to about 10 nanoseconds, so about 4x faster. And then starting in 3.1 and 5.0, we started taking advantage of the direct intrinsics. We got a lot of the way there with the sort of the general vector support, and then taking advantage of the direct intrinsics to eke out even more. So we went from 10 nanoseconds to 7, and then for .NET 5 to 6 nanoseconds. And so every release, we're really pushing the boundaries, and more functionality ends up using this sort of base level of performance-focused API. So that was a whirlwind tour. I am basically out of time. If I could ask two things of everyone here, it is first, if you're still on .NET Framework, please start thinking about moving to .NET Core. It's where all of our energies are going. It's where all of the performance improvements are going. It's where all the new functionality is going. It's where the world is moving. So if you haven't gotten there, totally understandable, but please be thinking about it. If you're already on .NET Core, please stay current, because as you can see, every release just gets better and better and better. And staying current also then means that you have a better chance of contributing. Issues that you find, you can come help us fix, and you can take advantage of things as soon as they're released. And then my second request is get involved. If there are things you'd like to see be better, file issues on .NET Runtime or .NET ASP.NET Core, or .NET WinForms, whoever it may be. Or if there are, if you'd like to actually get your feet wet and actually try and make some PRs, we would love it. Come find things to improve, whether it be something as simple as comments or something as complicated as vectorizing some new operation, taking advantage of hardware intrinsics. Whatever it is, we would love to have you. And with that, I will say thanks, and I guess see if we have any questions.
Yeah, I think we just have a few. Okay, I'm not on mute again. Let's see. Is regex benchmark is probably faster on .NET 6 with source generation?
So that's a good question. So we would like to implement, I think by source generation, you mean like a Roslyn source generator. We have it in our plans to implement a Roslyn source generator for regex, but it's unlikely to land for .NET 6. I'm very hopeful it will for .NET 7. The main thing that would improve isn't runtime throughput, but startup performance. In particular, because the way, whether you're doing interpreted regexes or compiled regexes, there is parsing to parse the regex, optimizations that happens over the regex tree. And if you're doing compiling, then it ends up with the regex options compiled flag. We need to basically generate IL and JIT it as part of getting to the very first time you execute that regex. Much of that goes away with a regex source generator because we're able to do all of that parsing and optimization and effectively IL generation at compile time rather than at runtime. Throughput should be basically the same. But yeah, I'm hopeful that lands. I'm looking forward to that.
Cool. And I think the next one is, what about splitting strings with span?
That's a good question. There's an open issue for it. We had a PR that we merged and then ultimately reverted because of some concerns about it, and we haven't yet revisited it. The good news is, you can split with index of like you always could, and index of is vectorized, and there are other new APIs in .NET 6 for doing certain kinds of splitting. For example, there's new functionality in .NET 6 for splitting a span on new lines, for example. But a general span.split is unlikely to land for .NET 6. There are still some concerns about how it shows up. If you have thoughts about it, please join us in the .NET Runtime repo, search for the issue around span and split, and contribute.
Cool. And I do have a couple comments about your session I want to part with before you leave. And that is, I've already said this before, and I forget which one of my guests on my show I talked about this with, but because I have a code performance book out and I benchmark everything, all my open source projects are benchmarked now using benchmark.net. And so I spent a lot of time doing that. But I have to tell you that performance increases, from especially from framework to .NET 5, but core to .NET 5 has just been dramatic, like you were showing, and one of my guests, I asked him, what the heck did you guys do? You found some magic somewhere, because all of a sudden everything is so much freaking faster in .NET 5. So I really have to hand it to you and your team to putting on all that work, for all us, lonely developers, not lonely, but developers out here.
Well, and I want to stress that it's, obviously there's a lot of effort that comes from me and others on my team, but I really want to stress that it is a broad community effort. As I mentioned, a lot of the performance improvements, some of the critical ones, in fact, came from folks outside of the .NET team, outside of Microsoft, the isolated developers, or lonely developers, I think, as you put it, just, improving their own lives by contributing to the .NET stack. So again, I appreciate your saying that, and we do invest a lot in it, but it also has a lot to do with all of you out there.
Yeah, but you all did just an awesome job, and I'm still struggling with Microsoft actually listens to us now. So I keep forgetting to put in request, but I've done a lot of I've submitted a bunch of stuff, mostly around Visual Studio, but I have to tell everybody out there that Microsoft listens now. So please make a comment. They can't change things if you don't tell them about it, right? And tweeting is good, but you need to go submit it through their different channels there to get it into the system, and then they'll look at, and like you said, they look at it. And the other thing I want to say real quick is benchmark.net is awesome. I know you guys use it. I use it in all my stuff now, and I even created a NuGet package open source project to kind of make setting up on benchmark.net a tiny bit easier, but it sets it up. It's basically what I use in all my testing, and so I have a lot of stuff in there to pre-create collections and all these kind of things, so you can just use them. But so I hope people will go check that out. But if you're not using benchmark.net, you need to. It's a great product, and those guys listen too. I've even submitted some stuff to them, and they've fixed things, and so they're pretty responsive too. And what was it on GitHub? Yeah, I think that's about it. That's all my comments. So thanks a lot so much for being on the conference, and I'm glad we got you worked out, because I know you have a meeting right after this with
sorry about the last minute reschedule.
It's okay. Everything worked out. So I really appreciate you being here, and I hope we get you on maybe next year when we do this, and maybe one Saturday when you're free, you can be on my show.
Thanks.
All right, thank you.
Thanks a lot.
That's great. The one thing I didn't say is I really need to learn a lot more about span. So not spam, span. All right, we're a little bit over time, so we got a bunch of giveaways to do. We're going to do 3 giveaways this time. If you haven't made a comment in the chat, or you haven't made a comment on social media, please make a comment and use the hashtag CodeQualityConf21, and that's how you win. We've been picking everybody by random, but for the next Amazon gift card, because I'm hosting this, I decided to give away the winner. And do you want to show the winner of the next Amazon gift card there, Simon? Yeah. So there's the winner of the next gift card, because she took her time out and made this awesome meme on Twitter. I thought it made me laugh. I really liked it. So I appreciate that. Congratulations. And make sure you get in contact with Simon, and so we can get you the Amazon gift card. that was cool. I'm glad that somebody did that. I really liked it. So the next thing we're going to do is we're going to give away our last 140 Stratus bucks. So Simon, do you want to pick the winner? Dun, 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 dun. Overops. Wait, do we have to run this again? Is that a person or is that a company?
I think that's a company.
Okay, let's do it again and pick a person. I need a drum. I don't have a drum. I didn't.
You need to bring your guitar.
That. I have my guitar right here. Oh, come on, Simon, there's something wrong with your code.
I'm sorry. I got to debug it.
It's all good. Makes me laugh, which I need.
I need to. Oh no!
All right, we got to do it again. I'll play a couple chords. All right, we got a winner. So there you go. Whoop, I lost my earpiece. Finally, so you get the last of the 140 Stratus bucks. We still have 300 Stratus bucks to give away next, and now we're going to give away another license for Grape City. So roll it. Let's pick the winner for Grape City. So you get to pick anything .NET related Grape City makes, which ranges from $500 to $900 basically, and they make awesome controls and reporting software. Great. John Franklin. All right. You win the Grape City license. So get in contact with Simon so I can get your email, and I'll send you out information this weekend about that. So congratulations. And with that, I want to bring on, I'm going the wrong way. Our next session, we're getting close to the end already. I can't believe it. But the next session is analyzing code at .NET, which is really near and dear to my heart because I don't see enough people doing this. So with Jason Bach, I'm sorry. And so let's bring on Jason. Welcome, Jason.
Hi, how you doing?
Good. How are you doing?
I'm doing well. It's a Friday afternoon. Weather's great.
Yeah. You're in Chicago, right?
The Twin Cities in Minnesota.
Minnesota, yeah. And I just thought, you guys have to stop rejecting my resume when I submit it. That's all I'm saying, I'm just kidding. But yeah, I'm glad you're on the conference, and because analyzing code is something that I spend a lot of time on, and probably more time than anybody I know, and so it's an important thing that it's an important skill that I think all developers need to learn and use all the time, and I do. So I'm glad you're here, and take it away.
All right, get my clock going, get PowerPoint going, and we are off. So thanks everybody for joining on my session. Again, my name is Jason Bach. I'm a developer advocate at Rocket Mortgage, and my talk in this session is analyzing code in .NET. That's where you can find out a little bit more about me. If you have any questions, put them in the chat. As I've been watching other speakers during the day, we're kind of doing all the Q&A at the end, so I will try to answer some questions then. Otherwise, feel free to send me an email at jasonbach1@quickenloans.com, and I'll try to answer it as best as I can that way. So I'm going to be doing a couple of demos, and those first two links are repositories where you can download that code and check it out if you'd like. The slide deck for this presentation is in that third repository, so you can go get it there. And I'd highly encourage you to do that, because in each slide, I usually have links to things related to that slide in the notes section. And also in the last slide, there is a lot of references to things that you could take a look at and dive in deeper later. So get the slide deck and take a look at what's in the notes section. So I'm going to be spending some time on what code analysis is, why it's important, why it's something you should care about, and how you can use it. And I'm also going to talk about how you can build analyzers yourself, along with some code fixes in .NET. And then we'll wrap it up with a call to action and some things that I encourage you to take away from this session. Okay. All right. Code analysis. There's lots of things in software development that I get excited about or I'm interested in, but there's been some things throughout my career that I really have spent more time focusing on and really enjoy diving into and learning about. And one of them is this idea of analyzing code and using things like compilers and other stuff like that to accomplish that. So why is this something that you would care about, especially if you haven't done this yet, or you've never really looked into this or what this is doing? Why is this something that you may want to consider starting to use in your own code bases? So I'm going to use a real world example here, and I apologize for the pictures because they're a little grainy, but they're old. So that will explain why they look a little fuzzy. But here's a picture of a bridge, and you may know this bridge by just looking at it. Okay, or you may not. It may just look like a typical span bridge. Well, this is a very famous bridge. This is talked a lot about in engineering circles as an example of a major disaster. It's the Tacoma Narrows Bridge, and it also had the nickname Galloping Gertie. And the reason why is because the engineers that built this bridge didn't take into consideration all the wind conditions that can happen in this area. And even as they were building the bridge and putting the decks out, they would start to actually sway a little bit. And it got this name, Galloping Gertie. In fact, they would have to close the bridge because the swaying back and forth on the deck would become so severe, people couldn't drive on it safely. So one day somebody was out there, this is like in the 1940s. One day somebody was out there with a camera and actually filming this bridge as it was experiencing these conditions. And in fact, they were so bad that people were starting to wonder, was this actually going to break? And unfortunately, it did. So that's the result of this bridge. So I highly encourage you to go to YouTube and look up Tacoma Narrows Bridge disaster or something like that, and you'll see the video of this happening. Fortunately, no human lives were lost. Unfortunately, a dog died in this accident. The dog was in a car that was on the bridge, and people tried to get the dog out of the car, but the dog was so terrified it wouldn't leave, and they had to get off the bridge. So the dog perished in the disaster, but fortunately, no human lives lost. But as you could imagine, a bridge like this that gets destroyed in this manner, it's a significant cost investment to rebuild it. Okay. Whereas if they would have done it right the first time, how many times have you heard that as a software developer? If you did it right the first time, then things like this can be avoided. Now, to be fair, accidents happen, mistakes happen. We're human, we're fallible. And when I say we, I mean me as well. Just because I'm talking about things that are mistakes in code doesn't mean I don't make them. I make them all the time, as I know you do as well. So there's no blame going on here in this presentation. In fact, what I'm trying to do is encourage people to accept the fact that, we all make mistakes, and we're trying to minimize those mistakes, because we don't want to end up in a situation like this, where we have this major disaster happening that's costly, not just from a financial perspective, but maybe from a trust perspective, in terms of I'm part of a company and we release software and it causes severe problems for our customers, and that starts getting reported on things like Twitter. There was an incident last night, I believe, where people were getting emails, I believe it was from HBO, and everybody was talking about getting this form letter from HBO, I believe it was. So, just things like that gets you attention, and it may not be the attention you're looking for. So how do we try to minimize these? We can never get rid of them, but how do we minimize them? You can think of doing some kind of review. And when I say code review, I don't necessarily mean being in the same room together. That's, I'm somewhat of an older person, and I remember talking and hearing about code reviews where everybody would be in the same room. But that's really not that much of a thing these days anymore, at least from what I can see. And that's not necessarily because people have been isolating and trying to stay safe during the pandemic. It's because we have the tools are so good these days to be able to do reviews in a much quicker, much faster way, especially if you're using things like GitHub, where you can examine a PR, look at all the changes that are in files, make comments in them. The collaboration and interaction is much, much better. But sometimes it's helpful to sit in a room, even if you're doing like a design process, or if you're trying to review something that is very tricky, very complicated. You definitely want to have people looking over this and saying, hey, maybe there's something that you're doing wrong. Because humans, this is a two-edged sword. We have a really good capacity and capability of finding patterns, finding things that catch our eye and go, that doesn't look right, or that's different. That can also be a detriment in some cases as well. But just by looking at code, sometimes we can see things and go, wow, that's interesting. So here's an example. This is a piece of code that I found pervasive in a code base that a client that I was working for had purchased from a person who had built this system over 15 years. And this person was very humble. He said, he didn't have any training in software development. That wasn't what his career goal was, but he stumbled across this opportunity and he just dove into it and made this thing happen for him for 15 years. And it provided very well for his family. And he finally just said, I want to sell and I want to get rid of this. And this client said, yeah, we want to take this. So we were looking through this code to start off with, because we needed to take something that wasn't meant to be running in a cloud environment and put it into something like AWS. So we were looking through all these things that we said, wow, that's going to be interesting. And we started noticing this piece of code, not exactly like this, but something like this everywhere in this code base. And so what this is doing is, if you trace through the logic of this, is it's taking the contents of an array and copying it into another array. Now, why you would do that, I was watching Stephen Taub doing his talk beforehand, and you always start thinking a lot about allocations and performance and how that affects the characteristics of your application. But ignore that part for just a second here. Let's just assume there's reasons why you want to copy the array. How would you do it? I would use something like copy2 or array.copy. What this code is doing in a nutshell is making all these temporary arrays of size 1, 2, 3, 4, 5, all the way up to the size of the original array, and copying the element out at the end one by one. You can imagine the number of allocations and the GC pressure that would be put in .NET by running this code. And again, this wasn't in one place, this was everywhere. Okay. Now, I did some benchmarking on this, and for small arrays, the performance, you really wouldn't notice anything in the large. But if an array would start getting more elements, like hundreds, maybe thousands, you would start to see it take off and be much less performant and allocate a lot more memory than just simply doing copy2. And I found it funny that the developer was close. You see right in the code a call to copy2, but somehow came up with this to do the whole array copy. Okay. So if you would see this code come by you, I think you would do that kind of double take and go, wait a minute, something's not right here. And you would look further and say, okay, wait, hold on, what's going on? So sometimes you can find easy wins like this in code. More often than not, finding those bugs can be really, really hard, and the search can take a lot of time, and you might just completely miss it. And those are the ones that seem to get a lot of press. For example, here's two that I'll go through. Here's a piece of code that caused a bug on every device that it was on. Okay. And this device was the immensely popular Microsoft Zune. I know everyone that's listening had one of these. You all rocked the Zune when it was out. Okay, maybe you didn't. Maybe some of you are like, what is a Zune? I had a Zune. I actually liked it. I thought it was a good device. This was Microsoft's competitor to the iPod, and it, arguably didn't compete that well. But again, I still like the device. Here's the thing, though. if you try to start your device on December 31st, 2008, it would kind of go through this initialization screen, and then it was supposed to go to like a start screen or a hello screen where you could start playing music. You'd never get there. You could turn it off, turn it on. You could hard reset it. You could do all these things. Didn't matter. It would not boot up. And the reason why is because of the code that you're seeing on the screen here. It has a subtle bug that in a leap year, you never exit the while loop. And this was in a driver that was called during the startup of the Zune. So all these people, New Year's Eve couldn't start their Zune up. Now you have to remember this is in 2008. So the bug report was from Microsoft is, yes, we know there's a bug. We will be fixing it. But if you can wait a day, then you can just start it up again on the next day, January 1st, and all will be well. And we'll eventually get a patch out to the driver. Now in 2021, software updates, we have auto updates. We can update software much, much easier. It's something that I personally don't really even think about that much anymore. But back then, it was a much different story. And I find this funny that you can say to your users, you know what, we'll fix the bug, just wait a day, and then we'll get it out there. That's not really acceptable, especially for other software applications. Could you say to your user in the morning, yeah, just wait a day and we'll get around to it? In some cases, that's not an acceptable answer. What about this one? So this is a piece of code from a very famous bug. And I didn't write it, thankfully. I couldn't have written it because I'm not a C or C++ developer. I did that very sparingly years and years ago, and I'm nowhere near a novice on that anymore. Okay. But what's interesting about this code is, yes, there's comments in there say this was generated code. And this was the root cause of the Cloud Bleed bug. If you remember what that was. Okay, this massive bug from Cloudflare. And what's interesting is the text I have in bold there, that in that root cause analysis, they figured out that if that would have been, instead of an equals, if it would have been a greater than or equals, would not have been a bug. But because of that one line of code, that's what led to this massive security bug. Okay. Small things can lead to really big consequences. You really need to have that microscopic look on code, because in some cases, those bugs are very, very difficult to find. Okay. But we still need to try. So how do we do this? Well, one thing that you can do is write tests. This is not a talk on writing tests, but I still want to mention this because I think it's very important for developers to use testing frameworks, to test their own code, eat their own dog food, make sure that they're doing the best attempt they can to see, is the code that they've written, is it working the way that they expected it to? And there's great frameworks out there like NUnit and XUnit that you can use in .NET to write tests against. So if you're not doing that yet, I would highly encourage you to start doing it. I've been writing tests for all the projects I've been on for almost since, I'd say, 2003. Okay. And so I highly recommend that you would consider doing that if that's not part of your habit already. Okay. I do want to make a point though about testing, that there is a tool in Visual Studio, and it's only in the enterprise version, which I'm not trying to sell, I'm just making the point here. But it's this tool called IntelliTest. So unfortunately, it only works in enterprise, and it only works against .NET Framework code that isn't using the SDK style project format, which is pretty prevalent these days for any new work that you're doing in .NET. If you ever open up a CS proj file, you'll know what I mean. But what's interesting about this tool is that it looks at your code and says, what are essentially all the boundary conditions of your code? And then I'm going to write tests for you to exercise that code. Okay. Now, when I would show this before, people would sometimes go, ooh, this is great. It's going to write all the tests for me and I don't need to do that. Well, yes and no. It has no intelligence around, is this code actually doing what your users expect it to do? So you still need to make sure that you're writing the code the way it should work. But what's interesting about this tool is that it can sometimes find conditions that you didn't expect. So I took that Zune bug and I took that C code and converted it into C# because IntelliTest only works with managed code. But I tried to be as faithful as I possibly could and put it into a method, and I pointed IntelliTest at it and I said, run it. And what's interesting is you'll notice that it finds for a condition of 366 days, it gives back this message, path bounds exceeded. And if you dig into it more, what this is really saying is, we call this method passing in 366 and it never returned. We never got an answer back. Okay. That to me would be a sign of what's going on. We would not expect this to not return. Yeah. So testing and this kind of tool, I would hope that they would eventually update it, because I think there's definitely some value in this tool, and maybe get it out of just enterprise, but that's a different story. I also mentioned code reviews, these manual code reviews, and however you do them, they're definitely beneficial, but keep in mind that, again, people are fallible. People will make mistakes. People get angry. People are upset. People don't have the greatest days, and that's just the way we are as human beings, and we'll miss things. Guaranteed we will miss things. Even if, hopefully we're not doing code reviews where it's just the rubber stamping looks good to me. You have people that are taking the time to at least look through it and go, is something catching my eye? But we'll miss stuff. Okay. For example, here's two examples. If I showed you code that had this in the code, you may look at this and go, well, it's fine. Okay. Maybe there's something that you don't like about it, and that's not what I'm trying to get into. But what I'm saying is, if you just saw this code without actually the change to customer service or the get method, that didn't happen in that PR, you may not know that customer service is disposable. And if it's disposable, what should you be doing here? You should be putting it in a using statement or calling dispose manually, but you don't want to do that. The point is, you're not calling dispose. And that could lead, depending upon what this definition of the class does, this could lead to some runtime issues. Okay. So that's one thing. Here's another one. Okay. People love LINQ, and LINQ is good. I'm not going to try to come across that I do not like LINQ. LINQ definitely has some power. I was just watching a presentation from David Fowler, who works at Microsoft, and it was a very interesting presentation on performance. And he talks about how LINQ is, very good abstraction, but on your hot paths, you want to be a little careful because of things like this. People will accidentally use the count extension method from LINQ to get back the count of an enumerable. But if the thing that's actually being returned to you is an array or a list, what you really should be doing is just using the count property or the length property, depending upon, again, what you get back. Now, count is optimized to look for those things and do the best it can to call those properties directly if what you're actually giving it is a list or an array rather than an enumerable. Okay. But when you know the type that you're getting back, you really should be calling that property directly. And that little bit of perf, depending upon where that is happening in your application, can matter. Okay. So these mistakes, these things that we do, we want to minimize them. We want to make sure that what we're producing, we want to learn also that when we make these things that we didn't know about, that there's a tool telling us about these mistakes. And so we don't do them again. Okay. Scott Hanselman has a really good quote that sounds morbid at first, but it's something I try to keep in my mind as I'm writing code, which is you have a finite number of keystrokes in your hands before you die. Okay. Now, again, that can be construed as being a little, we're talking about death here, but the point is I look at it the different way, which is, yes, I have a limited amount of time. So let's make the most of it. Let's make sure that we're focusing on the things that are producing applications that delight our users, whoever they may be, and they're happy with what they're using, and they want to keep using us to producing more things for them. Okay. So there are tools out there like static analysis tools. If you remember way back in the day, there was this thing called FXCOP, which released with .NET 1.0, which was a static analyzer tool. You'd give it an assembly and it would find all these things that were potentially wrong with it based on certain conditions that it was looking for. But the problem with tools like this is it's not that they're not giving you good information. It's that they're happening, in my opinion, too far down the pipe. Okay? If I'm writing code, I'm doing those keystrokes with my fingers, I want to know in near real time that I've possibly done something wrong. I want to know as soon as I can that I've made a mistake. I don't want to wait till this runs on some continuous build server and it comes back with a report, a minute, 5 minutes, 10 minutes, whatever down the line. By that point, my brain has probably shifted to a different thing. And now I might, and I got to go back and try to fix whatever I did wrong. I want to know as soon as I type it. I want to know as soon as I'm writing the code that I've made a mistake, because that minimizes the amount of time it takes to fix it. That minimizes the cost to fix a potential problem. And then it's like the sound of one hand clapping, because it's just you that's going to hear it. It's not the world. It's not the bridge that's going to fall in the river, or the device that doesn't work. Okay. You're the one that sees it, and you can fix it. And it's a much less costly endeavor. Now in .NET, the world has gotten much, much better. I've been using .NET for a long time. And it's cool to see how things have changed, especially from an open source perspective. Again, Stephen Taub in the previous presentation talked about the fact that people can contribute to .NET and do all sorts of features and improvements and performance. And a lot of this, I think, has to also do with Roslyn itself, in that Roslyn in 2014 was open sourced. It's the compiler that you and I use every time we need to compile our C# code. But it's not just C# compiling C#, and it's not just this repositories in the open that you can contribute to. All that's great, but it also provides capabilities and facilities for you, so you can write your own analyzers and code fixes and refactorings. And now in C#9, you can write source generators, and this all plugs in and is integrated within Roslyn, so that you get this near real-time feedback. When you write an analyzer in C#, plugs right into whatever tool you want to use. I'm going to be using Visual Studio, but this is core to .NET and the .NET compiler. So whatever tool you use, or however you're building your code, this applies anywhere. Okay. Now there are a lot of analyzer packages out there, and also, there's still need for some tools out there, because some code analyzers need to do something that's computationally expensive. And so in those cases, you may want to consider doing those on some kind of build server or something like that. But the analyzers I'm going to be talking about are all built on .NET, okay, and are using the compiler API. That first link there are the ones that come from Microsoft. I've got a list here, and these are not, again, selling you on anything. These are just things that I've heard of and people use on their projects, and there's a whole bunch of other ones out there that you can take a look at. But if you're not doing this, I would at least encourage you to think about using these tools. And so in this demo that I'm going to be doing right now, I'm going to show you what happens when you use these analyzers. And to be fair, it's not always a pretty picture, because when you start using these, or you start using packages from multiple packages that have analyzers in there, they may start to overlap and kind of fight with each other. And so you have to start thinking about, which ones do I want to use? What things do I want to enable? What things do I want to turn off? Fortunately, tooling helps here as well. Okay. So I'm going to go through a demo that shows you some code that is purposely going to fail. So if you load this in whatever tool you use and you try to build it, it's going to fail. At least it should. And that's the point, because it has mistakes in it on purpose. Okay. So if I come over here and I go to, let's see, this project. Okay. So I'm going to go through these C# files and show you some of the things that analyzers are picking up. And what's interesting is that if you're in .NET 5, you no longer even have to reference any packages in NuGet to install them into your project. Or what I sometimes have done in the past is use a props file and have that at the root of my solution, and then every project gets that analyzer put into it, or that package put into it. You don't have to do that for that core Roslyn analyzer package for .NET 5. That comes along with the ride. But if you want to use it, what you can do is, if you're in .NET 3.1 or previous, there is this property that you can set in your project file and set it to true. And that will tell people, or that will tell .NET, I'm sorry, that will tell .NET that you want to use that core set of analyzers from .NET. Okay. The actual package is this one, Microsoft.codeanalysis.net analyzers. Yeah. But as you can see, again, all this is commented out because I don't need it. I'm in, as you can see from my target framework, .NET 5. You can also reference packages that have analyzers in them. And again, in the second demo, I'll give you a quick run through of how you can write an analyzer yourself if you are interested. I'm also referencing Sonar Analyzer.C#. This comes from SonarQube. And I know a lot of people are at, they're at companies where they're using SonarQube to analyze their code. And it's a fine product, but again, I want to bring this closer to the metal. I want to bring this closer to my fingertips. So it's telling me when I've got a problem. Okay. So all these packages are typically out in NuGet, and you can just reference them that way. So let's start going through some of this code. Okay. What's also interesting is that Visual Studio and other things will start bringing in their own analyzers, like IDE analyzers, and start to tell you things about your code that you may want to be aware of. For example, you'll see things like private member X is unused. Let me zoom in on this so you can see this. Let me get my mouse over here. So if you can see, there's these little, what they call smudges. People from the Visual Studio team call these smudges. They're these gray dots that are in your code. And if you see these, that's a tip to say, I might want to look at what's going on here. So you can hover over your mouse and it will tell you that this is unused. You may also want to make it read only. Okay. If you see something like this, you'll sometimes see this light bulb pop up. And if that's the case and you're on the line and it also shows up on the left there, I'm a big fan of using the keyboard because I feel like you're faster that way if you're in your IDE of your choice. And for Visual Studio, you want to do Control period because that will bring up code fixes or suggestions on what you want to do in this code to make it better. Okay. Now, for the one where it's saying it's unused, well, if something is unused, I could just get rid of it. Okay. So that's one of those tips where you can start, as you're editing code, it's very common to forget that I don't have a parameter like string of Y here. That's also something that isn't being used, and I could just remove it. Okay. Or I could get rid of this field. Okay. Or this one, if I zoom in on this, it's telling me that this is assigned in the constructor, but it's never used anywhere after that. So you probably can get rid of this. You probably don't need it. Okay. So when you start going down these paths, these can be very helpful. Okay. Now I can see this in the UI, but if I go to the error list down below, I'll also see them show up here. And this is something I would suggest that you do is occasionally, I try to keep my windows not docked that I don't see them, but I will make a point to keep looking at the error list because sometimes these things that show up as suggestions, I'll want to address and get rid of them. Okay. But how do I raise the bar even more? How do I get things that I know are an error? Like if I compile right now and say build, what I should get as an end result is a whole bunch of red here. Okay. And in fact, there is a compiler error here that says this field is also not being used. Okay. Some errors, some analyzers, their severity is set to something like warning. And what I would also suggest in your projects is go into them and set treat warnings as errors to true. Now, some people don't agree with me on this. I've received flack on this before, but I personally will set this, and I found this to be more beneficial than harmful. Yeah, because if you hit whatever keystroke it is, for me it's F6, and I build and it's successful, people will not look and see if there's potential warnings. Okay, they're not going to look at that error list. They're going to commit and go home, or they're just going to stop for the day. If you make a warning as an error, it prevents the build from succeeding, and that makes it, that brings it to the forefront, and that forces you to address it. Okay. Now, in some cases, you might want to say, no, this is something I want to ignore, and I'll talk about that in a moment. But I would highly encourage you to turn this on to true in your projects. Okay. All right. Go to some other ones here. This is actually a warning from the compiler, but it's turning into an error because, again, I have treat warnings as errors. And this is saying that in a seal class, which I would recommend you seal your classes by default unless you intend for them to be used in inheritance. If you have a seal class, having something protected doesn't make sense because that can only be seen from if you're going to derive from it. So since you can't derive for it, you might as well make it something like private. Okay. So this is not something that will probably hurt your performance in any severe way, But in terms of how you're designing your code, it really doesn't make sense to have this as protected. You want to make it private. If you have obsolete types, again, by having treat warnings as errors, this false flag to the obsolete attribute actually ends up showing as an error. And so that gives you the ability to potentially catch things that are going to become obsolete quicker and try to find a way to get around that before it gets completely taken out of your hands. Okay. What about things like var? I'm team var. Okay. Some people don't like using var. Some people like to type out the entire type name. And to be fair, I will say this, to be fair, if I wanted to type out dictionary, well, I don't have that in scope here right now. So, IDEs are getting better in terms of saying, like, if I wanted to say string here, well, then I could just write, hit the tab and have string there, and that's all good. But, okay, I just got distracted because I said something about can't post comments in the chat. So, we'll get to that later. But you can put the type name there. I personally like using var. Now, you'll notice that having int here is actually making it an error. And it's saying use var instead of explicit type. Why this is showing up as an error is because of editor config. So if you don't have an editor config in your solutions, I would highly recommend making one of these. There are tools that will generate one for you based on the code that you currently have and inferring your style. Okay, but they're also being used for a lot of things now, like analyzers and their settings and their severities. So I'm going to open this editor config file up as a text editor first, because this changed recently in Visual Studio. So I'm going to bring it up as a text editor. And you can see in here, specifically right here, that these var styles are saying, I want to use var. And I also want this to be an error if somebody's going to put in the type name. Okay. Now, you may disagree with this. You may want it to be completely different and make them all false, and that's fine. But what I like about editor config is that it enforces these styles, these conventions, so that everybody does it the same way. I like using tabs. People like spaces. I personally really don't care as long as people are consistent, and that's what really matters. Okay. So you can use the editor config to set some of these things. Now, if I double click on this, you're going to see that there is this whole new view UI on top of an editor config that starts going through like formatting things you want to do, like tabs and new lines and stuff like that. Coding styles, like how you want to do your coding style with like placing using directives, and also analyzers. Any analyzers that have been brought in, they'll all be brought in here. And then you can determine if you want to set their severities or not. Okay. I don't really go this route because, as I'm going to show you in a moment, I think there's a better way through the tools to be able to say, if I'm going to bring in a new package and I find a rule to really not jive with what I'm doing, I can disable it in different ways. Okay. Over here to, for example, this one. These are rules are being tripped from Sonar, that Sonar Analyzer package. This one about methods being empty, I don't like. This would be really noisy to me. In fact, I don't even want it to be a warning, because there are legitimate cases where you need to no-op a method that's from an interface that you just don't need it to do anything. Okay. So I would personally not want to have that show up. So what I can do here is I can say, do the control period thing. And I can either accept their code fixes, which I don't want to do, but what I can do is get some suppressing configuration options. So what these suppress options are doing are saying, I could either put these pragma statements in my code, and that will prevent it from yelling at me. I could put them in a suppression file, and then there's an attribute put at the assembly level to say, don't warn me about this anymore. I could put that in source, or what I could do is configure it so that it's just silent or none or a suggestion. And if you look at that diff there, what that's going to do is put that in your editor config file. Okay. So that's the way, that's the syntax you need to do to say, I want this specific rule, this specific ID to be silent. And then I would never see that in my code ever again. Okay. So that's the way I approach analyzers with rules. If there are some that are noisy and I don't like, I'll just turn them off and configure them this way. Okay. All right. Now, the disposable object thing I told you about before, there's been a code analysis rule around for quite a while. But what I found out yesterday is it's actually been disabled because of performance concerns. Okay, so I thought this code here would actually trip and give me an error, and it doesn't, because apparently, again, it's been disabled. Hopefully they enable it again. There is another package out there in that list that I had in my PowerPoint presentation where they also have analyzers that look for disposable objects that haven't been disposed. So you can take a look at that one and maybe use that in the interim. Okay, so hopefully this, because I was hoping to show you this, when I've done this demo before, this works, and it didn't. At least I figured out why. Okay, the other one though about link count, that one definitely shows up. But this also is where you sometimes get conflicts between different analyzer packages, and some of them are trying to do the things that are in that core set of analyzers from .NET. You'll see here that count is actually, there's a problem here in that CA 1829 will fire, but its suggestion is it's just a severity of suggestion. Sonar's rule here will actually cause it to be read and an error. But what's funny is that if I do control period, this code fix actually comes from the stuff from .NET to change it to just being the count property. Okay, but at least I've got some way to see, yes, I've got an issue. So I would recommend, again, using the analyzers, turning things from warnings to errors, and please take a look at your errorless file. Even with the informational ones here, they can be very helpful to just look at and go, maybe I should take a look at these. And then if you actually find them to be very important, you can configure them so that their severity level will be different, and you might want to change them to being an error, and then you would have the compilation process start. Okay. All right. So that's a little bit of a tour on analyzers and how to use them. Oh, I forgot. Before I do that, let me come into here, because not only are there packages for analyzers that look at things that are kind of generic and core to .NET itself, there are analyzer packages created by people that write packages themselves for things like testing frameworks, like NUnit. NUnit has an analyzer package to find things to tell you about when you're writing your code before it ever gets to compilation. For example, in this test project here, you'll notice that I'm referencing NUnit and also NUnit analyzers. And if I come into this project here and I look at these tests here, where I'm using test case, which is basically just parameterized unit testing, if I change this true to a 2, you'll notice that I actually get an error here, and that's saying that this is supposed to be, let me move over here a little bit, that this is supposed to be a Boolean, and I'm passing in an integer, okay? Or if I took this off completely, then I'm gonna get an error that's telling me that I was expecting 3 parameters, and I only got 2, okay? Or 3 arguments, I was expecting 3 arguments, but only got 2. This is extremely powerful because systems like this, or packages that are specific to a domain, they can have their own analyzers set up so that they'll work and check for things that you may be doing wrong and tell you about them before I would try to run this test and get some kind of like cast exception when I run them. Okay. So you can bring in all these analyzer packages and they work really, really well to find bugs. How can you do something though, where instead of you using these, you actually want to write them yourselves? Think about if you've ever had like a guidebook or a whole set of rules that developers should or should not do these things in their code. Well, formatting and styling conventions and all those things, again, I highly recommend that you use editor config and use that to enforce that in your projects as much as possible. But what about rules like maybe you want something to say, we always want, if you implement this one interface, you should always implement this interface as well. That actually came up at a client I was at one time. Okay, so rather than trying to have somebody remember that every time they're doing a code review, write an analyzer yourself that will look for that condition. Okay, and then that just becomes an automated thing. So writing an analyzer isn't easy. It can be a little complicated, but I at least want to go through the mechanics so that you can kind of see how this works. Okay. And the analyzer that I'm going to show you with the code fix is looking for if you ever call new GUID by calling the no argument constructor to GUID, because what that actually does, it gives you back an empty GUID. And that's probably 99 point how many nines after that, not what you wanted. What you really want to do is probably called gwid.newgwid. Okay. Maybe you wanted an empty GWID, and then you want to use GWID empty or default of GWID. Yeah. So I wrote an analyzer to look for when you do this and flag it, and then a code fix to give you options in terms of how to fix it. So there is a thing that you can install in Visual Studio called the .NET Compiler Platform SDK. So you have to go into the installer and look for that, install it. You want to do that if you want to write analyzers, because that gives you a couple tools in Visual Studio that will help, like the syntax visualizer, which I won't show, but that's something to just keep in mind. But it'll also give you some templates that will make it easier to start out writing analyzers and code fixes. So you'll get a template to create a whole new project using an analyzer and code fix, and it generates a whole bunch of projects and code for you. So the first time you do that, I would highly suggest just doing that and looking at the code that's generated and see what they do and running them, because it's a trivial example, but it walks through some of the stuff rather well. Once you do these more and more, I just write the projects by hand myself. I just find that easier to do that. So this project, or most of this, the thing you really want to keep in mind is you want to target .NET Standard 2.0, and then you want these, at least the first two, if not the third, those packages referenced from NuGet, because then that gives you all the things you need in your analyzers and code fixes. Okay. If you want to write this analyzer to look for when I call NuGWID, you want to mark your class with this attribute and then inherit from this base class. Okay. And then you got to implement this supported diagnostics property, but the real thing we want to focus on is initialize, because that's where you're going to say to the compilation infrastructure, tell me when certain things happen in code. Okay. And that's from the context here. If I do context dot register, there are a whole bunch of register actions that you can do. And it all depends on what you're looking for, what condition you're looking for in code. Do I want to see if a certain symbol occurs within the compiler, if a certain tree or a certain node has been written in code? Okay. So depending upon what you're doing, you may want to use a different registration method. In this case, I'm looking for an object creation operation, okay, where you're going to call some constructor. And when that happens, I want you to call this method and tell me where that operation is, because then I'm going to analyze it and look at it and say, is it the thing I'm looking for? Okay. So in this case, I have this context invocation, and that's just the part in code where it's telling me somebody's actually doing a new something on a constructor. I don't know where it's coming from yet. I need to compare it to the GWID's no argument constructor. That's what this code does here. It gets the GWID as if I hover over this, it gets the GWID type as a named type symbol. This again is from the semantic model in the compiler API. So if you think of syntax trees in your code that represent all the things that you actually see in the code here, that's great information, but I want to work at a little bit of a higher level. So you can think of the semantic model as kind of analogous to reflection. It is not reflection, but it gives you more semantic information about the code that's in play, and it's a little bit easier to work with and reason about. For example, when I get that GWID named type symbol, I can find all the instance constructors on it, and then I just want to find that one constructor that has no parameters. Okay. And then I'll use this type to compare those two symbols, and are they the exact same thing? Because if they are, that means you have a problem, and I'm going to report that diagnostic to you. That's what shows up in your error list. Okay. So that's the first half of the equation. What about the code fixes themselves? Now, sometimes you can't build a code fix because of whatever you're finding. You just can't fix it for the user. But in this case, I can. I'm actually doing 3 code fixes. I'll just go through one of them real quick. So to build a code fix, you inherit from this class, and you put these attributes on the class itself. Okay. And then the heart of it is in this method you override, register code fixes async. What I'm going to do is take that node that I passed in here, the location of where that syntax is in code from the diagnostic. I'm going to pull that out here, and then I want to replace that in the tree with something new. Trees are immutable in the compiler API. So if you want to change something, you actually get a new tree back. And that's actually good, because if you saw that diff view that I had in Visual Studio, if I was able to just change the tree on the user without them agreeing to it, that would be pretty bad. Immutability has a lot of good characteristics to them. It also has this nice benefit that I don't actually change the tree on the user. So what I'm going to do is create a new tree with the suggestion. So for example, if I go into the GUID, new GUID code fix, what you'll see here is I'm using the syntax factory class from the compiler API, and I'm going to create a new invocation expression where what I'm going to be calling is essentially GUID.newGUID. That's what this code does right here. It generates a syntax node that basically says I want to call GUID.newGUID. Okay. So I get a new node, and what I'm going to do then is go to the root and say, take that original new GUID and replace it with GUID.newGUID. Okay. And then I register that code fix to the context. Now, one other thing, when you create a analyzer and code fix from the project template in Visual Studio, it will also create an extensibility project. And that's one thing I try to copy here, along with writing unit tests, because you should do that. And you can look at the repo and see how I wrote those tests for the analyzer and code fix. This extensibility project allows me to launch a new version of Visual Studio with those analyzers installed just there in that instance of Visual Studio. And then what I can do is have some scenarios set up like I do here, where I can see that this should be an error and this should not be an error. Okay. So when I launch that extensibility project, which I've already done for time purposes, just so I already got it loaded, you can see here that up here, you can see I got Roslyn up there. That's the Roslyn Hive. That's what they call this. But you can see that my analyzer, if I go to the error list down here, that is actually showing up as an error now. Awesome. That's really cool. And then if I click on this and I get the light bulb showing up, I can do control period, and you see my 3 code fixes are available. And if I pick that GUID.newGUID one, fixes my code, and I no longer have any errors. So you can write your own analyzers, you can write your own code fixes, and use those to handle scenarios that you have specific to your own application, or to anything in .NET if you want to do that as well. That's completely up to you.
Hi, Jason. Sorry to interrupt. Maybe if you could just wrap.
Yep, I'm right at the end. Yep. So that's my call to action slide. So it may seem like a mountain to climb. Not only just putting analyzers in your project, because it might start flagging things that you didn't know about and you have to spend time fixing those, or are those even problems you want that you think are errors? But if you want to create your own analyzers and code fixes, that can be an issue too. I mean, in terms of trying to learn the compiler API and all the things that it entails. It's not impossible, but it does take a little bit of time if you're not used to how the compiler API works. But I highly encourage you to do that, because the view at the top of the mountain is awesome. You can see so much more, I think, when you make that investment. You get a whole bunch of tools now that you can use to write analyzers, code fixes, refactorings, source generators, build tools yourself that can analyze code in all sorts of different ways. Okay? So powerful tools here, and I highly encourage you to take a look at them. So I am done. Thank you all for attending, and we can jump to any questions if people have them.
Hey, Jason, I think we've run over time, so I don't think we can get to any questions right now. So
okay.
I just want to wrap up and say thanks a lot for coming on, and I had a few things to talk to you about, but since we're over, the one thing I do want to say is I think we're brothers, because you literally talk about the exact same things I talk about, that I try to drill into developers' heads, and most of the time I feel I'm the only one doing it. And so I appreciate you, saying the same things I do, because at least there's two of us now that are saying these things and trying to bring up that these things are really important to think about. And Visual Studio has come a long way to help us with this, and it's got a longer way to go. But there's a lot of great things coming in Visual Studio, and I'm glad you're keeping at this code quality stuff, as much as I am, and I really appreciate it.
Yeah, well, thank you. Appreciate it.
Thanks, and I hope you come on my show in the future. Let me know if you want to be on the show.
All right, we'll see if we can make that happen.
Yeah. I know Saturdays are tough for family people. Well, I have a family, but my kids are grown, so they don't want to talk to me anymore. So yeah, thanks a lot, Jason. I hope to see you on the next conference too.
All right, have a good day.
Thanks. That was great. I mean, Jason talked about so many awesome things. I wish I could talk some more about. I will be talking a little bit about things in my keynote. But anyway, the next giveaway we're going to do is the big Stratus Bucks giveaway of 300 Stratus Bucks. I think, yep, Stratus Bucks. And we picked the winner because it's the top commenter in the chat. And the top commenter is John Mueller. So congratulations, John. You won 300 Stratus Bucks. Make sure you get in touch with Simon. We're having some StreamYard issues, so I'm not sure what Simon can do and cannot do. Talk about code quality. StreamYard is barfing out because I guess we're going long. So congratulations, John. And we'll be giving away the lots of stuff right before my keynote. And the other thing I want to say, because I know the keynote is right after Woody's talk, is this conference is going to go over 8 hours, and I think it's Facebook that has a hard timeout at 8 hours. And so if you're watching the conference on Facebook, it's going to stop at 8 hours. And so if you want to keep watching the conference all the way to the end, make sure you switch over to YouTube, and you can watch it all the way to the end. So I wanted to make sure I said that. So our next speaker is one of my longtime friends, used to help me run the user group here in San Diego. What he's doing, he's going to be talking about mob programming and the power of flow.
All right. I guess we're here.
StreamYard's farting out. I guess StreamYard can't handle the long conferences.
I'll try and make it a little bit shorter. Can you hear me okay? Everything's fine?
Yeah, I can hear you good, man. Are you in
I'm
San
go ahead
Diego?
and
Well, I
I'll
think
share
you're
my
home,
screen.
right?
Yeah, yes, I'm home in San Diego.
Yeah, so it's great to see you again, Woody. We need to talk more. You need to come.
Yeah.
You need to come to one of my Sushi Wednesdays.
Absolutely.
Yeah. All right. Well, I know we're over time, so I'm going to give it to you.
Thank you, sir. Well, David just said that we've known each other for a long time. I think it's been about 25 years. I'm not sure exactly. My name's Woody Zool, and I'm going to share with you the idea of mob programming, and I want to talk about flow. How does this relate to quality? And that is actually one of the big things that we notice when we first start working this way. And that is that, I should check with you. Is everything working okay here? Somebody who's running things, I just want to verify.
Looks good. Screen share looks good.
All right, thank you. I'll get to that part later, but this has working well together improves a lot of things. So this is part of what I'm trying to share today. So let's see where we can go with this. Get up here where I can click on my slides. I got a lot to cover, but I think I should be able to get through it without rushing too much. I start almost every talk I ever give, making sure I remind myself and make it clear to you that I can't tell you what to do or whether or not you should do something. What I'm here to do is to share what we did and to share why we did it. And I hope that gives you some hope that you can make improvements in your own environment. So that's essentially what this slide's about. I'm going to give a really quick introduction to mob programming. Mob programming is where 5, 6, 7, even more people sit at a single computer and work together on creating software. And this can be thought of like pair programming, but with just a lot more people. It was always interesting to me to work on teams, I'm putting that in quotes, where we actually didn't do anything at all like a team. I never really quite understood why we call ourselves a team, like a database team or a front-end team or whatever, and yet we never really did anything as a team. So let's see where this takes us today. Mob programming is all the brilliant minds working together on the same thing at the same time and in the same space. Now that's, to me, what Agile is. They recognize that if we're going to collaborate, or maybe let me say that slightly differently, prior to something like Agile coming along, a lot of software was done with individuals doing their work in different phases. And those phases made it hard for us to work on the same thing at the same time. We clearly can't be collaborating if we're not working on the same thing. But we can be collaborating if we're working on the same thing at different times, but working at the same time enhances our ability or capability to collaborate. And if we're in the same space, nowadays that can be virtual, of course, working remotely, or it can be in the same building in front of the same computer. This is what mob programming adds to it. We're going to be at the same computer. Now, a lot of people ask me about this. Does it mean there's just one computer? And I'd like to say not necessarily, but all the work we're doing is going through a single computer, and we're looking at some large monitors. I'll explain a little bit about it. This talk is more about what I see as a very important concept as to why this works, and that has to do with flow. We'll cover all that. Essentially, it's gathering together all the brilliant minds at the same time with the skills and knowledge needed to accomplish this work. We have different points of view, different perspectives, so to speak. We have different capabilities. We're at different levels in our careers. We're at different specialties that we have, but it kind of looks like this. In this picture, there's a tester. Matter of fact, I'll kind of zero in here. There's a tester, a product owner who happened to also be a developer, but from a different team because we were writing some software for their team. I was the manager of the team, but also a developer, another developer, a database expert, another developer, and another developer. These developers have a wide range of skills, but we have everybody we need so that we don't need to go off the team to get an answer to a question that's blocking us. It's not 5 people watching one person coding, but to make this work, we have to have some kind of protocol, basically to act as a single brain, even though we have 5 or 6 or 7 brains working together. We use a guideline that we learned a long time ago. Each of the navigators is there to contribute to the ideas that we're going to try. And the person on the keyboard we call the driver, they're going to actually code that in or key it in. It doesn't matter whether they can write code or not, because someone on the navigation team will be able to guide them if they need help with that part. Not everybody's forced to take the keyboard. That's a rule that we followed, so to speak. We really didn't have any rules. This is really the closest thing to a rule that we had. For an idea to go from someone's brain into the computer, it has to go through someone else's hands. Now, I learned to program in the early 80s. And in those days, you could buy a little computer, and the little computer came with a keyboard attached to it. And that's how I learned to program. The system is set up so one person is coding. I'm not sure that was the best way to do things, but somewhere about 15 years into it, I was introduced to pair programming. And mob programming is just pair programming, but with a few more people. It seems crazy. I'm going to quickly show you some pictures just to show that there are people doing this all over the place. Here is the original place where we originated the idea in San Marcos, California. They grew to have 6, 7, 8 teams. Right now, they're all working remotely, and I believe they're going to continue working remotely. Matter of fact, I think they're hiring right now. Only people are in the Pacific time zone, but if you're interested, get in touch with me. I'll get you connect with them. I no longer work there, but that's where we originated the idea. Here's folks from all over the world. I like to point out that people sometimes ask me, how does everybody stay engaged? How do you keep them interested? Well, I've never had a problem with that. It seems like we're moving fast. Everybody's there to contribute. They stay engaged. It's not exhausting if you do it right, if there is a right, but it's not that exhausting. It's really, it can be stress-free and relaxing, actually. But let's go on here. Here's some more groups in Stockholm, London, a couple teams at a place in San Diego, some folks in South Africa. I love this picture up here from 1960. That's Admiral Grace Hopper. She was an important computer pioneer. I don't think they're really doing mob programming, but the picture looked to me like they were. The only advice I'd give them is get some large monitors, because that computer doesn't even look like it has any monitor. They had to read things off of fanfold paper. Some of you might remember those days. This is a group in Sweden, at the public television in Sweden, and I love this group. They took and shared these pictures in an article they wrote. They really have a fantastic arrangement, although I'm pretty sure they're all working remotely right now. But I like this idea. There's every team member of all the skills are there in this work area, and they work together all day long, every day. Well, it can be done remotely, so there's a picture of a team working remotely. They started doing this way before the work from home of the past year and a half. But yeah, it can be done remotely. And of course, this is not programming, but this is NASA mission control. And I like to think of it this way. This is the same concept. All the brilliant minds working together at the same time on the same thing. And most of them in the same place or same space, although some of them are in outer space. But I'd like to cover one or two more things. Why would we work this way? I usually do this as an exercise. And whoever's in my workshops, they can come up with all the ideas of why would we work this way with 5 people at one computer. Lots of knowledge sharing, continuous code and design review, a lot of perspectives and different viewpoints on the work, rapid feedback. We're getting really quick feedback, allows us to deploy things daily, multiple times a day. We're focusing on the right things, and it enhances the flow of the work and eliminates queue and reduces inventory. I will talk about queues and inventory in a little bit. We were ending up with better solutions of much higher quality, and it was more fun, less stressful, more engaging. These are some of the benefits. But there's another way to answer this question. Why would we work this way? Because the team decided to work this way. It was a decision they can make for themselves, so it was up to them to decide how they wanted to work. I don't think we'd have ever been able to do mob programming if we didn't have that arrangement, where it was up to the team to figure out the model of work they wanted to follow. And it was kind of an accident. That's for another talk. We stumbled upon this idea of working all together because we were practicing code techniques and about clean code and making improvements. We were studying and practicing those things together. And we were building a good team of people who were willing to work with each other and were good at working with each other. Collaborating well is necessary if we're going to work this way. So that was a really rapid introduction. But every time I give an introduction, going back to 2012, when I first talked about this, less than a year after we had started doing it, I gave a talk at a conference, and the first question I think that I got was this: how can you be productive with 5 people at one computer? And at that time, I just said, I don't know, but does that really matter? I don't know how this works. All I know is that it does work. We were paying a lot of attention, and this is what we noticed. When we worked separately, imagine we're working in separate cubicles or maybe in separate rooms, and we added up our daily work together, we would get a certain amount done. Now, this is actually 2 days of work, as it would have been done the year before we started working this way. Once we started working this way, we were getting a lot more done. Now, I can't give you exact numbers, and this isn't proof that this is better. But for us, we could see a lot more was getting done, but it wasn't just a lot more stuff. It was important stuff. It was the more meaningful stuff. It was better done. The customers, which were mostly internal, but external as well, seemed to like what we were providing for them quite a bit better than before. It was also of much higher quality, of the kind of quality we would think of the ILIDs that sometimes we have, but that goes for both of these. You know, we were almost bug-free. For the 3.5 years that I worked at Hunter Industries, where we originated this, 3.5 years I worked there after we started working with the mob programming. We only had 3 bugs get reported into our bug tracking system. I was just talking with them yesterday there, just by chance, and we asked about that, and they said they no longer maintain any kind of a database of bugs. As soon as a bug is reported, they simply fix it, and on average, they go a month or 2 or longer, 3 months, without getting any bug from any of the projects that they are developing. So it was much higher quality, and you can imagine some of the reasons why, but a lot of it just had to do with having all the brains together to do the work. Nothing slipped through We had a very tightly woven, well-working safety net, so to speak. Let's go on here. At first we thought, well, this is definitely have to do something with systems. The thing with systems is, I like this saying, it's not about the sum of the behavior of the parts. It's about the product of their interactions. And the way that Russell Acuff used to talk about systems, he would say, like in an automobile, if you've got a fuel injector, an engine, some brakes, a transmission, so on, those things are useless separate. You have to bring them together, and the quality of the car, how useful the car is, it's going to depend on how well do these things integrate. How well do they work together? And that's one way of looking at a system, and I think that helps us get a quick focus on this. But we knew it wasn't just that we were a system and that we were really taking advantage of these interactions. And so we started looking into this. At first, I didn't like the question. How can we be productive with 5 people at one computer? I didn't like that word productive. Now, this is my father. This picture is of him about 20 years before I met him, because he was 25 years old when I was born. He would say something like this: a good question isn't for answers. It's for finding a better question. And he would often add, when you find the right question, it will answer itself. You'll know you arrived. So I'm going to go through the process that we used in following my father's basic technique of asking questions till you land on the right question. And to take it a step further here, just so you know, he was an engineer. He worked at the phone company in the US here, Pacific Bell, and he was well known for his problem-solving skills. And he helped design switching stations and things like that. So I wanted a better question. And the first step is to just look at the question that was first given to you. And I didn't like that word productive. So let's talk about that. I'm going to share 3 different concepts that are related to productivity: efficiency, productivity, and effectiveness. In a condensed form, efficiency is usually about utilization. Is everybody working as hard as they can? Is our equipment running as fast as it can? And whatever it is, if you're on a factory floor, do we have enough inventory to feed the machines? Things like that. That's just about utilization. Productivity is about actually finishing work, completing something. And effectiveness is about working on the right things and getting those done. When we're effective, we're probably efficient and we're productive, but we add this extra idea. So I'm not interested in productivity. I'm not interested in efficiency. Efficiency can be measured with busy work. Productivity can be measured, even though we're getting the wrong things done. We got 32 things done today. If the wrong things, who cares? But effectiveness is about getting the right things done. So that's why I'm after that. I wanted to change this. Let's just say, how can we be effective with 5 people at one computer instead of productive? Now, that's not the better question. This is the beginning step to getting to a better question. The next thing is, we need to flip this over. This is about the point of view. You have to understand the point of view of the person asking the question. Now, remember, people asking me this question at the end of a talk, they would ask me, well, how can you be productive? And it was usually managers who would ask that question. So I started gathering information from them. And I would ask them, well, what do you think works well? And they would usually say, yeah, I know that working separately, put everybody, they're working on things in parallel, we're getting a lot more done. But I really question this. Matter of fact, sometimes they'll ask me, are there any studies that prove that working as a team is better than working solo and having everybody separated? And I just reverse that question. Is there any studies that prove that everybody working separately is better than working as a team? And they don't have those studies. It would be the same study that they're asking for. They've made a decision that this is better, even though they have no proof that it's better. They just know that it kind of works. It just doesn't work all that well. They often express it this way: well, I want to get 5 things done, not just one thing. Well, I think they're saying I want to get 5 things worked on, because who knows when they're going to get done. This isn't really what happens. They're scrambling quite a bit more, and we're going to see this in a minute. They'll also say it this way: I don't want to pay 5 people to do the work of one person. And again, that's like a misunderstanding of what mob programming is about. All the work that we're doing, even when we divide the team up, could be potentially done with one person if that one person had all the knowledge and skills and capabilities themselves. So it's that they want to get the work done faster. And I think that we trick ourselves into thinking faster gets done when we have everybody working separately on things. It seems obvious that it should be faster, but I'm not sure it really is. So we flipped this over. So this is part of my dad's process. He said, once you understand their point of view, you have to ask the question from your point of view or from the opposite point of view. Now, he would probably, if he was still alive, remind me there are many other points of view. But right now, we're just looking at the two. This is the beginnings of thinking through these things. And I would ask the question this way: how can we be effective if we separate the people who should be working together? And when we separate them, it usually is into separate cubicles, sometimes into separate rooms, sometimes into separate buildings or on different floors. Often it's even on different teams or different departments. Like the database person's works under a boss who leads the database people, or maybe the systems people, or something like that. The testers work for a boss who is in charge of the testers. They're in a different department. The people who do the deployments, they're in a different group as well. These things are not just separate by space. We're separate by who's our boss. We're separate by how we can communicate with each other. I've been to places where it could take a day or two just to get an appointment, because I would have to go to my boss to go to someone else's boss to ask them for time for me to have a meeting with them. Well, this led to a better question. It was in 2 steps, and I really should change my slides to add this in. But this is what happens. When you ask these questions, you start getting a better idea of what question do we really need to ask. And I think that it comes down to this. We need to know, is there a way to compare these things that's reasonable? Now, if you say, well, would compare them by seeing which team gets the most work done? Well, if you have a team that's really proficient at working a solo and another team that's really proficient at working as a team, you might be able to measure some things, but are they working on the same thing? Are they working on the same project, the same aspects and the same artifacts of the same project? Those kind of tests are really expensive to put together, and I'm not sure anybody can really afford to do that kind of testing. But I think there are other ways. And the better question, how do we compare the two, that I like to use is, let's start by asking ourselves, what are the things that destroy effectiveness? Now, I usually do this as an exercise, but since we're not going to do that here, I do have a photo I took of a team that I worked with 6 or 7 years ago. It was just before the workshop. We came in, and one of the first exercises we did was gathered up. And this is a team that was not yet doing mob programming. I'm not sure they even understood what mob programming was at that time. So what are the things that are making it difficult for you to get your work done? What are the things that destroy the effectiveness for you? And they came up with 50 things in just 3 minutes. The one I'm going to point out first here, I'm going to only show a few. But one is needless meetings. Now, I would change that myself to just meetings, because I think almost all the time meetings are a symptom of a bigger problem. They're not so much a problem themselves. It's that we have to have the meetings that we have a problem. And that really is that we don't have a better way to make decisions, keep each other informed, share ideas, things like that. I think there are better ways to do it. But look at some of these other things. There's a grouping here. I should put them all together. Context switching, distractions, multitasking, waiting on a dependency, interacting with others. All these things kind of go together. When we're distracted from our work, a lot of people say, well, when I'm in the zone and somebody comes and interrupts me, it takes me a long time to get back to where I was. And these are some things developers often see are a big problem for them. But look at these other things. Analysis paralysis means we're discussing things more than taking action. We're waiting for someone else to give us an approval. So here's others: waiting on other teams. Unrealistic expectations, unclear expectations. Oh my goodness. I got a story I could share. I won't, but something that I actually worked with Dave McCartan on many years ago, where the requirements were never completed. So they never gave us the requirements. They kept telling us they would have them. They just let us work on whatever we thought we should be until they finally canceled the project. They had funded it, never got it done. We were waiting for expectations. They didn't yet exist. They didn't exist. The requirements didn't really exist. They didn't know what they wanted. Lack of skills, missing requirements, insufficient resources, cumbersome processes, technical debt. Now, if we have these problems in our way of working, we can look at our way of working and decide, does this way of working have more problems than that way of working? And this is what we noticed. When we worked as a team, many of these problems, and I really call them mostly symptoms, just faded away. We were addressing the real problems, even though we didn't set out to address any of these symptoms or the problems that underlie them. This is an interesting thing to me. What was happening is when we worked as a team, we weren't getting the interference, the distractions, the context switching, because we were all staying in the same context. I'm going to talk about one kind of communication problem. I stumbled upon this, I'm sure a lot of people also had, somewhere around 2003, long time ago. I was in a company and we were trying to figure out why we were having so many communication problems. And so we put a little team together and we were researching and finding out what kind of communication problems can we have and what was our biggest problem. And this is the problem that I saw as being the biggest one. And I called it, I named it this myself, the question queue time. There might be some other name for it. That's the amount of time that we must wait to get an answer to a question that's blocking us. That means we're working on something and we can't continue till we get an answer to this question. Oh, they're telling me that we need to move from Facebook to YouTube. If you're in Facebook, it's best wherever you're at to move to YouTube right now. There you go. And if you go to YouTube, why, then you'll get this same presentation, but you'll be in a place where it probably won't get cut off. Alrighty. So let's take this on just a little bit further. Oh, some people tell me they tried to, but it won't go. So I'm not sure how to deal with that. If somebody from the support team wants to break in and help guide us, I'll stop for that whenever you can. Okay, so this thing is really critical, the blocking questions. And I'll give you an example of one. We were working on something once where there were two drop downs on a screen that we needed to create so they could select some stuff. And all the instructions for the first drop down were the same instructions for the second drop down. This is problematic. The reason that this happened was somebody probably copied and pasted. So that is a problem. We didn't know what the second drop down was for, so we had to contact the person who wrote the requirement. We contacted them. We didn't get a chance to have them come and help us for several days. So that is waiting to get an answer. So typically, this waiting is a waste. As a matter of fact, in the lean sense of the word, all waiting is waste. You can't eliminate it all, but we want to eliminate as much as we can. If we use a value stream map, we can draw a chart that shows us how much time we're spending effectively working and how much time we're spending wasting time. And this basically just shows this line at the top is we're working, getting things done, then we're blocked because of a question, then we're working again, then we're blocked. You can see if we compressed out the block time, we could get twice as much done this day. So if we make this hypothetical situation where for every hour we work, what if we got one question? Just to give us a way to compare the queue time and how it affects our day. So if we have zero queue time, it doesn't matter how many questions, if we can answer them as soon as we get them. However, what if we have a 2-minute queue time? What if it's 10 minutes? These both seem minor, but they're interruptions. They cause context switching. They cause us to interrupt other people. But what if it takes an hour? What if it takes a day? Now, when I'm doing this workshop or the workshops I do internally, I often ask them, I want a poll. How long do you need to wait to get a question that's blocking you? On average, give me a range. And they'll usually say it's something like between a couple hours and a couple days. Well, that's a huge amount of waste. You can see, even if you're wasting an hour to get that answer, we're wasting half our time if we're only getting 4 questions a day. And a weird thing happens. As soon as the answer comes and we can start working on our thing again, it'll reveal the next problem that we don't have an answer for. And we need to go back to find somebody who can answer that question. So how do we typically solve for this? Well, you all know we've got this one task we're working on, and then we introduce a second task. This is called inventory. We've introduced inventory so we can stay busy. Our problem isn't being busy. And inventory itself, my definition of it here is it's work started on, but not yet delivering value. Interestingly, inventory itself is waste. Most software projects are full of this kind of work. Not very good. However, it makes us feel like we've made an improvement because now we're staying busy. But what we've done is we've we've solved for a symptom and not for the problem. The symptom is we're not busy because we're waiting, so work on something else. But the problem is we're not getting answers in a timely manner. Solving for a symptom doesn't actually solve any problems. It introduces other problems. And inventory itself is a problem. That introduces all kinds of difficulties, and I will cover that some other day if you want to talk about it. So how did we solve this? We didn't really. It just faded away. It's a problem that we stopped having as soon as we started working as a group, as long as the people we were working with and the questions we had could be answered by them. But as soon as we had to go off our team to get an answer, then we were blocked again. But this really emphasized it for us, and it made us realize we were talking about flow. And some of the product owners, it was actually the product owners, the database people, the deployment people, and the systems people, and then the testers. They were all on different teams than us. And that's where our biggest queues were, or the biggest waiting time. As soon as some of the people on these other teams saw how much this impacted us, we started reducing that queue time. And eventually, all of those people are part of our teams. We no longer have them in different departments. So this is the terminology we would use. When we work together, we were getting this automatic one-piece flow. I'll explain flow in just a few minutes. This is the idea of lean flow, that work flows without interruption. Okay, so this became a very important word. Matter of fact, you can see I've made it so big it fills the whole screen. And that's just to say, hey, I think this is super important. Let's pay attention to it in our work. Now, once we started trying to study flow so we could better explain these concepts to the other people in the company that we were working with, we realized there are many kinds of flow. And the two I'm going to focus on right now, we use the word flow in software development for at least 5 or 6 different things. And the two I want to cover today are psychological flow and lean flow. Psychological flow came along, I think quite a while ago. It could have been in the 70s, 80s. This fellow, Mihai Csikszentmihalyi from Hungary, the reason I can't pronounce his name is because I'm not real familiar with how to say that combination of letters. Luckily, I don't think he's here today. I don't want to offend him. So here's the thing. He defined flow as being the state that you can get into that's highly effective when you're really absorbed or really focused on something. This is powerful. And we all experience, we often think of it as being in the zone in software development. You get this sense of ecstasy and clarity. Now, sometimes it can be very frustrated, but without the distractions of others and other things going on, the sense of time disappears. We start getting this ability to know right where we want to go. It may be just an experiment to get us to the end of where we want to go, but this is the basic idea. Being in the zone is a powerful thing, and we started getting a little bit worried when we worked as a team. Maybe we're destroying this kind of psychological flow. We talked about it on the team, and we decided that we aren't, because we never forced anybody to work with the team. It was up to them. If they wanted to go work alone, they could go work alone. If they saw a problem they wanted to think about alone, they could go think about it, experiment, do whatever they wanted. If they like to go take a walk, because that's where they do their best thinking, that's how it is for me. I'd go out and walk around the building, walk around the campus where all our buildings were, till my ideas got clear. So we didn't feel we were destroying the psychological flow. However, each person's different, and we realize we need to allow each person to find their own way to stay in the flow they want to be in. And this is part of what we think we were doing. However, I wanted a better question than, are we destroying this kind of flow? And this is the question we came up with. Is there a sort of team psychological flow? And what would that be like? Well, it turns out there is, but at first we couldn't find any research on this. So we started doing our own research. We just collected photographs of people in teams. I just went on, online and just searched for teams and grabbed every photo I could. And we could talk about the different aspects of working as a team, like as a musical group. Some of you might know who these kids are. That's Dave Clark 5, right? Anyways, just kidding you. Here's Xerox PARC, a whole different kind of team. Each one of these. This is my favorite because it's just all the skills needed to do this operation. This was a famous operation from 1942, a heart operation on a 12-year-old kid. There's 3 surgeons here. There's 5 or 6 technicians. There's a supervising surgeon. These people are all focused on one thing, and they're all bringing their skills together. We were looking for examples of how people might work as a team. We read a lot of books, we read a lot of articles, and we discussed it quite a bit. And then we started finding some actual research. And this was available at that time. It just took us a while to find it. Research can be hard to find sometimes. When you have collective ambition, common goals, and they're aligned with your personal goals, and you have all the skills you need and you integrate them well, coupled with open communication and the safety of being able to communicate with each other, where we can share our ideas without fear, we start getting some benefits out of this. This mutual commitment, sense of unity, sense of joint progress. We end up building this mutual trust, and we have this holistic focus that allows us to get bigger things done than any one of us could do individually, because we're doing them with this mastermind of 5 or 6 or more brains. We did this actually once with 14 people on something that was so big and important to the company to get done as quickly as possible, that we had to gather 14 people to get all the knowledge into one space and work on this thing till it was done. So we were enabling team flow just by having practiced working well together. We didn't realize this thing like team flow could exist, but we've been practicing collaboration skills for about 6 months before we started mob programming. And we wrote a lot of what I'm sharing with you here today sometime in late 2012 or 2013, because we started working this way in 2011. But after studying these ideas of flow, this really helped us get an idea of why this is working well for us. But there's still this other kind of flow I want to cover, which is flow as in lean manufacturing. So in the lean manufacturing world, this is a very simplified description. Now, I have worked at places where we used lean manufacturing processes, so I'm sort of familiar with this. As a matter of fact, I really enjoy the concept. The idea of flow in manufacturing is we're going to work on something from start to finish until it's done without the interruptions, without the waiting, without the excess inventory. We really want to eliminate all inventory. We want to eliminate all waiting, but we can't do that completely. Okay? Yeah. So, can we get this with software development? Well, I don't think I'd be here today unless I felt that we could, with this particular talk anyways. And this book does a really good job of explaining how flow works for product development. And product development, software development is a type of product development. And I'm only going to cover one little part of it. And that little part of it is the queuing. But this book is well worth getting. At least somebody in your organization should be familiar with these things. The principle of queuing waste really is in alignment. It is in alignment with what I realized with the question queue time. Queues are the root cause of the majority of economic waste in software development. Now, if that is true, we better do something about it. Now, I kind of believe it is true. And as a matter of fact, I think it is everywhere I visit, I see these same kinds of things. I'm going to finish with one little bit, and then we're going to come to a conclusion. Queues create longer cycle time. All the rest of these things, I think, are related to that longer cycle time. Cycle time is essentially how long does it take to go from start to finish on something? And if our cycle time is being increased because we're waiting and we're queuing for stuff, then yeah, we're going to have a lot of other problems. So I can define flow with software development this way. This is the definition I came up with. Each story or each thing we're going to work on flows from idea or concept to delivered working software that people are using as directly as possible, without the queuing and waiting, without the inventory, without the distractions, the interruptions, the context switching, the multitasking. When we eliminate those things, we are truly achieving flow. And this is the way I kind of think of it, although this makes it look linear because it shows things going from one to the other. It's not really that linear. But I'll warn you, if somebody's giving a talk about Agile stuff and they don't put a circle into their talk, it's not really agile. So I put this in here so you know this talk is really about agile stuff, right? So here's the thing. At any point in this, we are learning stuff. The feedback is happening at every step. And I want as many of these steps as possible. Let's try and deliver 2, 3, 4, 10 different things a day from each team if we can. Let's figure out how to do that. And I think mob programming has achieved that for us. Matter of fact, when we achieved flow, we found we were working almost always on the right things, getting the work done. This includes exploring and experimenting discovery and working on a great deal less of the wrong things. They faded away for us. We won't go into details of this because I want to be done, because I want to save time, hopefully, for at least one question. Here's the end result for us, though. We were achieving this lean flow. We were eliminating the queues and the inventory. And this lean flow, coupled with the psychological flows, really were taking us to the result we were getting, but we didn't set out to do that. It just is the end result of what happened. We're optimizing for the flow of the work rather than for the output of the individual. We are not trying to get the most work out of each person. We're trying to get the best of each of us into everything we do. To me, this is massively powerful. So I can believe that I can answer that original question. How can we be effective with 5 people at one computer? It's because of these flows. Remember, originally I thought it was flow versus flow, when we realized maybe we're ruining the psychological flow. But we're getting it. As a matter of fact, we're getting 3 flows: the psychological flow, plus the team psychological flow, plus the lean flow. This was a miracle to us. Now, this isn't a golden or silver bullet, as they would say. This is not the answer to all of our problems, but some bright programmer in one of my talks shouted out, that is flow plus plus. And that's good enough for me. We're getting flow plus plus. So that's the end of the talk. Thank you so very much. I appreciate having this opportunity to share this with you. This ties in very closely to everything I was trying to do over 20 years of working for others, trying to get teamwork back into software development. So I'm happy to try and answer a question if you've got one.
Hey, Woody.
Hey, Dave.
My hair's all poofy today.
Yeah, I don't have hair to make poofy.
I wanted to say, this is my real hair, people. This is not a wig.
Yeah, same here. Yeah, so I always have a bad hair day. You only get them now and then.
Well, when it's summertime, my hair tends to be poofy anyway, and when it's summertime, it gets worse. And I washed it. So right after I washed it, I washed it this morning. It's worse the first day after I wash it.
Yeah.
And I know we're not here to talk about hair tips.
Down to here, down to there, down to where it stops by itself. Okay. Is there a question or anything you want to close up with?
Well, one person said, "Mom programming, is it one person physically typing, others backseat coding?" I don't think backseat coding is.
No.
Yeah.
It's 5 or 6 people guiding a person who is just putting some code in. They're not backseat coding.
Right.
So really what you're asking is, isn't that like too much direction? What we find is we need to learn to share the right idea at the right time and in the right way, and not just shout out our ideas all the time. This is a skill that we need to build. So it's not like someone going, turn left here, and someone else yelling, turn right here. It's not all of it. We need to learn, that we're here to help each other think. And by the database person being there, for example, if we're in the middle of the product owner talking about something, and then the product owner sort of shared something there, the database person might say, I think we're going to need a new table for this.
Mm-hmm.
We might not figure that out till 2 or 3 hours or 2 or 3 days later if we're working alone.
Right.
We're all separate because you can't think of everything up front. But when you're together, it makes it a lot easier to do that.
Yeah, and so everybody who's watching, this is one of the reasons, I wanted to bring Woody on to the conference, is because, because Woody was one of the people I asked to be on the conference, and it's because, there's more to quality than the code itself, right? It's, the process on how you do that is very, very important, right?
Yes.
And I was talking with one of the other speakers about toxic environments. I can see this doesn't create toxic environments because you're all there, you're all working together on one thing. And the one thing that you did in your the session I really liked is to show those pictures of different professions. And when you were showing the picture of that heart surgery of the 12-year-old kid, I was just thinking, oh man, can you imagine if surgeries were done the way we do programming?
Oh yeah, yeah. So what if your manager was rolled in? Yeah, if your manager was rolled in to the operating room and they look up and see there's 7 people and go, I'm not paying 7 people to do one operation. Get rid of everyone except for the surgeon. Well, this kind of clarifies. Yeah, if we did a surgery, let's not get too far into that.
Yeah, I really like how you brought that together with other professions, and I think it really made me think about the software community needs to really think about how other professions do it, right?
So
and not
David,
just the way we do it.
You're a musician. When you're playing in a band, let's say there's 5 people in this band, rock or whatever, and you take every solo and you want to sing everything, nobody's going to want to play with you anymore because everybody else wants a solo too. And so, we share what we're doing. Matter of fact, if we don't let the bass player do what a bass player is there for and let a drummer do what a drummer is there for, we're not going to have a very good band. It's a holistic thing. It all comes together. Now, sometimes a band member couldn't make it to the gig and the rest of the team has to fill in for it. But the team kind of knows how to do that because they've been playing together. They know the gaps they need to fill. This takes skill. And we don't learn these skills. Like you don't say, I want to play in a rock and roll band and then go join a band. The first thing you need to do is learn to play an instrument. And then maybe you need to learn how to play music with other people. And eventually you can play in a band. And that's the same thing here. Every one of us pretty much worked most of our career alone. We sit and program alone in our own space. We need to get the skills to work with someone else if we're going to work with others.
Yeah. And, even when you're talking about music, I personally, when I'm playing with a bunch of guys, writing songs even, or just playing songs, it's so much easier than when I try to do it all by myself at home. Right. Because when I write and record, the songs that I put out and even the song that, starts my weekly show, right. Just doing that 1-minute song was really difficult because, there's me here, there's Jeff up in North County, there was Mark down in East County, and then there was a guy in Germany, and we were all doing it separately, and I had to put it all together, and oh my gosh, so much work just to do a 1-minute song,
Okay. I'm going to tell you a little story about it. Now, I played music for about 10 years, trying to make a living, never made much of a living at it, but I worked with a guy who was a really excellent soundboard guy who recorded a lot of music. And he could listen to anything and tell you whether those people did it together live or whether they recorded it separately and brought it together. It's different. The dynamics of what happens when you're with the other people, you're building on each other. And you don't really get that when you're doing it separately. But this goes with sports. This goes with a lot of other things too. It's not just software development. It's the odd person out or the odd thing out. Because everywhere I went, when I first started working for others, they said, you're on this team, but we never did anything like a team. It was never teamwork. It was just that you happen to be working under this same boss or you had the same basic skill sets.
Yeah. And the one thing I wanted to point out, because I know I said this correctly, but it seems impossible. So, I know you developed this mob programming up in Hunter Industries, right? And now you go all over the world, teaching about it. And did you really say they go months without a bug?
Oh yeah.
Yeah.
Literally 3.5 years. So when I joined the company, they had some projects that were really late. They had 2 projects that were both a year late. Well, what's the appropriate amount of time to be late? 0. Right. And so that's the clue to me. As soon as I hear that at any company, I go, they're working on something they really don't know how to work on yet. So one of the things we worked on originally was how do we identify what bad code looks like and what good code looks like, so we can start making the good code and not making the bad code. And
Yeah.
we were building those skills. We were also building skills of breaking things down into smaller bits and so on. So we were building a lot of skills besides learning to work with each other. But when we have a tester there, the product owner there, a miscommunication gets revealed immediately. As soon as we say, okay, put a drop down there, and you put it there, and you go, oh, that's not what I meant. Well, that's a drop down. So, well, I meant it's like the three little things, and they're always showing, and then you click the one you want. Oh, well, that's a list or a radio button, or that's not the drop down. They drop down. Then the communication happens right then and there.
Yeah.
Because you're doing it with them. Now it seems like, well, this is going to be wasteful, but the exact opposite is what we found. Matter of fact, on that long list of things that stop effectiveness, bugs is a prominent thing there. A bug destroys effectiveness. As soon as you have to work on a bug, you're no longer working on the real work. You could say, well, the bugs are real work. No, the bugs should never have been there in the first place.
Bugs don't make money. Features do.
Right. And if we can't get to 0 bugs, which is almost impossible to do, let's get as close to that as possible. And there's ways to do that. And there's a lot of people doing this nowadays.
Yeah. So, the one question I wanted to ask you, because I know some people have left Hunter, and including you, but when you were showing one of the last pictures of you guys of the team at Hunter, I was going, if I worked there, I don't think I could ever leave, because how can you go from mob programming back to, something else after, experiencing something as productive as this obviously is? How can you go backwards? Right.
So this is a good thing that you brought up. When I had 2 goals when I was asked to go to work there. I don't know if you remember in the earlier days, if you're at the user group and you say, hey, where do you work? And say, I work over here. If somebody were to say, I work here at Hunter, somebody's going to say, oh, I'm sorry. So I wanted to see if we can make it where you're happy to be working here. When you're coming in the morning, you're going, I don't really want to go to work, but I'm so glad I'm working here. And my second goal was, I want to make it so when we have a job opening, everybody on the team scrambles to go tell their friends, you can come to work here. There's an opening, come here. If we could accomplish those 2 things, I think we would accomplish, that would be the best I could accomplish in my life. And I think we did.
Yeah.
We didn't set out to do mob programming. What we really did, in my opinion, is we set out to make an environment where great things can happen. This last slide that I usually share is just exactly about that. I don't know if we're still in this slide share anymore, but it says this: the object isn't to make art, it's to be in that wonderful state which makes art inevitable. Exactly. I learned that when I was in my 20s, and it really means you can get all the skills you want, you can get all the knowledge you want, you can get all the tools you want, everything, and you're still not going to have the great things you want until you have an environment where it's easy to do great things.
Right.
Let's find a way to do that. And Dave, I know we probably are out of time here, but I would say to every person that's listening today, if we as a group work towards improving our environments where we work, it'll make such a big difference.
And you retain people, right?
What's that?
And you retain people. They don't leave if you make an environment like this.
So this is an interesting thing. Of our original group, one of them had to leave for medical reasons. Another one retired. Another one wanted to work closer to home. They were commuting a long, long ways. And I had to retire, so to speak, to go teach this because I was getting so many requests to teach this stuff. And yet that team was together for over 4 years.
Yeah.
That's a long time in software development terms.
It is.
And they're still doing this. And there are people there that have been there since, over 10 years now, since we started doing this.
Right.
So yeah, you retain people. Make it easy for people to want to stay. It's not just about pay. It's not just about...
No, it's not about pay. No. And there's 2 things I want to end with you really quick because I know we're over time. You were talking about, it might take days to get things decided. The last contract I just ended, it would take weeks, if not months, right? And so basically whatever we're working on was pretty much dead, And even the last Lambda project I was working on with, through AWS, We could even, when I left, I was really upset about this. I couldn't even test it, because it took so long to get anything done there. And I estimate projects there take, 5+ times longer than normal teams, right?
That's right.
And if you live in America, everybody teenager on up has heard of this company, and is why I will never give them another penny of my money ever again. Because the amount of waste is just mind-boggling at this place. That's
a sorry thing.
Yeah, it's and silos are bad, and that's the one thing I'm sure we've all seen. Those of us have been around a while, that at least this is what I've seen, is the larger the company, the bigger the silos, right?
Yeah.
Yeah. And
there's two sides to a silo, Dave. There's the silo of knowledge that also is a silo of ignorance.
Right.
They're knowledgeable about their little area, but how it affects other people, they're clueless because they don't ever get to really see that. So that's I think these silos is, let's eliminate them best we can.
Yeah. So thanks a lot for being on the conference. I'm really happy you were the last real session, because mine's just a keynote, and whoever listens to those, And
Dave, you're the best.
I'm really glad we got to hang out a little bit. Yeah. I learned something every time I see you, and I really appreciate you, being my friend, and I really appreciate knowing you for so long, and I can't wait to know you until I leave this earth.
Yeah, let's work on that. Let's keep it that way.
Yeah.
Let's never leave this earth.
Yeah,
see you later.
Exactly.
Thank you much.
Well, that was great. I really like Woody, and he's so smart, much smarter than I am. And so I always learn something from Woody, and he's such one of the nicest people I've ever known in this period, really. I was going to say in this career, but I would say period. So let's get to some last slides really quick, because I know my keynote was supposed to start 3 minutes ago. I hope you're all here still watching. I got a lot to say in my keynote. And of course, it kind of wraps up what everybody else is saying today. But I actually did this based on an article that I wrote a while ago. But anyway, so thanks so much to Mahesh and Simon, of course, especially Simon, because he's stayed up all night and into the wee hours of the morning to help put on this conference. So everybody, please make a comment or say thank you to Mahesh and Simon. And I know Simon will like it, because he's going to go to bed as soon as I let him go. And what time is it there, Simon? He'll come on. So anyway, thanks. I want to really thank C# Corner, Mahesh, and Simon for allowing this conference to put on. And hopefully you all liked it, so we can do it again next year, hopefully. So I want to bring up really quick the Hello World Cookbook. I'm putting together this book of food recipes from geeks just like you and me, and all 100% of the proceeds will go to the Voice of SLUM in India. So please go to Hello World Cookbook. I've been up so long, I can't talk anymore. Please go to the URL there and submit your recipe so I can get this book off the ground. I really appreciate it, but most of all, the kids in the slums in India will appreciate it. Oh, it's 3:45 a.m. in India. Man, I'm so glad you're young, Simon. All right. I also want to plug my show every Saturday. Well, most Saturdays at 10 a.m. Pacific Standard Time, where I have experts in this world, including Woody's been on my show, and come on and we talk about whatever they're passionate about, and it's every episode to me is turned out really well. And I end each show now with something called New Code Rules, where I talk about something that I think we need to talk about and come up with solutions. And so I hope you watch the show. And if you do watch the show, everybody gets a free copy of Code Rush from DevExpress. And I really appreciate that from DevExpress. Also, if you haven't donated money to help the kids for COVID-19 in India, please go to this URL and please donate. We're going to give all that money to help the COVID-19 pandemic in India especially the kids. Their pandemic is going really bad right now, and they really need our support, and they really need our vaccine. So I hope you get some vaccines pretty soon, but I hear it's not going to be another month or so. So please stay safe in India. I don't want to lose any more of my followers and friends, and stay home. Don't go out. It's the worst thing you can do right now. I know you're allowed to do that, but don't do it. Stay home, stay safe, and get the vaccine as soon as you can. It's the last giveaway time. All right, this is our last giveaway. I hope everybody's around, and I got my guitar so I can do some music while we pick the winner. So let's give away my book first. So we're going to give away a copy to anybody, to whoever wins a copy of my book and some other cool swag, and I'll autograph it for you. And we're going to pick the winner from the comments. And all right, you ready, Simon? Trisha, you want a copy of my book, so make sure you get in contact with Simon, because I need your mailing address, and I'm not sure where you live, but we'll get it to you. I'll get it to you next week. All right. So thanks, Patricia. I'm glad you were watching, and I hope you enjoy the book. Where's my guitar pick? Because we're going to give away the last. License for Grape City product worth between $500 and $900. So let's do that. Oh, wrong place. It's the only song that can come up. All right. I don't know how to pronounce your name, but you won the license from Grape City. So make sure you and Simon get in contact, because I need your email address, and so I can send that to Grape City, and you can pick whatever they make. Isn't that awesome? Yeah. If you like what you picked, let me know. I want to hear all of the winners that won software. Let me know how you like it. It'll be fun to hear from you. All right. So I think that's pretty much it, Simon, unless you tell me something else. Well, let me look at the private chat. Oh, yeah. So I think we've given away everything. So next is my keynote speech. Are you guys ready? Here you go. All right. So, I kind of wanted to wrap up the conference with something that I want to make sure everybody knows. And to me, these are the 7. There's lots of important things to make a successful project, but these are 7 things that, I think are important for every single project. I don't care what kind of project it is, whether it's a big internal application, small internal application, a public application. All these things need to happen. They might change a little bit, but basically you need all these things. And so that's what I wanted to talk about for my keynote. And it just so happens that these things, most everything in my talk has been talked about already at the conference, which is great. I'm glad I picked this subject. So those of you who don't know me, I'm David McCarter. I'm a Microsoft C# Corner MVP, award-winning developer, architect, consultant, blah, blah, blah. I love playing music, as you all know, if you've been following me. There's my email address, Twitter handle, and LinkedIn. And so please contact me. Let me know not only if you need some help, or you like the conference, or your company needs me, because I'm looking for a new contract or full-time gig right now. So please contact me. I don't get enough contact. This is what I'm trying to say. All right. So after I got most of this keynote done, I figured that, everything I'm saying here, I hope you developers out there know this. So I decided to put the last line in there going, this keynote is really for management, because I don't know about, other developers out there, but management is a big roadblock to me in most cases to get things done correctly and with quality and with performance, really, but mostly the quality. Because management, I've said this until I'm blue in the face, management really doesn't care about quality. All they care about is shipping features because that's what makes money. Who cares about quality? We do, because we're the ones who are going to have to deal with it. So do you want to deal with bugs all the time, or do you want to deal with no bugs and do features? I think the answer is pretty obvious, right? So, make sure you download this keynote and send it to all of your managers and project managers because they need this. Because I don't know how to get it through their heads. So this is what the keynote's all about. But if you don't know any of these things, then I hope you're going to learn something too. So, and this has kind of been said during the conference already, but how many times have you heard this? Our software features 0 errors and 0 warnings. Never. I've never seen a marketing ad that said that, right? Because like I said, nobody cares about that. All they care about is the selling features so they can make money, right? And they don't go around saying this because most companies can't say this. If you ask me, well, at least most companies I go to can never say this when they bring me in. And the whole purpose a lot of companies bring me in is to fix this. And so I see a lot of bad code these days, and it's quite frightening, if you ask me. So you never hear anybody say this, right? So this is what I'm going to try to wrap this conference up is talking about these things that every successful project needs to have. And I've done everything in this talk, and the reason I have had 6 very successful projects is because I do these things. And I've been doing most of these things my entire career, if not all of it. And so, like I said, things change as software development changes, but I've been doing pretty much all this my entire career. And I can't stress how important these things are. All right, so the first thing I want to talk about is architecture, because I think I've already said this during the conference. This is so lacking these days from most teams I go in and work at. It's like pulling teeth to get anybody to do architecture or do any kind of documentation these days. I don't know what happened. Like I said, I kind of blame some of it on Agile, but it's super important. So all of you developers out there, if you think this, or your manager tells you to just sit down and start coding, stop. Tell them no. We need to stop. We need to architect it. We need to document it, because a lot of those reasons that have already been talked about during this conference is why this is super, super important. I've spent months just architecting and documenting data objects, right? I spend a lot of time doing this. And, I've said this a lot, you might have heard this in this world, but if you spend most of your day coding, you are doing it wrong. You should not be spending most of your day coding. The most of your day should be doing other things like architecture, analyzing, testing. Coding should be the least part of your job, really. I know this sounds weird, but that's definitely true. So you must architect and document any project from the get-go, or feature. Even if you're adding a feature to an existing project, you need to architect it and document it. I can't stress this enough, because I've already said this, most of my successful projects were all due to doing this properly. And everyone that's been successful has done this, to some degree or another. And so, what do I mean by properly? Well, properly to me, part of that means meet with the users and understand their needs, right? I say this because I haven't heard a lot of this, but I'm one of the developers that want to talk to the users, right? I've left companies because they wouldn't let me talk to the users. Because if I don't know the user's needs, I can't improve whatever I'm trying to improve for them. And hearing it second or third party is not the same as sitting down, spending a whole day with the users. I've got many stories about this, but I've spent days with users just watching what they're doing and just understanding their current workflow or whatever they're doing, because my job for most of my career is to make somebody's workflow or life better, right? And I can't do that unless I talk to them and see what they're doing now so I can improve that. This is so important. And like I said, I've left companies because I've asked them, please send me a day with the actual people using the product. And they refused. And I said, see you later. I'll find another company who will let me do what I want. So you must meet with them, right? And then you must architect and document the project. I can't stress documentation enough. And I'm really, really frustrated that, I see so little documentation these days and even less of architecture. So all the time you spend with architecture and documentation, which will increase, the time in the beginning of the project, but you will save immense amount of time and money later in the project, right? At the last team I worked on, they worked on a project that I architected. I coded most of it. And one of the other more junior people in the team, after we had to make some, changes, improvements to it, she came back to me and said, oh my gosh, Dave, it is so easy to make changes in this code base. I go, yes, that's why I do this. I've succeeded. If it's easy to make changes and it's easy for a junior person to understand, I've succeeded, right? But this all starts with architecture. And then once you come up with the architecture, go back and talk to the users about the solution that you came up with and see if it's going to gel with their team or their company, right? Because, the one thing I love to do is whenever I go to a doctor's or dentist appointment and they always use their, software to put in your information and look at your records and things like that. Every single doctor and nurse I see do that. I ask them, so how do you like this? And they all hate it. None of them like the software. And I go, yep, that's because the people writing the software haven't come to talk to you. And so they don't know what they're doing. I'm a software engineer. I don't know how medical people do their work, right? So for me, writing software for them is kind of silly unless I understand their needs and work with them on improving it, right? I'm gonna check the private chat real quick. So, one of the most successful projects I've worked on, unfortunately, was like 20 years ago. But it was actually I was part of the original development department for proflowers.com. And, I'm not going to go into the long story. I've written about it already. But basically, the system that I architected and wrote most of it for them ended up being patented. So now I'm a patented inventor now. And it's because of what I wrote. You can go Google me and look up the invention. But I invented that along with my CTO and one other guy that helped with the coding. But, I'm so proud of this project because, not only did I become a patent inventor, which is cool, but, it doesn't make me any money. I learned a lot from this process. But, the reason I call it successful is the users loved it. Right. And even users that never used a computer before could use my application, and users that don't speak English could use my application. That's because if I make the users happy, I've succeeded. Right. That's why I'm here. Right. So this is my greatest. I have other examples, but this is the greatest one because it's patented. Sorry, I moved off of PowerPoint. So good architecture equals long living projects. Projects last a long time sometimes. I mean, there's projects written, 10, 15, 20 years ago that's still running, right? So it creates long living projects. I rarely know any team that writes a project that's only going to be around 3 months, right? So you want them long living, and architecture will give you that. But the best thing is architecture will allow you to make changes easily. Good architecture will. Less bugs and other issues, right? Who likes working on bugs? Not a single person, right? And that's why a lot of developers leave after the first release of something, because then it's just bug fixing all the time. And that's not any fun. I don't like doing bugs. I like creating features. And I like creating things out of nothing, right? That's what I love. I don't like fixing bugs. And you create projects other people talk about, like my patented invention. You want people to talk about your project and how you came up with it, or how you architected, or how your team did flow, like Woody was talking about. You want people to talk about these kind of successes, and then you can in the case of me, I turn those into talks. I turn them into articles. I put them, I put that information into my book. And so, yeah, everything. And in fact, doing this will save money in the long run. Unfortunately, too many companies in the bean counters, the accountants, don't see this. They don't see the long-term cost. They only see the immediate cost. And it's a huge problem. And most companies, especially, I said earlier, the bigger the company, the worse this is. And so this will actually save money. I guarantee it. Guarantee it. Otherwise, I'll work for you for free. I should have said that. It makes changes easier. Changes must be easy. One of the last meetings I had with vice presidents and stuff at one company, I told them, look, until you break down and do X, Y, and Z, what you're asking is either A, impossible, or B, will take so long, our competitor is going to beat us. And guess what happened? Both those things. And the product is not doing well anymore. So you must be able to make changes easily, including swapping databases, right? I know that sounds crazy, but you should be able to swap it out pretty easily. It will make you happy. When you, like what he was talking, when you're all in the zone, you're all working together, you all create something from nothing that the users love. That's the best feeling to me. It's not the money. It's not the money. It's that feeling. And you will learn and keep your job. All these things, whether, it's good or bad, you learn from them, hopefully. And, good architecture, you will learn, right? And the more you learn up front will save you a lot later. And most important of all, of architecture, this is going to create happy users. Happy users equal satisfaction to me, but in a lot of cases, it means you get to keep your job, or maybe you get a big raise, or maybe you get a big bonus, right? Your users are happy, it trickles down, right? Otherwise, you're going to be left with users like this, like all the HBO Max users from last night, right? That are all tweeting about the mistake that HBO Max did with 44 million customers yesterday. It's pretty crazy. And this is usually the way I feel when I use apps these days. And the reason I talk about this so much and with so much passion is because I hate feeling like this. I want to feel happy. And unfortunately, most apps I use make me feel like this. And so I want to improve it. And this is my way of improving it. All right, so let's move off of architecture. And now we're going to go to coding standards, near and dear to my heart, of course. Very important for the developers on your project. And we're going to be talking about that. So why are standards needed? When I do this talk in person, I ask, I ask the audience, why, if you use coding standards, why do you do that? And here's some of the reasons. Every programmer on the same page, right? One of the speakers, I don't know if it was Woody or Jason, was talking about onboarding, new coders, right? At one company I worked at, it would take 6 months before new coders would kind of understand, what the project was or what the product was. That's way too long. So if you use common standards that are out, common standards that are in my book, right? It'll be a lot easier for your programmers to understand it and read it and know exactly what's happening, right? If we all use our own way of coding and standards, it just becomes a huge mess and it's unworkable. And usually we have to spend a lot of time rewriting it. So we don't want to do that. Easier to read and understand code. Very, very important. Code needs to be readable, right? Because, the more you stare at it, trying to figure out what is wrong with it so you can fix a bug, the more money you waste. And so it must be easy to read, must be understandable. So stop using really short variable names and parameter names. We don't need to do that anymore. It's not the 90s, so make sure everything is readable in your code. Don't make, big, long method names, but, concise and to the point. Code should be self-documenting, actually, in most cases. Easier to maintain code. I always say, how many times have you've written a code, you've put it out to the public and never touched again? Yeah, 0, right? So you have to make sure you use standards to make it very, very easy to maintain code, because like I said, maintaining code, fixing bugs, all this is a drain on resources and money, and we need to make that easier. So that's where coding standards can help. And in the end, if you follow everything that, coding standards, including, of course, what's in my book, you're going to end up with stable, reliable code, right? That's what we want. We don't want bugs, right? We don't want, the bugs like we've been, experiencing here in the StreamYard today, right? So I guarantee you, coding standards will produce this for you. So I know I've plugged my book. This is not the reason I'm doing this, this section. I'm doing this section because it's super, super important. So, if you don't have coding standards at work, please go pick up a copy of my book and create your own standards. Also, you can pick up my code and app performance book too, which has got all the performance stuff in it. And like I said, because you need to have a standard, right? It needs to be written. It needs to be documented in a single place and easier for developers to get to. Most companies, 99% of the companies I go to have no standards, none at all, right? It's whatever you want to do. And that's just crazy. And it's even more important to have standards if you use contractors, right? Because contractors like me are there for a short time. So they're even worse at standards because they can, I'm going to be gone in 6 months. Who cares, right? But it's super, super important when you have contractors. In my last company, everybody got a copy of my book. Other companies I've worked at, every developer in the company got a copy of my book. And because we all need to be on the same page, right, when we're writing code. And after selecting a standard, like I said, I already said this, make it easily available to each programmer, right? It should be right. This book should be right next to your desk, unless you're me, because I wrote it. Or whatever standard you have, it needs to be, you need to have it all the time. So you make sure you're not doing anything the wrong way. And on top of that, you need to enforce it either by doing code reviews, pair programming, and you can enforce it in the build process, right? Jason was showing a lot of the analyzer stuff. There's other ways you can check your code during the build process, but if you're not checking your code for standards during the build, you need to stop and start doing it, right? Because how do you know the code is correct if you don't check it during build, right? Code reviews and pair programming will catch most of it, but not all of it. But if you include it in the build process, it will catch all of it. And don't release the code until it meets the standards. And make the developer go back. I've done this. I've even done this with the team in the Ukraine. I said, nope, not accepting this code until it passes, the coding standards testing and everything. So my big tip for this section is only change your standards on purpose. And if you do change them, document them and then teach that to the rest of the team. You just can't, tell the team, go read it as your leisure. No, you need to talk about it in a meeting or in a brown bag meeting, a brown bag lunch or something like that. You need to get the information out to all the developers, of course, depending on how large your team is, of course, or how large your department is. All right. So that's coding standards. I don't know if anybody's still watching. I don't see any comments. So unit testing and more unit testing. I can't stress unit testing enough, right? Because this is our first line of defense, basically, on fixing bugs that we've written, and or possible bugs, right? So the 100% of the projects I work on do not even come close to 75% code coverage. And the reason I bring up 75% code coverage, because when I was working with the PM at Microsoft for 2 years on IntelliCode, which Jason talked about, which why that isn't in .NET Core and .NET 5 is beyond me. I know they are supposedly working on it, but I don't know what the heck is going on. But it's completely frustrating that they haven't made this available. The Visual Studio team hasn't made this available in .NET Core and .NET 5. But when I was working with PM, that's what he said. He said 75% code coverage is like the minimum goal you should go for, right? Anything public should be 100% of any public method should be covered, right? The private methods hopefully are being covered by the public methods, but 100% of the public methods need to be covered, or don't release it, or you have problems, and that's why I'm becoming very, very stringent on the code I release in my open source projects, that anything new has to have a unit test. And we're going back, one of my friends is helping, we're going back and writing unit tests for the older stuff. Cyclomatic complexity. I don't have enough time to get into this, because I could talk about this for half an hour. But if you have something like Code Rush, you can set it up to tell you while you're writing your code the cyclomatic complexity of that method, right? And if you don't know what cyclomatic complexity is, please go look it up, because it's super important. Because what that number means is the minimum, to me, what the cyclomatic complexity number means is the minimum number of unit tests I need to write for that single method, right? And this is why I love IntelliTest, because it will basically write the scaffolding for you, because it tries to break your code. And Jason showed that. And so this is the minimum number, right? So if your method has a cyclomatic complexity, one single method of 25, that means you need 25 unit tests to test one method, right? How many? I've yet to see a method have 25 unit tests. I just don't see it, because there's, at least in .NET Core and .NET 5, there's no easy way to do that. And so we write what we think we know. Maybe we use the new testing stuff in Visual Studio tell us, but we really need the IntelliTest to help us with this. So, for example, one project I worked on a while ago, a single class, or a recent project I worked on, a single class in this project had a cyclomatic complexity. No, I'm sorry, I'm getting mixed up. This project had this project had a cyclomatic complexity of 20,675. Sorry, I'm laughing. I'm getting punch drunk. I've been up so long. But only had 249 unit tests. I'm sorry, I'm laughing. This is just unacceptable, right? So that's the number. If you see 20,000, that means you need 20,000 unit tests. And I've never seen anything have 20,000 unit tests. So you need to pay attention to your cyclomatic complexity and make sure everything's covered with unit tests. One project I worked on about 10 years ago, when we had over 1 million lines of code. And when I started at the company, it had 0 unit tests. When I left the company 4.5 years later, it had 0 unit tests, because they would never give us the time to do unit testing, because they didn't see the value. My boss, who actually took one of my classes at the university here, actually said, and it upset me, because he has taken my classes before I started working there. When I asked this, one of the first meetings at this company, I said, why don't we have any unit tests? And my boss said, well, it's okay. We'll just let QA find it. Oh, I couldn't believe it. I wanted to slap him upside the head. I'd be fired right away if I did, but I can't believe that comment. And so 4.5 years later, no unit tests. So another company I worked at, a couple of days after I started, this was a couple of years ago, they literally came up to me and said, and we had a very small team. There was 2 developers and 2 managers. That's it, right? And one of the managers came up to me, because we all worked in the same office. And he came up to me and said, Dave, we're going to give you admin access to AWS so you can push code into production. And I said, how many unit tests do you have? They said 0. I said, nope, Don't give me access. I don't want access, because I don't want to be responsible for pushing code that hasn't been tested, right? And so I said, nope. So the whole time I worked there, which turned out to be not very long, I didn't have access because I refused to do it. I let this, if the managers want to take, responsibility for, testing, pushing code that has not been tested, go for it. But I'm not going to do it. So now one of the things I always do based on some companies I've worked at, because a lot of companies won't give you the time to do unit testing, documentation, things like that. You know what? I just don't tell them anymore. I just roll that into my estimates, and that's the estimate. And I've worked at companies and they said, Dave, why are your estimates so much longer than everybody else's? I said, because of this. I roll in unit testing and documentation, and that's why my estimates are, longer. Deal with it. So, and unit tests must also include tests for encapsulation. This is what IntelliTest did. You must test encapsulation 100%. I've said many, many times before that I rarely see code that does even encapsulation correctly. And if I see code that doesn't do encapsulation correctly, then I have little hope they're doing inheritance correctly, and I have zero hope they're doing polymorphism correctly. So we got to get encapsulation right. And, I've said in conferences before that if every developer out there did proper encapsulation, I would stop speaking. I promise. So that hasn't happened. So I'm still speaking. Test business logic, like Jason said. Not only do you have to test 100% of the encapsulation, but you need to also roll in your business logic testing too. And you must use random data as input. Too many people, test data with known values that they know work, right? Wrong. You don't do that, because that will cause problems. I guarantee it. And that's actually why, I created an open source project on the NuGet package that you can go see that it does this. The whole purpose of this project is to create random data, classes, collections, all these kind of things for you. I use it in everything I do now because it helps me test this kind of information with completely random data, right? Which will break code. I know there's a lot of database people out there, and they test their code, it works fine, and then one of your users has a last name that has an apostrophe in it, right? Breaks the query, right? This is what I'm talking about. And your unit test must, because a lot of teams are or should be moving to continuous integration, and you really need to think about how you're doing your unit test and doing stuff like this, because it has to run in GitHub, right, or some other system, right? So your unit test must be reproducible in continuous integration builds, right? Because otherwise it won't work. And this is actually something I'm going through right now with my open source project, is I've tested everything myself and everything works great. But when you put it into CI builds, some of it starts falling down, and I've had to go back and rewrite some of my unit tests. So my tip for this section is do not ever commit code that doesn't pass 100% of the unit tests. So, if some developer checks in code and they haven't run the unit test locally, you need to, give them a red flag or some, I don't know what it's called, but you please don't check in code if you haven't run a unit test. That's what they're there for, right? Just don't, I changed this one little thing, it'll be fine, I'll just commit it, commit it to the main branch. No, run a unit test first. And this is where, of course, continuous integration can help. All right, what's next? Continuous integration. Tom's still watching, so I know the one person is watching my keynote. So continuous integration in software engineering basically, to me, just means that everything's being built in the cloud somewhere and you're running your unit tests, right? Every check-in creates, every commit to the branch creates a build, and then hopefully that build's also running a unit test, because you need to find out right away there's a problem, right? So the developer can go fix it right away. I've been on teams where I basically have been dead in the water for a day because some beginner, checked in code that wasn't tested, breaks the build, and we're all sitting around going, yeah, there's not much I can do until the build's fixed, right? So this is really where in continuous integration, it's just this loop of test, build, release, source control, developer, reporting. This has to happen on every commit to the branches, right? Because this is how you find out the issues right away. And like Woody was saying, you need to find the issues out immediately, not days later or hours later even, right? Because it can be catastrophic sometimes. So some of the common practices, I'm going to go through this kind of quick because I know I'm short on time. So maintaining a single source repository, of course, automate the build, super, super important. Every commit should create a build, which is easy to do in GitHub. And make sure build self-testing, very, very important, right? Because I think, I forget if it was Jason or what he said it, that, most of the stuff should be automated. The manual days of doing this is gone, and we need to automate this. And this is how continuous integration helps. And, I'm really happy that, at least the team at GitHub is continuously, making this process better for us. I'm not in love with these YAML files and stuff, but, at least, they are making things better for us. Commit to the main line every day. Every commit should build the machine on an integration machine or, however you're doing it. But, it needs to be built on a clean machine. And that's one thing I really like about like building in GitHub is that you're basically creating a brand new instance from scratch every time you do a build. And so that will, using continuous integration will really uncover some issues with your code just by doing a continuous integration. So if your project isn't in there, be prepared. Once you start trying to do this, it's going to create some work on you. And this helps you fix broken builds immediately because, like I said, this can waste hours of time and, and that can really add up time, not only, loss of features, but it can be very costly. You keep the builds fast, of course. You can test and clone a production environment. That's a lot harder to set up, especially in the cloud, but you need to do this. Environments, I'm going to be talking about environments next, but, they must be easily reproducible, hopefully by just running a script. And it makes everybody, easy to get the latest executable and everybody sees what's happening. All this stuff is reported so you can see what's happening and, your boss can see what's going on and see who's breaking a build and give them a ding at the end of the week, I guess. I don't know. And of course, if you go into the automatic deployment, you can do that too. I haven't really done this too much yet because I don't know, I'm old school and I'm afraid of just letting it happen automatically without somebody saying, okay. But this can be important for certain things too. And like I said, doing this will uncover many issues with the code and projects. And every team I work on and help set up their continuous integration, that's exactly what happens. We have to spend quite a bit of time usually fixing the code so it'll work, it will work in continuous integration. Because it always works on my machine. Well, with continuous integration, you don't have your machine anymore. It's created for you on every build. All right. So that's enough about continuous integration. Next is application testing. I know we've had a lot of talk about testing during the conference. So again, I'm going to try to go through this pretty quick. But, anything before it's released to UAT or production has to have end-to-end testing, right? That's all there is to it. This must be done before the release, right? And things are better these days as opposed to a bunch of people all sitting in one room trying to do it all together. A lot of this can be automated, thankfully now from the old days. But this has to be done with every release. And you can't just you just can't change one little bit of code and put it out. It has to go through testing. Once any code is tested, it starts the whole, cycle over again about testing, building testing, user acceptance testing, all that kind of stuff. And this includes all layers. I'm calling this out because it doesn't matter what layer you're on, whether it's the UI, communications database, or whatever. Everything needs to be tested before you do a major release. And of course, I've said this over and over again, automate as much as possible. There's tons of tools out there. If you hire the right QA people who really love doing this automation, they're worth every penny. I've worked on a couple teams where, I've had a really, really good QA automation person, and man, those people that really know how to do that well are very, very valuable. And of course, regression testing. Regression testing is rerunning functional and non-functional tests to ensure the previous developed software still performs like it did, right? So again, before any major release, you need to do regression testing. Make sure you didn't screw something up. I don't think very many companies do this anymore because, one version something works and the next version something doesn't work. And I'm talking to you, Visual Studio, and other applications out there too. And so this is why regression testing is super, super important to catch these things. And developers should never participate in this kind of testing, right? We are not part of this. I mean, the actual testing part. We can help them out with issues and things like that, but we should not be testing our code like this. The way we test our code is unit testing. Everything else is done by somebody else because we're the worst people to test it because we know how it works. So we are the worst people to test code like this. So make sure you have a great QA team available to do this, right? And a very knowledgeable team and knowledgeable about the project. And I'm going to keep talking about documentation, but this is why documentation is important because how can the QA people test it if it's not documented? Are they just supposed to guess how it's supposed to work, right? There's no feature requirements. There's no architecture. There's no documentation. How are they supposed to test it? Please tell me. I don't get it. All right. Next, proper environments. I'm talking to the choir here, hopefully, but I do want to quickly go over proper environments because especially the last company I worked at, this was a nightmare. So you must have multiple testing environments for your code, right? And of course, there's the dev environment, and that's just for developers, only for developers. And this is where we can test something on in the cloud or in the server or something like that. I'm not talking about our local box. I'm talking about a dev box. That's, of course, all these environments should be near to production as possible, right? Even the dev box. And so depending on the project, you need to at least have dev, QA, and production. And for larger projects and larger teams, you can also have staging and UAT, and we'll go over those, right? But the one thing I do want to point out, and I know this is pretty easy to do in Azure, is a lot of teams, what they do is they do separate builds. They do a dev build, they do a QA build, they do staging build, and they do a production build. This is really the wrong way to do it, if you ask me, because everything QA and above should be released, right? The release type of build. And so the right way to move your code is to move them from environment to environment, not a completely separate build, right? So the QA build, when that's been accepted, should move to the staging UAT environment, right? The exact same code, right? You might have to change the configuration, but the exact same code should move from QA to staging, right? And then once that's accepted, then that's moved to production, right? You don't go from dev to production, right? You use the exact same code build in these different environments, right? And it's super important to do this. And like I said, I know this is pretty easy to do on Azure. I don't know about AWS, but I know it's pretty easy to do on Azure. So the minimum proper environments, of course, the dev environment, I just talked about this, only used by developers because we're always screwing things up and trying things. And, we don't want to block QA and the other teams by our screwing around with stuff. So, and of course, this will also, this will also, what was I going to say? I don't know. Somebody's comment threw me off base. But so this is only for developers, but it has to be, not your local box. It has to be something, in the cloud or a server somewhere else. Of course, then, after the dev environment comes the QA environment to be used only by the quality assurance team, right? This is where they start doing their testing, their automated testing, all these kind of things, right? Is the QA environment. And we and developers should have no access to any environment except for dev, right? QA, UAT, and production, should have zero access to. That's the access for DevOps people. So next is QA, of course. I know a lot of people, already know about QA. Super important to get some good QA people and teams in there. And then, of course, after that comes the UAT or staging environment. And this is where not only the QA people can test, but this is where your top users can start testing too. So they can look at it, so they can, give their okay, before it moves into production, right? Because you want to get the users involved. And so, because we're not the users, right? The users are the users. We're the worst people to test this stuff because we know how it works, right? We need to have the people that don't know how it works necessarily on to test it. And so that's why the UAT environment is super important. And then, of course, comes production, the final environment. And like I said, engineers should have no access to production at all. And that should only be done by the DevOps people. But the one caveat that I ran into with the last company I worked for is, the problem was, we had logging, so we could find, so we could log the errors and issues and stuff like that. But we had no access to the logs because it was all stored on a server and they wouldn't give us access. So every time I needed access to the log, I had to tell somebody on the team, and they had to contact somebody, in DevOps, and then we had to wait around for a while or a day or more even to get access to a log. And how can we fix things like that in production? It doesn't work. So, make sure you have your logs in the cloud somewhere. Yeah, in all environments. So make sure the logs are easily available to everybody, but especially dev people, right? There's lots of systems out there, Application Insights, Raygun. There's all kinds of systems out there, and it must be web-based so we can easily get to them no matter where we are. But yeah, I could never get access to the production logs. So how am I supposed to fix anything? Kind of crazy. And of course, all environments must be easily reproducible. This is really important and will take some time depending on what you're doing. Is you should basically be able to stand up an entire new environment from scratch by running a script, right? Because doing this manually, like they did at my last job, can take weeks. I'm serious. And so then we can't test, and then we can't let things move. And it was a nightmare. So this must be easily reproducible. Back in the old days, back in the 90s, we would rebuild machines entirely every night. That's how we did it. And but now we have the cloud, and it's a lot easier. And the last thing I want to talk about is something very important. I think Jason talked some about this, and that's profiling, right? Very important, but rarely done. And so memory profiling is basically, using a memory profile against running code, in near production environment as you can, right? And because, I can tell, we can talk until we blue in the face that this is the right way you should code. This is the right way you should do iDisposable. This is the right way you should do arrays. We can talk about all that and you can implement it, but the real way to find out really what's happening is running a memory profiler against running code. And like I said, you don't run it on production because it really will slow down production, but you need to have it running on near to production code as possible. And you need to have people use the app or however the app is used and run the memory profiler against it. And it gathers all kinds of information. Application Insights actually gathers a lot of this information. But this is what we do locally. Developers do before we release it to, QA or user acceptance testing. And this is the only way to find the last bit of memory issues, pinned objects, disposable issues. I even found a bug in one of the HTTP classes from Microsoft that I had to report to them because there was a constant problem happening in one of their types, and I had to tell them to work on it. But I found it, and so this is why this is super important. And 100% of the companies I work for don't do this at all, right? I've never walked into a company and saw a company do this ever in my life. And so when I get there, of course, I do that. But even one company, I said, okay, well, we're close to, release, so I'm going to do some memory profiling. And they said, no, we're not going to pay you for that. Oh, how can I guarantee good code quality if I can't run a memory profile against it? So, I've tried a lot of the memory profilers out there. And the one I like the best actually is called the .NET Memory Profiler from SciTech Software. It's relatively, because memory profilers can be very, very expensive, and but this one is not expensive, and it will pay for itself the very first time you use it. I think it's only like $250 US, and the first time you use it, it'll pay for itself. I guarantee it. And I use this not enough, unfortunately, in open source projects, but I do try to use it as much as I can. And this is a screen grab from that product, and it will show you all the things you need to, go look at. And you can drill down into the actual type, that actually is causing whatever the problem is. And you can actually, depending what you have turned on, you can actually see what values were in that type when that happened, right? So much valuable information that memory profilers give you. The one caveat, the one thing I should say is not every developer needs this, right? Most teams, you only need one developer that needs a license to this, because memory profiling is very time consuming, and you really have to know what you're looking at. So you know how to drill in and go in and look at things. But it's very time consuming. So if you do this, make sure you don't do it at the very end. You need to start before the end of the project, because this can be very time consuming. Going through everything that it produces, depending how long the profile was, it is very time consuming. So all of you companies out there that are afraid to, pony up $250 for every one of your developers, you don't need that. You just need like one or two developers that have a license. So I think everyone should, but you can get away with one or two. So if anybody listens to my words and actually starts doing memory profiling, please let me know. I'd love to know your experience. And go check out .NET Memory Profiler from SciTech Software. I think my mouth is starting to screw up because I've been up so long and talking so much today. So let's do some summary to wrap this up. I know everybody, I think Simon and I are the only ones here for the whole time, but I don't know about you, but I'm really tired. I know Simon probably wants to go to bed. So summary, architecture, and documentation, all these things are very, very important. Coding standards, of course, unit testing, continuous integration, application testing, regression testing, proper environments, and of course, profiling. Every project needs this. I don't care what kind of project it is, it needs these things. Because in the end, you'll not only come up with better products, but your developers will be happier. You can be proud of your project, and that's what it's all about. We want to be proud of our work and be happy where we work and happy with the team. And this is one of the things that helps do that, right? Because if the users are happy, everybody will be happy. I guarantee it. And as I'm talking about this, if your team needs help in any of these things and even more, please contact me, and I can help your team out. This is what I do. I go into teams and fix their stuff. I was going to say crap, but fix their stuff, right? So please, you can email me or you can tweet at me, and I'm more than happy to help your team out. And because this is what I do most of the time these days, and code quality and performance is, really what I'm focused on. these days, and because I really like helping these things out, because like I said, I have a motive, and that's what the products I use, I want to like, right? And that's not happening much anymore. So this is why all these things and even more, and everything that has been talked about in this conference is very, very important to listen to and do, so we could have a good life and go to the beach, right? The sun's kind of out today. I could go to the beach after this if I wanted to. So don't forget to pick up a copy of my coding standards book or my code performance book, especially my coding standards book. If you don't have a standard, get a copy and start there and create your own standard, or just use mine. If you want me to add something to it, let me know. I'll put it in. I'm always working on the next version. I put out a edition at the beginning of this year. I really don't plan to put one out probably till next year, because I'm working on the code performance book right now. But if you don't have standards, you need to. And of course, my book is a great start to do that. And so thanks for attending the conference. Thanks for, listening to me at the very end of this and listening to the keynote. I know I put this at the very end, but I put it, I did on purpose, because I kind of wanted to wrap everything up that happened at the conference into this keynote. And so I hope you all found it useful. Thanks. So Simon, what's next? Is it over?
Yeah, looks like.
Okay, Mahesh isn't here. We're not going to wrap it up with Mahesh or something?
He's not here, David.
Okay. Well, I want to let Simon go to bed, so let's stop the conference. Go get some coffee. Go get a drink at happy hour. And, Monday when you get to work, let's work on these things. All right. Thank you.
20 years ago, a seed was planted and cared for. We painstakingly nurtured it and weathered it against adversity until one day it blossomed and the fruits of our labor began to show. Today, millions have learned, shared, and been inspired by what our community has produced. We proudly served 21 million users from 204 countries in 2019. For our 85,000 technical articles, code samples, and videos, our 450,000 forum questions, and our highly anticipated conferences and events featuring keynote panels, live streams, and industry experts and influencers, we recognize and reward members for their dedication to the community. Through content contributions and mentorships, we ranked number 2,620 in the world with a reach of millions across our social media channels. Thanks to you, our global community of software and data developers grows stronger each day. For more information, visit us at csharpcorner.com.